Good morning, good afternoon, or good evening where you are. And welcome to the DevSecOps Days DC 2022 events. So DevSecOps Days is a really great opportunity for all of us to learn what we are doing it. And now I'm really happy to announce the DevSecOps Days DC event, which is the last DevSecOps Days event in 2022. So before really diving to today's discussion, I would like to give some background information. What is DevSecOps Days? What is our purpose? How we started? What we are trying to get out of this a great session today. So we have great speakers, great exchange, great participants as well. So DevSecOps Days is really a community event that started almost 5 years ago as the group of volunteer people all over and talk with the practitioner, talk with other implementer, or hearing different stories and different perspective. Maybe some of them are tool-related configuration, maybe some of them are different stories. So DevSecOps community event is really getting people together, share those knowledge, share their experience, share those kind of learning pieces. Why is important? Because DevOps is really based on the sharing, based on the common learning. This is an opportunity for all of us to learn, to exchange information. Then we can build up the culture. Then we can build up the good elements or good security practices along all the practitioners. That's the real purpose of DevSecOps Days events. If you get more information for the past events, for any other recording that has been done this year and previous years, you can go to devsecopsdays.com and then take a look at those videos or the blog posts, any other type of write-ups. On top of that, if you really would like to be part of this community event, please let us know so we can help you to facilitate those conversations in your community. Again, this is a community event, as I said, and I wish we had been in person to get together the local community members. We can talk about more. And we are hoping to have an in-person event in DC next year and following years as well, because in person, it really makes a great connection with the local community members. So what are really going to cover up today? And we really would like you to be part of our YouTube channel, and this is going to be kind of broadcast already through the YouTube channel. Please get in the YouTube channel, ask those questions to the participant. This is a live sessions, and we have all the speakers will be ready to respond to the question. We're trying to get you as much as you engage with the speakers, plus with other audience, other participants. Remember, this is an opportunity for you to share the knowledge between your peers, your stakeholders, and we can really improve the security culture amongst each others. So as I said, you can go to the YouTube channel and those questions or the speakers, and I'll keep moderating, or moderators will look in those questions. We'll ask direct to the speakers and you can hear them as live. If you're not really following at the kind of sessions, you can really ask emails and send email to the info@sci.edu, or you can send email to me, or you can contact any other speakers or team members as well. We're happy to help you or learn from your stories. At the same time, try to respond your questions and try to be engaged with you as together. I'm really encouraging all of you, please engage with us through the YouTube channel so we can have a more interactive session. I know it's very hard, but let's try our best, and let's try to really get connection with the community members. So what are we going to cover up today? So as I said, we have a great speakers. Now we launched the day, and we have a keynote speakers, and from Kyle Fox is going to talk about his experience. We're going to talk about OWASP and then use secret for the OWASP script. So we're going to talk about on the topics, and we will dive into the more products, and we're going to talk about the cultural elements until noon. So after noon, we're going to continue our session with the great keynote speakers from DJ Schleen, and he's going to talk about the really SBOM. We're going to talk about a lot on that topic after noon as the software battle of monkeys. I know we are talking a lot on SBOM. We can open up really what is the underhood of the software bill of materials with DJ. And afternoon, we'll continue a great speakers as well. We're going to touch again the culture pieces. We'll talk about the software supply chain from Chris, and we're going to talk about the minimum viable security. We will end up a day around 4 p.m. That's our goal. It's really a lengthy day, seems, but I really enjoy listening all these great speakers. And plus, I would like to hear from each of you for your experience as well. And then based on what you're hearing, what things that you may be struggling, maybe what the problem that you have. So quick introduction, and it's me. I have been doing the technical director role at SEI, and I have been supporting many Department of Defense organizations. I'm a joint faculty member. I'm a community sponsors. I am here really to help the community. That's my mission. That's my purpose. That's my focus. To increase the community with respect to awareness of software building systems with a high quality, with a high security, reliable systems, and DevSecOps is one of them. As I said, we have a great keynote speakers today, and Kyle Fox will be our first keynote speakers. And Kyle, I know him for a while, and Kyle is the front runner and DevSecOps in the Department of Defense, and he has done a great work with the mini division of the Air Force, and he really created a great concept of the DevSecOps in a very highly regulated environment. He's going to talk about a lot on this in his journey, so I'm going to introduce him a lot down the road. We have another great speakers and good friend of mine as DJ Schleen, and he is kind of a community advocate person. He likes to talk in an adversarial way, but he's really giving it a lot of idea what is really not working well. Everybody's talking about the great stories, and DJ is going to talk about what is not working. Let's correct those, be open, be discussed, be sharing with the community member, and DJ is one of them as the community speakers and also our keynote speakers today. As I said, we have many other great speakers throughout the day. We have Alex and from group head of the DevOps, and we have Mark and Hahn and from TCP Technologies, and another great speakers, Chris Hughes, and he was one of the speakers at the past as well. I really would like to hear those speakers on their perspective with the security, with the software supply chain, and plus the cultural element. As we are going towards today, so we can wrap up another great speakers this afternoon. And Vishay and Jason and Joel and Jeroen will be our speakers and talking about their experience and how they are doing the DevSecOps in their organizations, from cultural to the minimum viable security, from the software supply chain perspective. So you will see a lot of great stories on how they are doing it, how they are facing with some problems in their organizations, how they are overcoming those problems. It's really, as I said, it's really key point to learn each other from the speakers. And as we are going throughout the day, so we have a great moderators as well. And I would like to thank Jeff and Doug, and they will be supporting as a moderators, which is looking for the questions and be sure that we are going aligned together. And we'll be supporting as a team events. Again, thank you for both Jeff and Doug for their support. As moving forward, and really I would like to announce another great event. It's coming on November 10th, which is another great community event, which is All Day DevOps. If you're really looking for a 24-hour length of the conversation on DevOps, please join the All Day DevOps will be on November 10th. It's going to be a 7th annual All Day DevOps conference. It will be at 24 hours, no kidding, 24 hours. So we're going to start early in the morning in Eastern time. We're going to continue 24 hours. You have a constant DevOps talks and DevSecOps or SREs, many other topics we'll be covering under DevOps. I'm glad to announce that we are the sponsors of that event last 7 years. And I see a lot of benefits, even though I use some of the talk sessions through my class at the CMU as the lesson learned and experience on how people are doing it for the implementation perspective, for SREs, for many other topics as well. I really encourage you to register. It's a free event, by the way. Then you can get more engaged with the communities. If you get more information, I would like to share those URLs, and you can get more DevOps perspective, DevSecOps to the SEI website. And we have been publishing the many lesson stories about our lesson learned and our stories and our information that we captured. And also we are sharing a free information for the communities. And this is really important to increase our community awareness on DevOps and DevSecOps. As a team together, we are in this world. Just going to share one note why it's important to share those information with the community. And statistically, we have about 27 million software developers in the world. And we are 5 billion people living in the world, right? Roughly 27 million of software developers. And we are very limited with respect to security knowledge out of 27 million developers. Think about that load. It's important to share this information. Please look at those websites, either the podcast or the blog post, or any type of information you will gather and more of the DevOps and DevSecOps concept. And lastly, I would like to thank our sponsors, and from the Highmark Health as a community sponsors, and Aqua and Security Compass and Sonotype. They're really helping the community grow and sharing information among their teams, and as well as supporting community event. It's I'm really thankful to those participants and also the sponsor for supporting us. And lastly, if you have any questions, please reach out to me directly and ask those questions for your lesson learned. Maybe you would like to share. Maybe you would like to learn more about it. Maybe you have some challenges. Please reach out to us, either me at Hasan Yasar, hs@sei.edu, or you can through the LinkedIn, or you can access to the SEI resources. Use any sources, any materials get back to us. So we're really happy to talk in those journeys in your environment. Without further ado, really, I would like to introduce the Kyle Fox. As I said, the Kyle Fox, I know him for a while. He has been a great supporter for the community. And Kyle is really different perspective that he look at the DevOps. And I remember the first conversation I was talking with Kyle about the DevOps journey that he was trying to set up in his organizations. Like I said, it is not going to work every time when we talk about the hardware, when we talk about the very high regular environment. Kyle is going to talk about the really great topics on software-defined weapon systems today. And he's going to share his lesson learned. He's going to share his topics about what he's done, what he has done in his environments. So as I said, Kyle is the key voice for the Department of Defense Software Innovation, and Kyle Fox is the Chief Software Officer and Technical Lead for the research and development efforts, the U.S. Air Force Nuclear Weapon Center ICBM Modernization Program. So without further ado, I would like to hand over to you, Kyle, and I would like to hear your journey and your stories.
Excellent. Well, great intro, Hasan. Quick, give me slide share and I'll put some slides up. Great. Okay. There we go. Okay, everybody. Well, so thank you, Hasan. Thanks, everybody. I'm really excited to be here. Hasan, great intro. So just a little bit more about me. Definitely an interesting role. So like Hasan mentioned, last 7 years or so, I was in the Sentinel program office. For those that aren't familiar, it's the new Minuteman III ICBM replacement program. So we're re-looking at the ground-based deterrence for America. And this was a unique program in that it was an actual greenfield, right? Something where it was a blank slate look at how we provide that aspect of deterrence for America. And we were able to take that and really take a look at, and I'll talk about more of this in a second, but look at where these systems are going over time and understand the nature of how these systems will have to evolve. And so because of that, we were able to adopt more modern software practices. We lean very heavily on Hasan's team and other community experts that are online right now. But it was an amazing journey because we worked directly with industry partners, with defense industry, and with our policy folks inside of DoD. And we drove out a system that really was a pathfinder for use of these technologies in an extremely high assurance environment. Now, the other thing I'll say is similar to Hasan, like I'm very much here for the community. The new role that I'm in is one that's really meant to unify a lot of the efforts that are going on across DoD. The big thing that we're trying to do is show that a lot of these systems that are being built today really have kind of the same struggles, both the same advantages and the same areas that we're working together. Also true of commercial systems, right? DoD now and these modern systems are looking much more similar to commercial facing systems. So I'll walk through that through the talk, and at the end, it will be kind of like a rally on let's partner together and solve this together because we have to, right? For us to provide foundational national security and continue the American way of life, we really want to be, DoD wants to be easy to do business with and be actually supporting in a very meaningful way software development and open source software and other related engineering activities. Okay. So why do we do DevOps? Well, why is all this change happening, and why aren't we just doing what we've always done? So it's been said that we live in exponential times. And so by that, just a couple of fun facts. Landlines and adoption rate of having phones in the average American house really took over 50 years. You think about that. Smartphones, right? Slightly different rollout, but now we're looking at less than 20 years to hit 50% saturation of American homes. If you start looking at the adoption of from 3G to 4G to 5G, that rate is shrinking and shrinking and shrinking. On the same size data, like data is another interesting way of looking at this. It's been said that up to 2020, that humanity has produced something on the order of 64 zettabytes of data. And that by 2025, we'll have produced over 460 exabytes of data. And to put that in perspective, roughly 5 exabytes is every word ever spoken by every human that's ever lived. And it just blows my mind. I mean, you think about how fast technology is being provided now to, and similarly, everybody else that's contributing to this, whether they're adversaries, et cetera. It's just amazing the pace at which technology is changing. So I mentioned adversaries. I mean, to echo that, we're also seeing the evolution of the way that systems are designed to take advantage of each other is also rapidly increasing. Classic one, if you look at critical vulnerability enumeration, CVEs. In 2010, there were roughly 15,000 unique CVEs, and it is something of an exponential curve. It's projected that by 2029, we'll have over 1 million CVEs annually. It's amazing, again, just the pace that this stuff is happening is incredible, and it's ever increasing. The other thing that's changing here is the sophistication of the way that systems are being compromised. As our systems in general are gaining in complexity, so are the ways that we can compromise these systems. Now we're looking at not just attacking the end system, but every aspect of the delivery chain, from early dependencies to the way that we actually perform deliveries to all of the folks that are engaged with anything that adds value along the way. Anytime something has changed, there's an opportunity to do an adversarial action. So I'm excited about the rest of the supply chain talks today, because yes, we do need to move faster with these systems, but we need to have zero compromise on the defense systems with system safety, security, and effectiveness. And also, I mean, commercial systems as well. We would all like to have more sophisticated aircraft or commercial infrastructure that we interact with, but no one's excited about an unsafe plane and losing consumer confidence. So how do we go about that? We're recognizing that one of the main things that systems need to focus on these days is delivery. Delivery and that ability to incorporate learning for the length of a system is really the thing that determines if it's successful in the market or successful in the battle space. So by recognizing this and understanding how we need to prep for the future fight, we've really had to start to think about holistically, how are we designing the systems? How are we focusing on the supply chain, or focusing on the delivery mechanisms and all attributes of that? So how do we go fast? Like I mentioned, delivery. There's kind of like, yeah. I like to just, again, like focus teams in on this. So there's three main things that I'll touch on here. One is architecting for speed. So this is being really meaningful, intentional in the way that we build our systems. The second is making sure that we organize our teams and our processes around delivery and accelerating delivery, reducing burden of delivery. And then last, we look at all of the things we can do to build automated bodies of evidence and things to optimize the way that we, again, have that equal footing on a risk posture as we learn things along the way, keeping everybody on the same page. And there's a lot of really exciting tools and techniques that are coming out in modern software that talk about that. Okay. Architecting for speed. So really, really exciting things have happened over the past 2 decades in software engineering, particularly in the past 10 years. So just a quick tour of this, top left there. So we used to build systems, and we still do for some areas that are very monolithic. That means that we have software where you have to have any change, you have to change basically everything. That software was also tightly coupled with the hardware, and that hardware was typically very mission specific, very custom. And so we started to see these trends of abstracting the hardware and software from each other, variety of techniques, and further breaking down the software so that we can modify only a bit of it without breaking the rest of it. As we go down to where we're starting to move into, now we're getting into this really exciting space where we're starting to see techniques like microservices, where we can, with really great intent and almost like a scalpel, come in and change a very small piece of that system, yet not impact the rest of it. Now, same with the hardware as well. We're seeing this big trend of moving away from very specific hardware, even in these defensive systems, to something that's using more of generic compute that's shared across platforms. So that's really exciting because we're seeing the utility now being driven out of hardware and almost exclusively into that software layer. And I'll end on this, but it's getting to be this era of this software-defined weapon where really all of the warfighting utility is effectively provided by software. And that's just amazing if you think about it, right? We're providing these pliable, flexible systems out to the warfighters that can accommodate change gracefully, given all the other delivery mechanisms, but our systems are being built around that. Last thing I'll mention on architecture. So we do talk a lot about, kind of changing features in software, but it's also important to think about these cyber physical systems and the environments they're serving in and the missions they're serving in. So some of these are system safety kind of things, they may injure humans. Some of these are weapons that we talk about in DoD that, we want them to put effects on bad guys, not good guys. So for those systems, we need to be very intentional in the way that we separate the very critical things, the human safety things, nuclear surety things, away from the things that are providing, general functionality, so that we can alter our investments and we can really spend that resource, that extra IV&D work, etc., on the most sensitive part, but allow those kind of other areas that are less impactful, or at least less high assurance, to move a little bit more quickly with lower levels of assurance. Okay. Next is delivering around value. So on the left there, this is the classic DoD acquisition approach. There are some couple challenges with this when it comes to software-based products. First, this system is really built for doing large acquisitions that have a lot of capital investment. So think about every decade or so buying a new tank or a brand new plane, something like that. The problem with software is that this is completely oppositional to how software functions. Software is about more on the right. You quickly drive to a minimum viable product and then rapidly iterate on that. Now, what we're seeing again, the shift, right, from very monolithic software, very custom hardware, to now very modular software sitting on top of general compute, is we're seeing a big shift in DoD from the left to the right. Now, this extends far beyond just software development teams. This includes everybody along that value chain for delivery. So think about this, the way that you establish your program, the way that you set up funding for your program, the contracts that you set up, your vendor agreements, the way that those vendors collaborate with your end user, warfighter, the way that you do certification, the way that you train when you release the software, all of that is now going through great change inside of the DoD. And this isn't unique just in DoD. We're seeing similar changes inside of commercial spaces. In more IT-facing areas, this has happened a while ago, right? And this is just how we do business. But you start to look at more of the system safety things, think aircraft, think subways, things like that. We're starting to see this applied as well. SpaceX is a great example of this, moving away from what was a traditional NASA process where they would have very long code freezes before they would do deployments, to flipping the script and now allowing that learning all the way up to launch. It's been an incredible experience both for SpaceX and NASA. There's lots of great videos that talk through just how valuable it was for both teams to understand how valuable that learning is and allow that learning to take place through as much of the life cycle as possible. Sorry.
Good morning,
Yeah.
good afternoon, or good evening where you are.
The other aspect of
Welcome
going
to
fast,
DevSecOps Days,
two
DC
parts.
2022
First
event.
is shifting to this idea
So
of
DevSecOps Days
going
is
to an
really
integrated
great opportunity for all
mission-oriented
of us to
risk.
learn what we are doing.
A lot of
and now
words.
I'm
What does that
really
mean?
happy to announce the DevSecOps
If you think about
Days
who has a
DC
say
event, which
and
the
is
last
a system
DevSecOps
safe,
Days event in
secure, and
2022,
effective,
2022.
in
So before
DoD,
really
there's
diving
sort
into
of these
today's
three
discussion,
circles,
I
and
would
commercial
like to give
systems are
some
two
background
different.
information.
But to give an
What is
idea, on the
DevSecOps Days?
top
What
left
is our
there is nuclear
purpose?
surety.
How we
So
started?
from nuclear
What we are trying to
systems,
get out of
they're
this
definitely unique.
a
In that they
great
provide
session today.
deterrence
So
and
we
they're
have great
weapons that are
speakers,
different
great
than the
exchange,
rest of
great
the U.S.
participants
arsenal.
as well.
So there are unique
So
requirements and
DevSecOps
investments
is
that
really
go
a
above and
community
beyond
event
traditional systems.
that
Again,
started
because these
almost
systems
5 years
so
ago as the
unique.
group of
So you'll see
volunteer
there's
people all
again
around the world.
additional
We ended up
teams that are
really
brought in
talking
for doing
about
kind of
what
checks.
is the security
There's things that we
means
look
in
at
the DevOps
specifically that are
context.
slightly
I
different
know
than
that we
what
have
a
been
normal
talking
weapon
DevOps
system
in
would
every
go through, let alone
platform.
a
Every
commercial system.
organization does DevOps.
Top right
So they're
there,
getting a lot
lots
of
of folks are familiar
benefits.
with
But
cybersecurity.
we often start
This
to ignore
team actually has
or
been
by
thinking about
intention or somehow
processes like
we really
continuous
drop the
ATO for a
security
while
as a
now.
community.
They're
Now,
really
DevSecOps Days is
where
really
a lot of these
focusing on
organizations are starting to
adding
lean
the
on
security
with
into the
their
DevOps
journey
activities,
from
into the any
more of
software
a
engineering
waterfall serial
activities,
delivery
to
process now
share
to
amongst other
this
community members.
risk-based process where you establish guardrails essentially. And if you can demonstrate you're operating within guardrails, you have a very fast opportunity to go to fielding. On the bottom, system safety, an amazing community. They're ones that keep everybody safe. if you look at the amount of standards that they apply, it's something like 50,000 plus requirements that you get from MIL Standard 517. But those are by intention, right? I mean, we have things that can injure humans, and so we have to take special care with that. Commercial systems have a similar type of arrangement, a huge number of requirements. So then how do we navigate this? The best thing to do is to take all of these communities and make sure that they're not operating in silos, but work for alignment. So one of the first things that's important to do is establish some sort of common way of describing what criticality means in your system, how you're producing a body of evidence to satisfy each of those communities with their equities, and then show how that system continually meets those standards. So one approach we're starting to see across DoD, especially for the very high assurance systems, so these are the weapon systems, anything that involves airworthiness, things that involve nuclear surety, are starting to trend towards this DO 178C approach. Now, it's definitely not prescriptive. We're not saying that all systems will use 178C, but just pulling the thread. It's a way to bring everybody into like a common understanding of how to think about when something is very critical, how to start to apply stealing from cyber controls against that concern, and having a body of evidence via a plan, software, aspects of certification, and mirror a level of rigor table that kind of keeps everybody on the same page. What gets exciting about this is when you start pairing this with DevSecOps techniques. And so you're able to take the tools now that are able to, again, like operate underneath a certain risk agreement, do the hardening, the testing, the demonstration that we're meeting that standard, and provide it in a way that that authorizing official has like very clear visibility, and they're engaged in that process through the entire delivery stream, all the way up to production, by the way, which is unfortunately kind of forgotten in high assurance systems. So by bringing this alignment with the standards, by starting to lean on the tools to generate automated bodies of evidence, and also by doing some of the maybe less sexy things like automating the process using tools like Jira and other service desk kind of products like that, we're able to really keep that learning unified across stakeholders, right? So it goes much beyond just the software developers and maybe their system integrators, but similar to the IT journey of a number of years ago when we went from siloed IT to DevSecOps, it's expanding that sec to think about all of the folks that are involved with delivery. So part two, the shift left and shift right. So shift left and shift right, remember, we're talking about more than software for many of these systems for delivering utility. So shift left goes all the way up to ideation of the system, now starting to engage with your requirements folks, the users, et cetera, what the system needs to do, ensuring that the system is built to those architectural best principles so that they can operate in that environment that they need to, that they understand the changes that are going to be asked from them, and their system is built to accommodate that. And then as we start to go through the delivery, that we really pay attention to what level of assurance these systems are, and we have the infrastructure in place to satisfy that, dragging all the way out to delivery and operation. So one thing that we have, current state of DevOps in the department right now, we're seeing a lot of success with delivery into sort of a laboratory environment, hardware in the loop facilities, things like that. The latest programs are showing a lot of success there, and it's been great. We've de-emphasized traditional milestones, which were, hey, let's go build all of our engineering artifacts, then we'll go to test, then we'll go to fielding. So that's starting to get eroded now to where we're doing continuous development into this integration environment. Now, the next big leap is moving to doing that with fielded weapon systems, or for commercial, same kind of idea. How do we do OTA updates for critical infrastructure? So this is where I'm really excited again about all the folks that are on this call and the discussions that are happening in the community, because reminding everybody, like, we have to do this with no compromise. So we want to increase the speed of delivery, but we cannot sacrifice the safety, the effectiveness, et cetera, of these systems, those key attributes. Okay. So how do we get there? And what are we saying for the latest trends? You can actually kind of go through the agenda and get an idea of where the department is focused on. But let me just kind of give you some highlights. So one of the big trends we're seeing is the move to declarative all the things. So instead of having unique environments, instead of having unique processes per community, whether it's a system tester, or it's a DOT&E agency that comes in to make sure that weapon system is effective, or fielding and training environments. We're starting to see those environments now. The discussion's happening much earlier, including the development teams, and starting to express those environments using declarative techniques. It's the same thing that's happened again to IT as it's gone through the DevSecOps revolution. We're starting to see very similar techniques applied to our cyber-physical software-based systems. The same is true for GitOps style workflows. We're just now starting to see this really on the major systems, which is really exciting, right? We're moving away from the situation where we have unique tail numbers with the configuration that's specific to that asset, with hardware that's specific to that asset, and kind of the quirks that's specific to that asset with notes on, oh yeah, for this particular unit, you have to do this and this and this special thing. Instead, we're moving to general compute and software that looks more like an IT system, where we're able to manage those changes inside of a development environment, inside of our Git repositories and related engineering artifacts, push that when we need a change to production so that the entire fleet remains consistent. A word that you'll hear in the digital engineering community is digital twin, right? And that's really when we're successfully able to understand everything that's operating inside of that fleet, and we're moving to GitOps type principles. So I want everybody to just kind of zoom out a little bit in your thinking as you start to work on these services deliveries. Make sure that you're engaging with your systems folks, your testers, etc. Because again, the real power comes when we unify everybody, very similar to the journey again that we saw from IT to DevSecOps. The other really exciting, one more. I got too excited. The other really exciting thing that we're seeing now is this ubiquitous connectivity that's happening inside of the department. I think this is one of the biggest enablers for moving at speed at scale. So we're starting to see now the incorporation of cloud techniques. We're starting to see our first cloud-native weapon systems, even in the nuclear community, which is quite amazing, quite scary, and I'll talk about that just in a second. But this ubiquitous connectivity is important because, again, like where principal value is maximizing learning. So by having these systems that are generating engineering artifacts, that have different engineering communities coming together, that have different test communities, certification communities, financial communities, facility construction, like you name it, whatever it takes to deliver your system, getting everybody on the same page with the same data, seeing the changes at the same time, that's how you move fast. And so we're seeing, again, really exciting cooperation between the different cloud service providers. We're seeing classified cloud grow out in a very significant way. It's a real thing that programs can just buy now and get on and use. They can connect directly with their primes that can get on and use at every level of classification. We're starting to see data actually be freed up, so it's able to move between these environments in a very free-flowing way. Definitely still work needed, but impressive gains over the past 2 years. And we're starting to see these systems connect to, again, those operational weapon systems. Now, I mentioned it is a little bit scary. So we have to, again, no compromise in safety, security, or effectiveness. So now that we're starting to connect and unify all these systems, it's also critical, just again, going back to the IT to DevSecOps to cloud revolution, similar idea. As you start to concentrate all of these amazing capabilities, you have to be very cautious and careful with how you manage them because you can have larger compromises. So remember back to that CVE chart that I had, where we're moving from 17,000 to 1 million plus vulnerabilities a year. This is where it gets really exciting when we talk about acknowledging that there will be critical vulnerabilities enumerated in systems, potentially even in production systems. It's just something that is likely to happen. So if we just take that attitude from the get-go and start to embrace techniques like zero trust, where we understand that, look, we can't trust every aspect of the system regardless of the level of investment. Now we need to build these systems that are resilient against things going wrong. Even if it's an innocuous hardware failure or something more nefarious, we're able to recover in a sophisticated way. This is definitely new stuff for DoD. It's new stuff for commercial as well. But it is exciting to see that shift happening, that we're no longer believing that, just because we have gates, guards, guns, huge amount of investment in the supply chain, we're still doing all of those things, but we're also hardening our delivered targets or delivered systems so that, again, if anything does go wrong, that it is gracefully recovered in a way that still retains that warfighting utility. So it's impressive work, really good collaboration happening with industry on that. Okay. Now, where are we going from here? So I mentioned software-defined weapons. Software-defined weapons, again, is this trend that we're moving away from having unique boutique hardware and unique boutique software. Instead, we're seeing this generic compute that's common even potentially across platforms. We're seeing software that is now consumed that warfighting utility or commercial utility, and it is now fundamentally changing the way that we acquire, certify, deploy, and manage these systems. So I'd like for this to be kind of the call to action slide, where if you think about how important it is that we do this rapid delivery with cyber physical systems in a way that's safe, secure, and effective, this is how we provide, again, that foundational national security. It's incredible the progress that has been made over the past 18 months in this area. It's exciting how much commitment we've had from commercial industry, the defense industrial base, folks like SEI. But there is definitely a circle of the wagons activity that needs to happen to push forward in key areas. That includes supply chain investments. That includes thinking about some of these, how do we keep the rest of the community engaged with this? Software teams are used to moving pretty fast, but folks that are building buildings, the financial teams, all of those folks that are new to this kind of thinking, the style of work, we really need to invest in them so they understand how really software community has been, experienced with rapid deliveries for a while now. I'll say this is definitely one of the most exciting times to be in software that I've been in software. So I hope that it really takes away from everybody that it's just incredible the time that we live in, but the challenge is also incredible, and we'll have to rise to meet that as a community. Okay. And that was the whole thing. So Hasan, yeah, if any questions from chat, I'm happy to answer.
Thank you, Kyle. It was a great presentation. Actually, I really like to hear about, I know it's a long conversation, and how the DevSecOps is really applicable for highly regulated environment, like as you mentioned. A lot of people are confusing. It is not practical. I know you have done it. You explained the good topics on especially, and looking for the DO178C. And I'm going to have a couple of questions while waiting folks to really chime into the chat window. And people are really confusing security as a value. What do you think about the value? I know you had a great slide with the value and speed. It's kind of related to each other, value and speed. But security also has a value. How do you really describe the value of security in your journey, Kyle? Do you have any ideas, or have you ever done or thought about it? I know you have done it, but I have a little bit background on the value means in security.
Yeah, absolutely. So, kind of foundational again. We know that we have to accommodate rapidly changing systems. We know that we must accommodate learning through the entire life cycle of these systems in a more graceful way. That's where DevSecOps gets quite exciting, because it enables these techniques for us to again incorporate that learning. Now, that applies to all the communities. That it applies not only to the folks that want to have features, right, but the folks that care about, is the system secure? Will it always operate to the conditions that it should, no matter what's happening to that system? Similarly to system safety, right? It's important that we demonstrate that these systems are always behaving in a way that they should, and never in a way that they shouldn't. Now, when these communities first get introduced to these sort of rapid learning kind of techniques, there's definitely some concern at first, even reactions that this is impossible, right? You're asking me to move 1,000 times faster. It can take 24 months to certify a system, and you're asking me to do it in 24 minutes. I understand. So the way that we were able to walk teams through this and get them excited about it is just very similar to how you see the IT silos getting broken down with DevSecOps. But we started to form these teams that were more like IPTs, more joint teams. We would bring in our certifiers, we'd bring in cyber, system safety, nuclear surety, all on the same team. We would break the mega-sized problems down to small pieces, and then we would show, as we were making decisions on tangible hardware software targets, including them. And that is something that they've never had before. I mean, previously, what would happen to these certification teams is they would be dumped this entire system and say, hey, go approve it as fast as you can. And don't change anything because that'll cost a lot. Or slip the program. So by having them be proactive in these decisions and the architecture that's going on in the system, that was very exciting for them. Having them start to see the system be built in small incremental pieces, gaining confidence over time, that's been exciting for them. But my last thing on this, I won't say it's a solved problem at all. We're at a point now, like I said, that we're successfully delivering to the labs. It's been demonstrated that that's working quite well. The next change is going to be, how do we do this repeatably to certified end systems, particularly for our highest assurance systems? Lots of good progress there, but it's definitely still an area that there's community help needed.
Great. Thanks, Kyle. And there's some questions coming up for the chat window as well. Maybe we can dive those questions and try to answer as much as we can. I know the folks are believing DoD is not moving fast. So maybe you can talk about like the DevSecOps speed that you described. Fast doesn't mean we have to deploy to the weapon systems. Fast means a different context right here. Like there's a continuous delivery concept. I know you had one of the great slides and talking about the continuous delivery and deployment. Maybe we can open up to what the fast and speed means here. Like we're not really deploying to the code to the missile every minute. What does the speed means here?
Yeah, absolutely. Okay, so the speed, it's not just about how many deployments a day you do. You really need to look at what utility are you providing to the way that the system needs to operate. And as far as like how fast, like what has their transition been? Like it's amazing the speed ups that I've seen even in the past kind of 5 years ago. I've been across many programs now, these modern programs that have gone from what was like a multi-year buildup to a point where you would have a software master that then would go to an integration lab, to now having devs, testers, integrators doing multiple software builds every day, interacting with real physical hardware in the loop. Some of these programs, the cutting edge programs in DoD, are doing this across the United States with thousands of developers contributing to the baseline, all pushing again to that hardware integration lab multiple times a day. Now, I did say it wasn't all about deliveries. I think teams should just kind of back out a little bit and think about what do they need to provide? Like, what is that mission that they're operating? What value are they providing? And then pair it with the techniques appropriate for that environment. But the DoD really has accelerated in the past few years. The next big leap is going to be that integration lab to end weapon system.
Right.
I'm seeing that last thing on like IT type systems. That's now happening pretty rapidly. It can happen a couple of times a day. Once you're getting into the cyber physical systems, we're just on a beginning journey of having the ability to release on demand, but it's coming soon.
So Kyle, another question is related to the speed maybe, and I think what you have shared so far, and people can use the DoD DevSecOps references and other documents to implement the DevSecOps. Right. So there's one question is what about how can we learn about this DoD approach to DevSecOps if we want to adopt it? So I guess we can offer the DoD CIO Office DevSecOps, the pages. There's a lot of reference design guide, lesson playbook. Are you agree? Can we offer those?
Yeah, absolutely. Yeah. So they're publicly released documents. So if you just look at DoD software modernization or DoD DevSecOps reference design, just plug those into Google and it'll bring up the DoD CIO pages. Thank you, Jason Weiss, for going through all the PA process in that, by the way, previous DoD CSO. It's a great place to start. You won't see any surprises there. It just talks about a couple of design patterns that are pretty commercially relevant. It uses mostly open source tools, trying to, again, push on upstream consumption as much as possible, but it does accommodate teams that have IP based in their stack. It just describes ways that you'll want to encapsulate that again. So you're more like a Lego, not like a logjam.
Yeah. So another questions about the software bill of materials as well. You mentioned in your talk, Kyle, and supporting open source software. Is the software billing of materials providing value when you try to use OSS, open source softwares?
Okay, yeah. Real quick rant on open source. So open source is definitely a business decision when teams engage with it. And it's a fantastic community with how much excitement, how much talent you pull from, the level of investment. is typically far beyond like any single program, any single use piece of software. Where OSS with broad adoption, it's incredible all the level of investment that happens against it, not just on the engineering side, but again on the security, hardness, et cetera, that the software can go through. But saying that though, it's absolutely a business decision, and that it's got a slightly different life cycle model than just kind of paying someone to worry about all of the things that go into maintaining software and keeping healthy software. So as long as teams are really aware of what they're buying off when they take on OSS, it can really complement part of their software strategy, even in very, very high assurance systems. The difference is kind of the risk on, right? So for like a nuclear weapon system, obviously there's going to be a huge amount of investment to make sure that that system is always safe, secure, and effective. Things that might be a little bit different than if it was, not as innocuous. Maybe it's a data visualization system, then there may not need to be much investment. We might just be able to throw it straight on a wall, and away we go.
I've looked at a couple of things here, Kyle. I completely agree with you. Open source software, OSS and SBOM, makes us to be ready. You said one key point in the threat space, right, Kyle? The threat is keep growing. How much we are ready, like getting millions of vulnerabilities in a year, something like that, it just scares me. Yeah. It's about the resiliency, am I right? Like we should be ready, or we should have some plan, or we should know what is really ingredient, what is the component of the environment, so we can take a look at those and then properly and give some informations or be ready for what the vulnerability is, right? It's just about the readiness and resiliency.
Yeah, absolutely. So one, we have to make the great leap to just acknowledge that these systems could be compromised. And so zero trust principles, absolutely. Teams should be thinking about that no matter what you're building. Once you're done with that, then understanding all the things that comprises your systems is super important. So things like software bill of materials and other dependency management techniques, both internal, et cetera, to just know exactly what's being fielded. Then you can have more data-driven conversations with those risk authorities. I know what's going to happen is when we start to do these SBOMs for real, and we do binary source analysis, and we look at these shrink-wrap software that's been sold as very secure, like we've seen, Log4j and other examples, there are pieces of these, even commercial pieces of software that have issues. And so it'll definitely be an interesting time over the next few years in software engineering community when we start to realize how much risk is already in our fielded commercial systems. We'll just have to have, again, that good data-driven discussion with our AOs, make sure that they understand what mitigations are put in place and where there are investment areas, how do we prioritize that using threat modeling and other techniques like that.
So like a risk agreement, and one of your slides, you talk about the risk agreement. I guess you're referring to risk agreement between AOs and then the developers and everybody else together, right?
Yeah. And again, not just cyber, right? But anybody that has equity saying that the system should do this or act this way.
So I have a related question since we're talking about the agreement with the stakeholders, Kyle. And in one of your slides actually was kind of highlighted to me, working as a team together. I know we have many distributed organization units. They are working different environments potentially. Maybe they have a different type of tool sets. Maybe they have different cadence. How are we going to get those groups together working as a harmony? I know it's very challenging. It's another long conversation. Maybe we can talk about the cultural, discuss cultural throughout the day, like how to get team together, what the secret motivations to get the team aligned for the same value that we are delivering under DevSecOps umbrella and for our missions and vision. Do you have a few words about the team communication, team collaborations?
Yeah, I would start with, remember that everybody on these teams are hardworking humans, right? So everybody is kind of in a different spot of their journey. These communities all have very different backgrounds. Software teams in general, they have more experience with Agile and now DevOps. As you're working with other teams, like your financial teams, they may have not maybe seen one YouTube video on DevOps. And so it's important that we have patience and we work with them to build that foundational understanding of what these techniques are and what advantages they can bring to them in context that makes sense for them. So pulling on that financial team example, helping them understand how forecasting works with systems that are sort of this infinite game where the rules are always changing, we're gaining new information, systems are evolving in a way that we can't artificially constrain. Changing the way that we do our budgeting process, our projections, moving to more of a capacity estimation versus funding individual widgets. That can help them start to hit their targets. So these systems come in really, kind of on cost objectives. So that's true of any of these communities. Just, really think about how those communities need to do their business. And then as you think about the techniques that you've seen work so well for you in DevOps, help them understand how they can, again, provide value back to them.
So I guess you said the kind of bringing the value, teams, people should be aligned with the mission, with objective, what we are delivering, so people can get together and using the same objective to get it done and to really solve the early problems. And other things maybe you can open up here. There is a concept of source of truth. So when we say source of truth, I'm assuming people are able to communicate and share the informations as quick as possible, because speed is important. We're not going to share the information most likely by email, right? We are expecting people going to use the same common repositories or same accessible environment for sharing and exchanging information, or making awareness of test cases. And you have one of your presentation, Kyle, in the past, that you present a great DevSecOps pipeline, give people ability to connect and to look at what is really coming up, what teams are working on it, instead of having a pocketed different infrastructures and laying around multiple components. What do you think about that, the DevSecOps common pipeline and source of truth?
Yeah, absolutely. I think it's fascinating watching the digital engineering community in this space. And so they have the grand challenge of, okay, we just described we want to take all these different communities and put them on the same page. But we also acknowledge that these communities have very different terms, products, techniques, et cetera, and data sources. So the grand challenge now is to have all of this data democratized so that it doesn't matter who you are, what your background is, you're like rapidly informed of the decisions that are happening on the program, and you're polled so that your equity is represented in those decisions. So lots of exciting work happening between the different major architecture programs, the different requirements capture tools, and the BOD and SIM tools, starting to drive to more commonality for how data is exchanged with each other. And we're starting to see some more really exciting engagements between those providers and, again, like our application lifecycle management folks with DevSecOps tools, starting to employ more GitOps-friendly techniques. And I think over the next few years, as those two communities start to trade notes more, we'll start to see more of GitOps declarative managed architecture. It's already happening with UML 3.0 and other exciting advances like that.
Yeah, it's a community. We will get better. We will learn each other's. Like I think that you said as one of the keywords, I really like that. Building the community knowledge is really key point to overcome those barriers. And based on my experience, most of the barriers becoming a mindset for me. Looks like we're not in the same page, or we are not communicating in a DevOps way. I'm assuming that we are talking about let's communicate as a DevOps way. Let's put some empathy and requirements perspective. What other stakeholders expecting? We can prep those as early as possible. I am working in some code bases, maybe architecturally, maybe testing. I know somebody from other teams potentially use those artifacts eventually, right? It's kind of how the relationship is working together.
Yep. We've already seen some good examples, like when we see hardware changes inside of architectural programs. I like Joe Justice's approach of contracting for interfaces. So this helps with, let's say, a hardware team changes the memory allocation, right? They move to something smaller for a swap consideration. Those now, like the tools allow very tight integration back to the software team, so they understand, oh, okay, this is now, violating our agreement. Let's have a discussion on this before it gets too far down the engineering process. Like what's happened in the past, software teams are just kind of told, well, just you have to live with what you get. So it's exciting, again, to see the context being given to the folks involved in this decision-making process.
So which we're going to fail early during the interface check and communication instead of failing miserably at the end of some integrations, right?
Right, software at the bottom of the V.
Right, first, absolutely.
Last done, first needed. Yeah, so we're starting to see it more throughout the whole process, which is good.
It is about more communication. I like that. It was a great conversation with you, Kyle. It was a great, I know we have enough time to talk about a lot of topics, but I really appreciate your time. And you're in the the different time zones, so it's very early for you. And thanks for participating as a live to the sessions. I really thank you. And I'm sure community is also thanking you a lot for your contribution perspective as well. And looking forward to have another session with you, Kyle. And thank you so much for participating. As we are moving the top of the hours, and we have next speakers, and after the short break, and next speaker will be Jeroen Willemsen, and he's going to talk about learn how to or not to use secrets with the OWASP wrong secrets. So he will be with us as a recorded sessions. And before that, Jeroen Williams is a principal secret architect and a jack of all trades in security. He loves to develop a new software and set of DevSecOps support tooling and help companies with security programs. He enjoys sharing knowledge, and which is why he published articles, blogs, and give trainings and talks on the various subjects. So Jeroen will be with us in shortly, and he's going to talk about the secrets and with OWASP, wrong secrets. And looking forward to have another the session with all of us together within 5 minutes.
Hello, hello, hello. Welcome to our presentation at DevSecOps Days 2022 in Washington, D.C. Well, virtually it is, because I'm currently presenting from the Netherlands. In fact, this is a pre-recording. However, that shouldn't keep you from asking any questions, because there will be a 5-minute live Q&A. So feel free to jot down any questions you have or feedback, so we can talk about it later. Before we continue, a little bit about me. Because 5 minutes Q&A might be very short. If you want to get in touch with me after this, use the allmylinks.com/community or scan the QR code. You'll find various ways how you can interact with me. If you want to talk about the project, secrets management, or actually help us out to progress this project even more. Having all that said, let's actually go into the content, as we only have 25 minutes at most. So a very important question that we always ask each other in order to assess the trust level we can have with each other is, can you actually keep a secret? You might have had this question when you were a kid. Your parents asked you to keep a secret from your younger family members because, hey, Santa apparently isn't real, or Santa Claus doesn't exist, or whatever. And at a later age, you might actually have secrets from friends that you shouldn't or weren't allowed to share. And by now, you're probably at the age working at some company where you might have company confidential material that you shouldn't just share with others. So can you keep a secret? That is you as a human being, and keeping secrets can be kind of tough, can't it? So what if we want to have computers to keep a secret? How can we make sure that they will do that right for us? That is where this is all about. So there is, of course, many types of secrets. And of course, we're not talking about, the secrets behind Santa. No, we're talking about different subjects here. So, for instance, a secret can be credentials to access any sort of service. It could be OTP seedings. It could be your GPG private keys. It could be your signing key or a password, an SSH key, an encryption key, an HMAC key, an API key. But also things that you might consider less as a secret that still are, such as the activation link for certain services, which automatically personalized activate certain things. Or what about that QR code for a single type and sign-on? And then, of course, the MFA backup codes, which are also secrets. And then there might be many more secrets like API keys and whatnot that your computer or your application needs to access without other human beings automatically being able to reuse that. So that might sound simple, but what if you would ask yourself, where would you store a secret when you're running on Kubernetes? Would you store it in code? Because, hey, your code gets compiled and that compiled asset just runs in some container in some pod or a job or whatever, right? Or would you just store it in your container? What about your Kubernetes config map or your deployment configuration or your Kubernetes secret or your Kubernetes job specification? And maybe if you're lucky, what about your secrets manager? Hopefully you have something laying around like HashiCorp Vault or some other secrets manager where you can store secrets in. And what about your platform providing solution? So if you're lucky, you're a bigger company, you might have something like an SRE team or a security team or whatnot that might do something with secrets management and say, hey, you can store your secrets in storage X, Y, or Z that we secure for you. Or something else. There's so many places you can put your secret in, right? And by the way, did you do that for all your secrets, or are they spread around on these different layers? So let's make this question from a problematic state. Assume you get hacked or something else happens, like a big event, and some people have been working at your end and they show not to be very trustworthy, get sacked, and they have access to a lot of things. That means you have to start rotating a lot of these secrets within your organization. And now ask yourself, do you know if you would have to rotate all of your secrets where they are? Do you know the purpose of these secrets? Remember that password in this secrets entry in Kubernetes done by Joe from Department Z? And I really don't know, man. there's no metadata, there's no annotation, there's nothing, and the secret just gets loaded, and if we remove it, then half the services go down. But why? Why is the secret so important? And can you rotate them timely? So rotation is not just about, changing their values. It's also making sure that the services that need to work with those secrets can actually work with them, so they are actually ready to actually consume them or use them as validation or whatnot. And so many other things, of course, require like monitoring and whatnot. Right? Monitoring, you say. Well, we can help you there. How about you monitor all your secrets and make an alert when somebody tries to grab them, and then log the entry when the access, and there you go. Okay, so now assuming you didn't do that you're not going to log the contents of the secrets, can you still tell us when your secret was last borrowed by the next colleague? And can you tell us where it was used for? In other ends, can you tell us when your secret was not working anymore? Well, that we often can tell, because the moment it is going wrong, so far beyond when we should have rotated or we should have updated, we'll see 404 stack traces, error servers going down and whatnot. So yeah, apparently we can tell that very well, but often already when it's too late, when it is indeed no longer working. If you're less lucky, you can't tell. You just see weird stack traces or error messages that don't tell you that it's just a secret that got expired or a key that needs to be rotated. So apparently secrets management is special. It's not that easy, right? I mean, there's a bunch of things that can easily go wrong. That's what we also saw at OWASP, and that is why we started a project, Wrong Secrets. So today I want to talk a little bit about this project and spend most of your time with a demo. So this is what we're going to talk about. The project itself, we're going to do a Docker demo on Heroku. We're going to do an AWS demo focused on Terraform State, go over a few takeaways, and then talk about the future of the project. Well, that's at least what we right now see, as we are volunteers, but if you're wanting to join as a volunteer to our project to further extend the project, we might actually change. Alright, let's get started. So what is Project Wrong Secrets? So first of all, it's a vulnerable app and a secret detector testbed. Wait. So we'll demo the vulnerable app and the secret detector testbed. You can read all about it in your documentation. The idea is basically we hit many more secrets in our code and in our branches. And what you can do now is test secret detectors to see how effective they are in detecting those different secrets that we hit for you. We're very willing to extend the testbed for as much as needed, so if you have any secrets missing, just file PRs or issues so we can further extend that. Our goal with this application is threefold. First of all, we want to educate on secrets management and its pitfalls by having interactive challenges that we're about to demo. Second of all, we hope you can, well, you and everybody else who might not be watching, help you with this vulnerable app to reflect on the secrets management strategy. Because if you did an exercise, we hope you were going to ask yourself, did we do something similar with the way that I just learned how to find a wrongly configured secret and gets its value? Does that impact our current secrets management strategy? Do we have to store our secrets elsewhere or reconfigure our whatever we store our secrets in? And of course, we want to promote secrets management as an important facet of security. Everybody has been talking about key management and whatnot, but secrets management in general is something I think that should get more attention. We're currently in OWASP Lab project. That means that OWASP sees a lot of value in what we do and would love us to extend it further, and that's exactly what we're doing. And by we, I don't just mean Ben de Haan and I, as a project lead. There's many people that have contributed to our project, so if you're watching this, thank you so much for your hard work. And thank you testers for testing various challenges, and also a special thank you to Madhu Akula and Björn Kimene for all the additional help provided to make sure that we could accelerate as much as possible. A project like this isn't built in spare time in such a short amount of time if it weren't for these awesome people to help us out and accelerate this as much as possible. So how does this app work? So basically, it's a Java application or a Spring Boot application actually running on Java 18. And we have a bunch of reverse engineer challenges that are written in Go, C, C++, and Rust. All of this is packed into one beautiful Docker container, which you can then either run directly on Heroku or Fly.io or other services that run Docker containers, but at least we use these. Or you can use it as a pod and then run it on top of Kubernetes together with Vault, for instance, for Vault-related challenges. And you can run all of this stuff on Minikube, on Octito, or use one of your cloud environments like AWS, GCP, and Azure. For the first two, we only have scripts, and for the last three, basically, we have everything in place from Terraform. So you have to start with an empty account, and we can Terraform it with you, or you can Terraform it yourself with our Terraform code, that is, of course. And then you have to run some additional scripts to set up all the layers above that, and then you basically have your challenge environment to play with. Note that we're trying to always lower the cost as much as possible, so there's no very expensive worker nodes. It's all lightweight EKS or lightweight whatever in there. Alright, and we got challenges at every layer. Enough talking about that, isn't it? So let's start doing a Docker demo at Heroku. So we already had this question multiple times, like, okay, but I don't have all the tools installed possibly to do this. Can you help me? So for that, let's have a look at our Wrong Secrets desktop. You can find all the instructions to run this as a Docker container in our project README. Feel free to follow that up so you can actually run the challenges from this desktop within Docker. That will allow you to have all the tools at your fingertips to actually do your whatever you want to do to find out what's happening and where the secrets are. For now, we'll just move directly to, for instance, Heroku. So here you'll see a bunch of challenges that can, for instance, run on Docker. So that's where this demo is about. We also have a few challenges that only run on Kubernetes, like we talked about, and a few cloud-specific challenges. Let's start with challenge number 1, and given sake of time, we do challenge number 1 and 4. And after that, we'll do the cloud demo. And if you want to, we can always, of course, record different demos for you for the other challenges if you like that. But at least this will be the content for this presentation. Anyway, enough talking. Let's start hacking, shall we? So challenge number 1 is fairly easy, as you can tell by the difficulty, by the way. We got difficulty ratings for all of those, which also show how much work it is to basically retrieve the secret after it's been misconfigured. Or after where it's been put somewhere wrongly, basically. Let's go for challenge number 1. So this is basically challenge description. Let's go over that. So let's assume that you're writing a proof of concept. You often then just hard code your secrets for a certain commit, right? And then you might put something like password in code. So what if we forget to remove these hard coded secrets? Can you spot the secret we are looking for in code? And what about looking for it inside the container? Sometimes the simpler tools are most effective. So you can either, clone, use grep for the word password or something else. We're not going to do that. We're going to cheat a little bit. We know that this is challenge 1. So if you do a little bit of analysis, then you end up over here in challenge 1. And there you can see, okay, we apparently have some spoiler. We have some answer correct. And all of that refers to the whole time to the same thing. Constant.passwords. So we have this constants class over here that apparently has this password, which is the full login password. Do not change. Okay, we won't change that. That's for sure. Let's try it out, shall we? So let's try it out. Is this so? As you can see, I tested it just before this. Apologies for this banner. Is this the secret? So this should be wrong because we know it's wrong. So let's do password do not change, and then you can see it's correct. So it only allows you to enter the actual correct values. So let's try something else, shall we? So let's try to do challenge 4, which is actually a harder challenge, at least the hardest challenge with Docker. So the developer got smarter. Now the password is no longer defined by Spring, but means of a Docker container build argument. Ooh, that's interesting. You can easily spot it by looking at how the layers of a Docker container got constructed. So if you're not really familiar with how that's happening, you can just press stuff like show hint, and it will show you how to have a look at that. So let's try to do that. So let's just take this, and tag here is of course our latest tag. So let's open a new one, and we say 1.5.3 because that's the latest release right now. No vault is the tag. Oops, let's do oh yeah, let's just first do docker pull latest no vault. So we just pull the latest in, and no vault basically means anything that's running. So now we do. So let's just use latest. And now we can see how the layers are constructed. Apologies for this being a bit dispersed. So let's see if we can make it a little bit wider for a little bit more readability. Already a little bit. So what we have to look for is basically the arg value. So basically that will be, so here we have the copies, here we have the run statements to actually get stuff done, and here is a arg based password. And it says this is on your command line. So we constructed the container by saying docker build and then --arg, and then we provided the arg based password and its argument. So apparently this should be the value of that. Let's see if that's correct. Submit. And that is correct. As you can tell, we got way more points because this challenge is more difficult. And well, you can tell if you can fulfill all the challenges, you'll get a very completed bar and some funny surprise. So of course, there's many more challenges, right? There's challenges you could already try with logging. There's challenges with hidden stuff in Docker at other places. There's even CI/CD challenges for related to our GitHub repository. We have password manager challenges and some cryptography related challenges, but also funny things like binary reverse engineering, which might sound hard because of the amount of stars. But just press show hints and we'll guide you through. Should be a blast. So having that done, that is about the Docker part. So by now you can tell that Docker and Go might not be a good idea. So how about having a short AWS demo? So what we did, we just freshly terraformed for you an environment. From the AWS folder, you can follow some instructions. Then you start with Terraform apply. It starts telling you all the stuff that needs to be implemented, and then you tell it to implement it. Then you follow a few other scripts which are in the README. And then eventually you end up with a nice place where you can start playing around with. So let's try to play around with that. So over here you can see the AWS environment, and our challenge that I would like to have a little bit of fun with together with you guys is challenge number 9. Because this is basically where we start storing secrets in Terraform state. So the problem here is that, when you use Terraform, the nice thing, or if any infrastructure as code, is that you need to keep state somewhere. And you possibly might end up having secrets in that state. And this challenge is about that. So you can run through the Terraform TF state, and we already looked it up for you, of course, given we only have 20 minutes to present. And here you can see that we also have a secrets manager, secret apparently, which contains this string. And given it was a secrets manager exercise, wrong tab. So given it's AWS Secrets Manager exercise, we believe this might possibly be the secret that we see in Terraform state. And that is correct. So the way that works, of course, is that we use an unsafe generator to generate the secret and just copy pasted it in without protecting it further, which broke this stuff. We would love you guys and girls and they to really look into the rest of this. But of course, with 20 minutes, it's going to be a bit hard, or 25 minutes. So let's go further. So, of course, we're told how to not do this. So how should we do this? So if you look at our Heroku demo and at other demos as well, there's a bunch of links that we have of content that we created or content that we support on secrets management. Just go over these links and find various sources. Next to that, basically use wrong secrets, like I told earlier, as a secret detection benchmark to find out, hey, can I detect secrets early on before it gets committed, or early on before it gets into containers, or early on before it's in a Terraform state, so I can prevent those secrets to leak through those resources. And there's of course a few takeaways I think we can learn by now. First of all, know the hard code. Not in Git, not in your containers, and that you'll find out throughout everything else is not in your binary codes or whatsoever either. Don't just trust defaults. because the Terraform providers were in a default mode. There was nothing specific that we did for the given versions that we used there. Make sure you actually rotate your secrets timely, because you might make a boo-boo. So it's better to actually just rotate them timely. And if you can, just use ephemeral secrets that only live for the sake of being consumed in a short time span, and then get rotated, removed. And reduce blast radius of the secret. You will find out with many of the things you're doing that you don't necessarily need admin passwords for everything. It's fine to have access to certain resources with reduced scope. So if your secrets gets leaked, then only the reduced scope is basically exposed. Also reduce exposure. Make sure there's very little resources where the secret is actually stored at. So it's going to be very hard for people to find it. And make sure that for that given resource where you store the resource in, that you don't allow too many type of roles or individuals to actually access that secret. And of course have logging and alerting in place. That is not as easy as we saw in the introduction, but there's many good practices to make sure that this will work. So where do we go from here? So first of all, it's an open source project running on 3 clouds and lots of other environments. That means lifecycle management all over the place, like dependency updates, migrate to a new Kubernetes version again, update our Terraform providers and whatnot. We're very happy that we got everything now covered in the Pandabot configuration, so we can actually see when something needs to get updated quite timely within a month. That should allow you to consume our Terraform or the other definition at any point in time, because it should be workable, because we're testing at least on a monthly basis. We also want to make sure the development becomes easier, and we want to add the amount of reverse engineering challenges by, for instance, high diffuse secrets within Swift binaries. And there's many other challenges we want to add in terms of mistakes that we already spotted in the wild, because of course there's more than just 24 different types of boo-boos we found so far. Then of course, as you can tell, this app has been made by volunteers, and it's not made by UI and modern front-end specialists, so there are a lot of UI improvements coming our way, but it will take some while. Next to that, it's the secret detection testbed that we want to extend with a lot of other different secrets. And right now, we already support CTF mode, where you can basically run CTS with OWASP secrets, either with Facebook CTF or CTFD. But the problem is, of course, that currently we only can host just one version. So what we're going to do is port OWASP multi-juicer, which is built by TerraTech and Bjorn Kimmich and a few others. And we're going to port that not to support JuiceShop, but to create a version that actually allow you to have a real CTF environment for OWASP secrets. It might actually very well be that a very early alpha phase is ready when this recording is actually being broadcasted. So stay tuned for that one. But we can really use your help. Like we said, it's all based on volunteer work. So if you want to, please promote us by just starring the repository or talk about us in social media to give more attention to secrets management in general, and maybe help others to find our resources and help us to expand those together. Take the project for a spin. Not just, have a look at these demos, but just try it out yourself. It's fairly easy. Just go to Heroku, Fly.io, or Octata, or really set it up yourself with a Docker container locally and just start playing around. You'll actually find a lot more things that we haven't talked about during the session. And give us feedback. Either you found an issue, or you can contact us through OWASP Slack, and you can go to channel Project Wong Secrets and talk about this with us, or just chat with us directly. And the best thing you could do to us is basically file PRs to, add challenges, improve the stuff that we have there, or help us fixing the issues that we're facing currently. Questions so far? Let's go to the interactive part of this. Hope to see you there.
Morning, everybody. I'm Jeff Hammond, DevSecOps engineer here at the Software Engineering Institute. And I have the pleasure of handling the Q&A session with Jeroen. Jeroen, thanks for the great presentation. I thought it was really another great addition to the OWASP tool suite. So, basically, I thought one of the things that I thought was the most interesting is seeing that, there was all these pre-made challenges. Can you explain a little bit about what goes into deciding what challenges are bundled with the wrong secrets tool, and how you come about with the ideas for those?
Yeah, sure, Jeff. There's a bunch of processes that have led to this. It started basically with me being an information security consultant, visiting various customers and seeing all these mistakes in the wild. And then, of course, when I joined OWASP, we went to conferences and stuff like that, talked to many people, and we found this firm belief in some of the security aware developers of, hey, there's no way you can find this if you do this or that. That's a perfect security mechanism. And at the same time, you would then have us or red teamers or whatever thinking like, huh, this doesn't sound like a very good idea, to be honest. And then when you actually spot that idea in the wild being implemented, that certainly alerts us to, okay, we really need to start educating people that this wasn't just a wild idea for a single individual. Apparently this idea lives everywhere. Let's start implementing a solution for that, as in by showing that this doesn't work. And then when we started presenting this tool, we got people, of course, during various conferences and meetups saying like, hey, I love this tool. Have you thought about challenge X, Y, and Z? And then all of a sudden, very often when they talk about that, all these ideas of them actually come back to my head like, hey, I actually saw this happening in a while. That's a great idea because it's not some funky thing you thought of. It's actually happening. For instance, there's now a bunch of issues filed in GitHub because of our a meetup in the OWASP Hamburg Stammtisch, where a bunch of the attendants are like, hey, do you remember, that you had your tickets in Jira or whatever system, where an engineer would start asking another supportive team and saying, hey, for some reason, this is not working. I use this API key here and it's not working. And then the support team would come up and say like, oh no, that's the wrong key. You have to use the actual secret right there in plain text. And then the other, engineers say, thank you, it works now. So that's a new issue right now they want to implement as an idea of, hey, let's make sure you don't do that. And that's how it's been evolving basically. So mostly from input from what we see literally happening or what we're gently reminded of by the community around us.
Great, thank you. Thanks for sharing that. Yeah, I mean, it sounds like it's a little bit of everything. It's from practical experience, discussions with other people that you meet. Do you see this as something that continue to grow as new use cases develop and that sort of thing?
Yes, definitely. I thought we would sort of kind of freeze the amount of challenges to 25 at some point. And then people came to me from the smart contract world and Web3, and they explained like, look, we actually have a similar challenge, but our ecosystem is big and used a lot. Can you have a look at it? And then I figured like, yeah, sure, why not? And then they came up with another set of challenges. And then of course at the OWASP Stammtisch, we saw again a lot of documentation stuff coming up. And then there were people that did the binary reverse engineering, and they said like, hey, I got this engineer saying that this is a problem in C. Everybody can reverse engineer C binary, but Swift is very hard. You can easily put a secret in there. Can you please show him that that's not the case? So it's still growing, and now it's growing organically because the more exposure the projects get, the more people start thinking of, hey, I've seen this malpractice before. Can you add that to your list? Although it's growing slower now, we'll have to see where it goes. We just don't know. For us, it's a journey, which we enjoy because I like building something next to my security architecture work. And by that, if you, while watching this, actually see anything you feel like, hey, maybe you should have thought about that case as well, let us know. File a GitHub issue.
Great, thank you. So how does this fit in with other OWASP tools? I know I've used some like Juice Shop, that sort of thing. Can you tell me a little bit about how you think that those things could be integrated more?
Yeah, of course. So there's a bunch of categories in OWASP in terms of tooling. So you got, for instance, tools like OWASP SAP, which is a great tool people should check out if it comes to manual middling and testing APIs and whatnot, and testing HTTP traffic. And we also have various other tools like the OWASP dependency checker, which are really tools that will help you to set up your to improve your overall security by taking care of certain things. Next to that, we have a bunch of vulnerable apps within OWASP, like Webcode, like the VWA, Juice Shop, and tons of others, which are more about showing how to not do things in the hope to educate people not to repeat us as having bad practices. And we're OWASP Work Receive Secrets really fits into that, because there are tons of documents telling everybody what to do with secrets. but apparently nobody reads them. So that's why I figured it might be easier to see what happens if you don't read them and just do stuff.
Great, thanks. So how did you get involved with OWASP? I'm curious because, I've attended some OWASP sessions here in Pittsburgh. Can you tell me a little bit about how you got involved with the organization?
Yeah, of course. That all has to do with a great thanks to Nana Baars, the project lead of OWASP Webcode. When I worked together with him at Xebia at a given customer where we did some SDK development that was very security relevant and had a lot of risks involved basically. He said like, hey, you got a lot of mobile security knowledge. Maybe you should talk to some friends of mine at OWASP. And there it basically started. So then we worked at the MESVS and MSDG. And later on, I stopped because my second child got born and stuff like that. And then we moved to this project.
Great, thank you. Well, hey, thanks a lot, Jeroen, for joining us today. That was an awesome presentation. I know I personally can't wait to pull that container and run through the challenges to learn more about secret management and that sort of thing. So I appreciate it. Thanks for your time. We're going to take a quick 10-minute break, and we'll have more presentations of DevSecOps Days when we get back. Thanks for joining us, everybody. Jeroen, thanks again.
Thank you so much.
Welcome back, everybody. Again, I'm Jeff Hammond, DevSecOps engineer here at the Software Engineering Institute, excuse me. And very happy to introduce our next speaker, Mark Hahn from TCP Technologies. Mark, the floor is yours.
Great. Thank you, Jeff. Today, I'm going to talk about security as an awesome product feature. And the point of this talk is how do you get development teams and their surrounding ecosystem involved in working on security and including it as a primary piece of your project, or your product. The goal is to review some methods and other approaches that helps you make the case that security has got to be front and center in your product, and not just some afterthought. So we'll talk about that. I have a significant amount of background in cloud and SRE and DevOps and building and delivering systems. If you would like to follow along, the URL there down at the bottom is the link to the same slides I'll be sharing, so you can follow along and read the speaker notes with me, or maybe just go to sleep and read it at a later date. But anyhow, the point of this talk was I was listening to a security podcast a couple of years ago, now, surprisingly how long it's been, right at the beginning of the pandemic. And Brian Harden was on the Breaking Down Security podcast as a guest speaker with Brian Brake, and made this comment out of the 30 or 40 minutes that the podcast was going, and said, basically teams want to work on awesome features, not security. And they don't realize that security really is an awesome feature. And I that phrase rung in the back of my head for quite a while. And I thought about this and basically decided, you know what, it is an awesome feature. What we just need to do is to convince teams that that's the case, and get them to get teams to realize that. So part of this actually can be summed up. Our last speaker was from OWASP and talking about his tool that he's developing. There's another OWASP project around security culture, project security culture. And if you look in the speaker notes of this presentation, you'll find the link there. I'll put it front and center here in a minute. But basically, there were several people at OWASP that were thinking about this as well. And in their book on security culture, there's a whole chapter on finding a security champion, somebody who can help you move forward in this area. But let's talk about what does that mean to be an awesome feature. And I like that term, awesome. And the reason I like that term is that really it's an adjective that's talking about comparison. We're making a choice about the relative value of different things. Security is awesome, as well as other features of the product are awesome, right? So, adding a new feature to add a new report or add a different way of looking at the data that your product has got, like that new view of data, that chart or graph might be awesome, but then so is security. And so we're looking at, how do we use this idea to move forward and make relative choices. And so when we're trying to describe value, we've got a couple of different ways that we can describe value for the features and for the various work that we're putting into our system. So teams need, along with their product owner, if they're an agile team or if they're waterfall and they're doing a project initiation report for a particular product, they need some way of being able to describe the value of the business features that are in there. And so there are multiple ways to do this. One is with, say, monetary methods, like what is the ROI for this? There are other things about relative value in that you can compare this to that and say that, well, I think this is more important than that, and have sort of subjective arguments about it. You can have checklists or security best practices or application best practices. Maybe you're building a to-do app or some kind of scheduling app, right? There's a checklist of things that you need in that product in order for it to be a good checklist application. Or to-do application or project scheduling application. Those things have to be on your checklist, as well as other things around good operational best practices and so forth. Or you can use frameworks that help you describe the value for that. Let's dig into some of these various methods. One of the way is to use relative valuations. And so relative valuations come essentially in 3 or 4 different ways. One are hard things that you just can't get away from. If you're building a banking app, you've got regulatory requirements. If you're doing healthcare, you've got regulatory requirements. And so those mandates, there is no relative value. They are required in order to be there, along with maybe some of the features of your application are kind of required to be a particular, to be a particular type of application. And then there are things that are important. And from a security perspective, we've kind of listed these things, encryption at rest and encryption in transit. So TLS is something that's important, and not just TLS. Like we can still encrypt with SSL 1.0. That's still encryption, but maybe it's not the encryption you want to use. For identity management, OAuth 2 is a factor. Now we're talking FIDO and other terms. Some form of multi-factor authentication is important. Encryption at rest. Correct session timeouts. What is the right session timeout for your application? For a banking application, it's probably a relatively short timeout, 10, 15 minutes, 15 to 30 minutes. But for other sort of business applications, that might not be. It might be a full day's worth of work or a half day's worth of work, like a 4-hour timeout. So you need to think about those things and have discussions. And then there are other things like that are nice to haves. And I list application firewall here. Somebody may argue with me about that's an important requirement, not a nice to have. Depends on how you build your application and what you're doing. So as a relative evaluation, we will have discussions, and we may not be able to come to an absolute conclusion here about which is better. And so somebody's got to make a choice. So possibly, we go back to the HIPPO, the highest paid person's opinion wins out. More data-driven solutions might involve sort of a monetary valuation for this. So the obvious monetary evaluation is to look at what does it cost you if you don't have good security, right? So probably the 800-pound gorilla here is the POMON data breach report that's published every year. Just updated these slides for the 2002 report. A data breach costs you roughly $4.3 million in the U.S. So that is average worldwide across all regulatory frameworks. In the U.S., it's nearly double that at $9.4 million. If you download the 2002 report, it's there on page 10, according to their data. A cost per record, $164 from the same section of the report. The average number of records in a breach is tens of thousands of records. This, however, and regulatory requirements are also can help you get to a monetary evaluation for this. The EU has the GDPR fines that are basically a minimum of 20 million euros or for 4% of your gross revenue, which is a huge amount. So the only problem with these figures, you're building an application where your budget for building the application may be, less than $1 million. Then in that case, these numbers are so huge as to be basically meaningless. So maybe you need a different approach to do this. So monetary evaluation may not be the only way you want to do this. You may figure out ways of measuring ROI for a security feature in terms of trust for the application. An ROI-based measure is probably a better choice. So, when you're building your application, security is not going to be everything that's in your application. So if you look at the amount of time and effort that you're spending, put a dollar amount on that and figure that the value that you get back based on that is a good way to do a measurement of that. Checklists. Gartner has, 12 things to get right. So this is a report that they published in 2019. 12 things to get right for successful DevSecOps. And this was the report that they produced their DevSecOps diagram, which took the SecOps diagram or the DevOps diagram and made it more complicated. But this is a checklist of things that you've got to do. If you're looking at the PCI standards, they have a long list of checklists that you want to do. So with points and subpoints. This is one way to approach it. They're useful in many ways to make sure that you've covered the bases, but they also get difficult to go through, and that particularly for something as long as the PCI checklist, it can take you many days to get through there and ensure you've covered your bases. It also leads to fatigue if you've been reading through, if you do PCI assessments, if you're a developer and you're trying to read through PCI to make sure you've done everything right, the fatigue that comes from reading with something like that is difficult. So with DevSecOps, we prefer more to put these checklists into our day-to-day process, which is helpful. So, many of the things that you can do is, for every user story, there might be a check about security implications that you go through for every user story. And so then you're doing a little bit of security every single day. And that's helpful for building that mindset. Another way to do this is a framework, and a framework might be another form of a checklist. So when I think about frameworks, I'm thinking about approaches to building security into your DevOps process, as opposed to say, the Spring Boot framework for security add-on. I'm talking more about a process framework for getting security right. The OWASP Open SAM model is one such framework. It's got a lot of good advice about what you need to do. There's less advice about how to approach that, which I think is a bit troublesome, but the Open SAM model helps make sure that you've covered your bases for everything that's needed in your product. It's also a bit big. It's 303 pages, so it can be very difficult to get through and apply to your project and make sure that you've done that. It is a layered approach, which I do like, and it can be applied iteratively, which is a win. Any of these things that you choose, particularly the checklist approach, they tend to get complicated quickly. And remember, complexity is the enemy of security. So if you can do the simpler things and repeat doing the simpler things, put that as a part of your DevOps process, then you're moving forward and you're adding security. You're making the right choices about security as relative valuations. The other thing that you can do here is empower your dev teams to think about security, so they can take on security as their primary approach. So, agile methods allow you to agile teams allow you to move faster, to respond quickly in the security world where security threats and your threat landscape are changing every day. Being able to be agile is really, really important. So this is helpful in terms of, being able to respond to security threats. And it's important that you empower your teams to move forward with security so that they don't always have to have the security person on site, or that it's not just, they're not doing security when the security team is coming around and asking them about it, but they're doing security as a part of their day-to-day process. And so that comes with a recognition that as you're building your product, security is a business problem. And it's important that you recognize that it is a business problem, and it is a full feature of your product that security must be addressed at the start. This comes to us from Kip Boyle, who wrote this book, Fire Doesn't Innovate. Kip was the CISO for PEMCO Insurance for a long time, and is now a consultant, but a really smart guy. And the phrase that's basically at the beginning of his book is that cybersecurity is a business problem, not a technical problem. And that was basically the approach that he used throughout his career in the insurance industry, that, look, every time you think about something in insurance, you need to think about cybersecurity as well. And so was a real innovator in the insurance industry. But if you make it a business problem, then your teams can be empowered to address this on a daily basis, and that's important. It becomes part of their process. So, I like this. I like the continuous loop, just a single loop of a DevOps process where you've got continuous feedback going into your product design. So, but when you look at like a business value chain and you look at how teams are organized, if you're empowering a team, that team is responsible for taking input from multiple stakeholders. And so this is sort of a depiction of a development team and the various ecosystem that they operate in and the stakeholders that show up around them. And it's important to recognize that, if only information security is the only champion for security in this model, then the development team is only getting a security signal 20% of the time or less, because you may not be fully involved in the product. It's important that the project team, the development team, understands that security is part and parcel of their day-to-day work. For that matter, it's also important that senior leadership and the business owners understand that security is a primary feature of this product, and that your SRE and operations teams also understand that security is a day-to-day operation, and so that everybody is working together. Hopefully, your users value security as well. If it's a banking application or a healthcare application, hopefully they understand why security is important, and are willing to use a username and password to log in, or use a username and a multi-factor authentication device to log into your application. I know that I do. And if your users are internal to your corporation, making that case that they need strong authentication is something that belongs to the information security department. But also, you need to carry that message through to your development teams. Let them know that they're part and parcel of your security operation as well. The other thing is that security doesn't have to be all or none. It is an iterative approach, and it absolutely must be an iterative approach, because, again, our changing threat landscape. But you can, for each iteration where you're going through the plan, build, test, deploy, and monitor cycle, you can iterate on various parts of this. So, you can build for, a secure architecture in the planning phase, and add security scans into your automated builds. Build capacity and stress testing, as well as static security application testing. Like, you don't have to do the application security scanning in your first iteration. Like, that can come later, as long as you're going to get to it. It probably should come sooner, and those are good relative value arguments to have. But these things are important, and building in a monitoring infrastructure that allows you to look at event rates for interesting security events, like the number of logins, the number of failed logins. Like, these are all indications that you can use to better understand the security landscape, the security threat landscape for your product. And so by taking an iterative approach, you don't have to mitigate everything all at once. You're not taking a big chunk of time out of the project where you're seeing none of the application value features and just security value features. This is so the iterative approach allows you to bite off small chunks that are digestible in each phase. But it's important to recognize, for the product team, the product owner, the senior management, the business value of a system cannot be realized if the system is not trustworthy, right? If I have a banking application and it isn't using secure communication, I'm not going to use that banking application. I'm going to think twice about using that bank. Same way with say healthcare. Same way with other parts of if the intellectual property of my company is unprotected, then I'm very worried about their lackadaisical approach to other things that are important as well. In many organizations, those security features are lumped into something that are called non-functional requirements. And this is a common project management phrase that that drives me bananas. All of these things are functional requirements, and there may be trade-offs between certain functional requirements, but using the phrase non-functional requirements devalues these features. It devalues features like monitoring, just basic monitoring. I will often ask my development teams, what is your application's major business transaction? They probably have a good sense of that. And the follow-on question is, how many of those transactions happened in yesterday? That's a question that many don't answer, but monitoring should be a full feature of their product so they know how much value does this application actually add to their system. So, by lumping, say, monitoring and operational tasks into non-functional features, you're really devaluing them, and that shouldn't be the case. Same way with security, having strong authentication, having encryption at rest, having these other things are really important to having a strong application. So, in summary here, as a security person, as a developer, as a product owner, as anybody in the product ecosystem, you need to help your organization empower development teams and empower those development teams to address security features. When you're talking about security features, you need to pose them as product requirements which bring value. So you need to find ways of describing that value for each of the features that you've got in terms of identity or encryption at rest or other key features. You need to talk about the value that brings in terms of trustworthy. Hopefully you can talk about ROI. You can talk about avoidance of costs like breach costs. You need to search for developers who find security interesting. Every job description should have a line that says, understands good security principles and applies them through all facets of their job. Whether it's a product owner or a sales clerk at the point of sale register or your security architect, they're all involved in security. So everybody needs to understand their operational security goals. And so adding a requirement or a skill set that a developer or a product owner or whoever else you're hiring to build this product has security experience and does security right is a good idea. And then work iteratively. You don't have to boil the ocean. Security is an ongoing process. It will always be an ongoing process. There are operational aspects, there are design aspects. So make sure you're continually addressing that, evolving your design and so forth. There are two references that I think are worth mentioning here. One is the book Accelerate, which I'm pretty sure everybody in this community's got. There is an open source tool for evaluating your DevOps efficiency there. The next one is of course the standard threat modeling book. This is this book is still kind of the gold standard in threat modeling in my view. So I've used both of these books, pretty extensively in this presentation. So at this point, nearly done, and we've got about 5 or 6 minutes left for questions. Jeff?
Mark, great talk. Thank you so much. I really enjoyed that. I took a lot out of it. One thing that I was thinking of throughout this was, I think of a scenario where you go in to consult with an organization, and there's nothing being done about security and application security. What are some of the easy kind of early victories to get an organization started to start along the path of thinking about this sort of thing?
Right. So I think the easy victories come with, I think, some, having some background. There are technical victories to be had, and then there are sort of business victories to be had. And the technical victories are finding that low-hanging fruit. Like, do they need to figure out how to rotate TLS certificates? Can you sign them up for Let's Encrypt? Can you show them how to use a password vault or a password safe to extract secrets out of their configuration files and put them into secure enclaves? Those are, those technical blocking and tackling things are really easy to show teams how to do. So those, from a technical perspective, those are the sorts of things that you should look for. From a business perspective, I think what you can do is you can say, look, we've done some technical things here that have improved security, and we can demonstrate that. Say we took a day to go do this, and it took, say, 2 developers of time, and so that's this cost for that. But the value that you get for that is these sorts of threats that have been mitigated. And so having a good sense of what a typical threat model and threat landscape looks like, and describe that to business executives, they begin to get the picture as you describe what a real good threat landscape looks like. And that, there are common attacks that are going to affect them, and that you've mitigated many of these common attacks through doing certain things. And those attacks have a huge potential downside. And the work that you've done has only cost them a very small fraction of what they expect. So at the CISO gathering that was hosted by the ISSA, one of the things that was mentioned was, how big a security budget should be for a project and for teams. And, the number 7% to 10% was considered kind of a baseline. And so if you can show that that baseline can be spent effectively and bring an ROI by reducing the threat landscape and reducing your potential risk downstream, that's a big win that executives can understand.
Great, thanks. We have a question coming in from Hasan, actually. He's asking, how can we handle threat assessment under an iterative approach without knowing the overall system architecture?
Well, so I think your threat assessment comes with sort of some generic things that we know systems typically have, and then a detailed threat assessment can follow as that architecture evolves, right? So if you've got a system that is, say, transferring data from system A to system B, that's that data has got to be encrypted in one way, shape, or another. That there's got to be strong identity somewhere in there so that you're not transferring data to the wrong system, or if you're receiving data, you're getting it from the right upstream system. So what these things are gonna happen, and so you can iterate on the high level architecture as that high level architecture becomes more detailed. So you can talk about, in that high level architecture, you're going to have some ideas of where you're capturing data, where you're storing it, and so forth. And so you can begin to think about that. If it's business partners, you can think about those connections to the business partners. If it's a cloud architecture, you can start looking into the likely places of storing data in the cloud architecture. You can look at the likely ways that data will be transferred between microservices and make evaluations about things that you think you're going to need to do. And then as those designs begin to become much more concrete and more detailed, you can iterate and refine your architecture down to those concrete steps. It seems like the threat modeling just follows the level of detail that you're given. Good question, Hasan. Thank you very much.
Yeah, great points. Thanks, Mark. I think we're pretty much out of time here. Again, Mark, I want to thank you for joining us today. That was a great presentation. I think you hit on a lot of important aspects of application security. I also am very interested in the cultural implications of all this. So thanks for discussing some of the points there. I think you mentioned the easy wins, and to me, you're kind of creating good habits with your dev team and working towards like adopting a more, security minded culture for your application. So again, thanks for joining us today. We're going to take a break now, 10 minutes. We'll be back in 10 minutes with more DevSecOps Days. Thank you. Welcome back, everybody. Again, thanks for joining us for DevSecOps Days. I'm Jeff Hammond, a DevSecOps engineer at the Software Engineering Institute. Our next speaker and our last speaker for the morning session here before we take a lunch break is Joel Tosi from Dojo & Company. Joel, please.
Great. Thanks much. Wonderful to meet you all. And we will just jump into this topic, talking around culture shifting through learning. Quick background about me, just so you know I'm not just somebody on a screen. Long story short, spent a lot of time in the engineering space, developed trading platforms in Chicago, worked at Red Hat as an architect. But really, like the last decade or so, been working with organizations on how to make it easier for people to learn, make it easier for people to do great work. And it really spans the whole spectrum of product, technology, and process. And that's what I want to talk about, is this idea of helping people learn and do the great work that they can do, and how that impacts culture. So before I even get too deep into it, I want to make sure I give you my perspective on culture and why I take this view of it. For me, culture is a shadow. It's a shadow of the way that we work. And so using that metaphor, that culture is a shadow, just like if you want your shadow to be different, you can't just work on your shadow. You can't just put chalk on the ground and say, now my shadow's better, now I'm perfect. You actually have to work on yourself. And so if we think about culture as a shadow of the way the work works inside of our organization, the only way we can truly change the culture is to change the way that the work works. The best way I found to have that happen is by embracing this idea of learning and making it easier for people to do work. Then the culture changes and your shadow changes and everything starts to fall into place. So before we talk actually about what we need to do to create these learning situations and make work easier for everybody, let's talk about our current world. Let's not be blind to what's actually happening in our organizations and our products and our teams right now. We're at DevSecOps Days, right? So we know the world is complex. We're building vast systems, crazy systems, distributed systems so big that we can't even keep them all in our cognitive load at the same time, or in our memory at the same time. We can't perceive the complexity of the systems that we're working on. Taking it the next step, the systems are working with people. People interact with our systems, and people are building the systems, and people are complex. We don't know what they're going to do. We don't know how they're going to interact with their systems. On top of that, we are building things that have never been built. And we're building products and systems that have never been built with tools that have just been built. So any idea that there is going to be any sense of certainty, or that we know exactly what's going to happen, is out the window. We're building things that have never been built we're building complex systems that have never been built, interacting with complex people with tools and using tools that have just been built. It's a complex world. Again, with this idea of complexity, there is no one way to solve a problem, right? There is no one way to solve a problem. There is no magic spell. There is no magic certification or framework or something that just says this is how it works. If you do this, then your products will be secure. If you do this, your culture will be better. You can't use views from decades past to say this is how we should do things. You can't assume certainty in a world of complexity. Multiple ways to approach a problem, highly complex environments. The best we can do in complex environments, when we know there is uncertainty, is embrace exploration and embrace learning. Last item to be aware of in our worlds and in complex domains, this idea of explicit knowledge, where we can explain everything and just put it down into documentation, put it in wikis, put it in Confluence. I can tell you all of the knowledge. I can tell you how to secure your apps. I can tell you how to deploy things. That's out the window, because complex domains aren't simple, aren't exact. There isn't direct cause and effect. On top of that, because we have complex systems, it's hard for us even to explain how we know what we know. We've experienced it and we've created it internally. So this idea that I could tell you what I know and you could just consume it yourself by reading it, again, it's not how knowledge works in complex domains. So we need to be thinking about knowledge is a means of changing culture, but also acknowledge that knowledge isn't something as simple as I can just hand it to you and now you have the knowledge. We actually have to go about creating knowledge, and creation of knowledge is a personal event. So again, using knowledge, using this idea of making work easier to change culture. To do this, we have to think about what our options are. Now, I'll tell you in my experience, this idea, whenever anybody says they want a different culture, fundamentally it comes down from this recognition that there is a performance gap. No organization, no company is saying, we are the best company ever, but we want to change our culture anyway. Typically what's happening is somebody has identified a performance gap. A performance gap could be something like we are not executing as well in the market as we want. Our products aren't consumed as well. Our security isn't as high as we'd like it to be. Our quality isn't what we want it to be. There's a gap between our desired performance and our actual performance. This tends to be the motivating factor for a cultural change, right? Or a change in how we want to go about working. Now, typically, this is the standard approach. We've acknowledged there's a performance gap, and so we increase the pressure to do work. We don't have enough, we're not happy with our security, so let's increase the pressure to have more security done more frequently. And all that does is we increase the amount of time we spend working, which, as you all know, will increase performance in the short term, but constantly burning people at 100% utilization is not a long-term solution. You get burnout, you get people leaving, those type of situations. You run people too hard, the quality overall goes down. Like this idea that we can just increase the pressure to do work will work in the short term, but this work harder loop is just a fallacy. This doesn't change your culture. This might just make it worse. The better option is this idea of reinvestment. We've discovered a performance gap. We want to have something different in our organization. We want to shrink this performance gap. We want to improve our culture. That creates, instead of a pressure to do work, it creates a pressure to improve. Now, the pressure to improve isn't meant to be like the stick, right? You need to get better. You need to get better. What it actually needs to do is, by increasing the pressure to improve, we need to increase our time spent improving, which then increases our capability, which then increases our performance, which shrinks the performance gap, which changes our culture. As soon as we start focusing less on getting more stuff done, and we start focusing more on how do we make it easier to get things done, the world starts changing. Our views of the world start changing. And this reinvestment in our capabilities is a fundamental approach to doing this. But there are some things that have to be in place for this to be an option. You can't just say, we want to get better. There are some fundamental items that need to be in place. Here's, based upon my experience, the 4 areas that I see in organizations that want to increase their performance, that are creating time to improve, to lead to a cultural change. These are the items that are in place. An idea of psychological safety, repetition, experimentation, context and experiential learning, and social dynamics. And we'll get into these 4. This is the meat of what I want you to be thinking about. When you're thinking about, how do I make it easier for people to do work? How do I learn how to make it easier? These are the items that need to be in play. I would be remiss if I didn't mention a dear friend of mine who passed a few years ago from cancer, a gentleman named David Hussman. If nothing else, if you haven't heard of him, my biggest takeaway for you would be to see what you can find on him. He had many nice videos and thoughts that he shared, but he had this really nice saying: the difference between failure and learning is how much it costs in either your ego or your money. I always found this interesting, because every organization says that they're a learning organization. We embrace learning. We want to learn. We fail fast, do all of these sayings. But the reality is, nobody would say, well, we wanted to launch that satellite and it cost $1 billion and it didn't work, but man, we learned a lot. Those types of situations don't really happen, right? So what we need to do is, we actually need to, if we want to be a learning organization, we want to make things, make improvements in how we work, we have to make it so it's safe for that learning to happen. We have to make it safe in the cost organizationally, and we have to make it safe from our professional perspective and our ego. Dr. Clark wrote this wonderful book, The 4 Stages of Psychological Safety. And the takeaways here for you are, is if you want to be a learning organization, if you want your culture to change, where do you kind of fit in this spectrum of psychological safety? Now, at the very top, you have this idea of challenger safety. If you want the culture to change and you embrace learning, then it has to be safe for people to challenge the status quo, how things work, right? We talk about culture being a shadow of how you work. Is it safe for people to challenge how things work, challenge the status quo without it being a problem? That's like the level 4, the utopic space, right? Moving slightly downwards, this idea of contributor safety. Can people learn on their own within certain guardrails of what's that's safe for the organization and safe for the people? Are people allowed to learn and explore on their own ideas? If that's obviously a fundamental need before you can challenger safety. To have contributor safety, you have to have basic learner safety. Just the idea that it's okay for people in our organization to learn and they're open to learning new ideas. Now, learner safety is fundamental. All of these items are fundamental to change your culture. But this idea of inclusion safety, if that doesn't exist, everything else is again out the window. And now when I talk about inclusion safety, there is this, it's safe for me to be present with the team. It's safe for me to explore ideas. But here's where I see organizations struggle with this idea of inclusion safety, is they'll talk about, they'll define people by their roles. So the engineers can't deploy. They can't learn about deployments because they're an engineer. The testers can't learn about engineering because they're just the testers. I would even take it potentially a step further and talk about if you have partners, do you segregate, do the partners not feel that they're included in your decisions because they're partners? And so if we want to change our culture, and especially if we want our partners to be part of that change, do they actually have this idea of inclusion safety as part of us? So again, changing the culture, changing the way we learn, we need to have a safe space for that to happen. Moving further along, if you want new ideas to stick, repetition and experimentation have to be part of how your organization approaches learning and cultural changes. This is a very simple graph called the Ebbinghaus forgetting curve, over 140 years old. Here's it really simply explained out. If you learn something on day 0 and you don't apply it, you tend to forget it. If you learn something and you apply it the next day and you apply it the next day and you continuously apply it, it tends to stick. The reason why I bring this out is many organizations talk about wanting to change their culture, and part of what they do is to change their culture is they send people out for training, but when they come back, the people can't apply the training. And so that's people aren't, and then a month later when somebody says, why can't you do that? Well, I haven't had to do it for a month, and so I don't exactly remember what it was. And so if we want to change the culture, we want to embrace learning, people have to have repetition, experimentation as part of the natural habits of how they work. Along those lines, learning can't be an outlier. If we want to change the culture and we want to embrace learning and making it and continuously improving and making it simpler for people to do the work, we can't make it be just a one-off event. We can't just have hackathons that say, we're going to have a hackathon once a quarter and we're going to learn how to do things differently. It has to be intentional. Statistically speaking, if your learning events are 2% of the time, then business as usual is the majority. It wins. The learning is the outlier. So we need to make the learning be just how it always happens. We're always looking at improvement. And again, tying this back into complexity, there is this static thinking fundamentally fails in dynamic environments, in complex domains. There is no such thing as a best practice in complex domains. We're building things that haven't been built. There aren't best practices. There are emergent practices. There are things we can observe happening that are making situations better, but there is no checklist that says if you do A, you will get B. So again, we need to embrace learning and embrace making things simpler, especially in complex domains. When you want to become a learning organization that changes your culture, you have to embrace the complete value stream. Very simply, the first way to look at this is, in this diagram, you can see general boxes. right? There's some idea, we've discovered some idea that for a customer, we're thinking about how to build it, how to plan it. We're starting to build the code a little bit. We're trying to deploy it. If we are not looking at the whole value stream, very simply, we tend to optimize the wrong part of it. If you want to have a better culture, but all you focus on is the deployment and operations, that's in essence ignoring how the whole value gets delivered to your customers. So if we want to change the culture, we actually have to embrace the whole value stream. How do we actually collectively go about delivering value to people and to organizations? On top of that, learning is complementary. So if you just, like on this previous slide, if we just want to get better at deployment and operations, we run the risk of sub-optimization, isolation of skills. But the other interesting item is that these skills actually complement each other, right? So like we're talking about DevSecOps. The best way to get better at security and better at deployment and better at development is to have a good context of what's the problem we're actually solving? Why is it interesting? How is it being used? What's our risk vectors? And all of these skills and these contexts actually help each other. If we think about just a little piece of our problem, then instead of trying to secure everything, we're able to talk about the security in a concrete example in a small slice, and we can talk about the architecture to build a small piece, and the operations and the deployment all make sense together. But if we optimize each aspect individually, we overbuild and we lose the value of how these skills actually help each other. So again, we want to change our culture. We have to focus on the whole value stream. Skills are complementary. To learn effectively, we have to see how the skills intersect. And these things, these approaches are fundamental to change your culture and to make it easier for people. Experience matters. We talked early on about this idea of explicit knowledge versus tacit knowledge. Here, this picture here is my arm. So it is, I have a tattoo. And here's the story behind it. I was talking to my tattoo artist and I said, Ben, how did you become a tattoo artist? With hoping that his answer wasn't, I was really good at drawing in high school and I decided to make it permanent on people. What he told me was, he had to have experiences. He couldn't just read about tattooing. He couldn't have somebody else tell him how to tattoo. He had to have different experiences. How does different ink work with different skin? How do different needles work? And he had to build up his technique and his practice there. I mention this because we can't assume that we've documented everything in SharePoint and then people will read it and they will be able to take in the knowledge again in complex domains. If you go to a tattoo artist and you ask them how they learned how to tattoo, and they said, I read about it in Confluence or I read about it in SharePoint, don't have them put a tattoo on you, right? You want them to have experience and practice. With the products that you're all building and in trying to create a different culture, we need to give people time for experiences. We need to give people time to practice how to get better. And they need to do it by experience and not just by reading. Last concept is about this idea of social learning. We all build and deliver and support ideas and systems together. So the idea that we should learn individually is silly because we don't do anything individually. We build things together, we support things together. And so this idea that if you want your culture to change, we need to embrace that the way we work is the way we learn. And then the way we learn is the way we work. And then we're looking for continuous improvement in that way we work. And so that we need to model this learning in social ways as well. I tend to have teams do this through a variety of ensemble programming, group level learning and doing their work together, again, cross skills. But here's the other benefit of it, because most of the times when I'm working with groups on learning how to learn together, somebody will say, why am I watching somebody else do something? I'm a back-end engineer. Why am I watching the security person talk about security? Or I'm a security engineer. Why am I watching the deployments people talk about deployments? There's a variety of reasons. First and foremost, we can talk about mirror neurons and the fact that just because I am not actively engaging in the activity, I am still learning from it. And so this was based upon Don Hebb, this Canadian neuropsychologist, his research around mirror neurons. Just by seeing people do the activity, we also learn as well. There's also a secondary benefit. By watching people apply new techniques, if I'm a security engineer and I'm watching engineers apply techniques, I'm also learning what's hard for them about it. I'm also building empathy for how they go about solving their problems and how they approach their problems, and it's vice versa. And so there is the benefit of the skill growth, but there's also the benefit of the empathy growth. I have a better, deeper understanding of how they work. And so again, if we want to make it easier for people to work, we need to have this idea of social learning together, social aspects together. We can help each other make our work easier, which leads to a better culture and a better outcome. And look, if nothing else, it tends to be fun. You should have fun at work. You should enjoy the people you work with. 9 times out of 10, when I've worked with groups that didn't normally work together or they had some animosity, I don't really want to talk to the security engineer because they always fail my stuff and say I'm not doing it right. You know what happens after about a half an hour of working together? They are friends and they enjoy working together, and they create this empathy and this shared understanding, and they want to get better together. And it's just a better way of working. You all are building wonderful products. Again, new products that haven't been built, new ideas that haven't been built. The energy should be towards that and not worrying about kind of like the bad aspects of your culture. I don't want to talk to them because this is how they view the world. Bring people together and good things happen, and the culture starts shifting and wonderful things start happening. In closing, I would leave you with these things to consider. Knowledge and culture are not a thing. Knowledge can't be transferred. Knowledge can't be managed. In complex domains, we can't write things down. We can't write down our knowledge and hand it to the next person, and therefore they have the knowledge and they're perfect. It's better to talk about knowledge creation than knowledge transfer. How do we go about creating knowledge for people? Through using some of these aspects we talked about: safety, experimentation, repetition, context, social learning. Create environments where knowledge creation can happen. And again, the culture cannot be directly worked on. It's a shadow. So if we focus on making it easier for people to do their work, learning how to do work, and it's spending that time on improvement, then you'll get to this, you'll start working on your culture, which will then make your shadow better. You'll work on the way the work works and the shadow becomes better. So again, please think about creating conditions that foster knowledge creation to happen, that foster simplicity in work, and you'll get the culture you want. Where to start? It's the simple, I think it's a Chinese proverb: the best time to plant a tree was 20 years ago. The next best time is now. Here's my recommendations for organizations that I work with. Like if you're at that executive level, you're at the organizational level, where do I start? Start by thinking about how do you invest in time to improve, and not just pressure to improve, not just the pressure to get more work done. At the organizational level, look at systems learning. What's the systems? How does the work actually flow? And what's hard about the way the work works for our organization? And what can we do systematically to make it easier for people to do work? At a managerial level, think about creating safety for your employees and your direct reports. Provide them more context and more opportunities to learn. Run set-based designs and not just assume that the first decision is right. Increase this idea that we're here to explore. And if you're a team member, or you're a sole contributor to a team, think about asking for more context or seeing if your team can work in a more social learning aspect, and using those mirror neurons to see how you can learn together and share better ideas. All of these items you can do on your own. We just have to want to start. Continuously learn to make it easier for people to get their work done, and you'll get the culture you want. That's my utopic statement. Here's a disclaimer. If you continuously learn to make it easier for people to do their work, and if you don't get the culture you want, I guarantee you, if nothing else, you'll get a better culture. If people are happier, it's just a good place to be. And so, if nothing else, let's make it so people enjoy their work more. In closing, everybody loves Deming, especially in the DevOps space. I'll tell you the same thing I tell every organization I'm with. You already have the best and the brightest. You don't need 100 consultants and contractors to tell you how to do things. You already have the best people inside your organizations. We just have to make it easy for them to do it themselves. Embrace learning and embrace this idea of simplicity and create a better culture, and you'll do wonderful things. That's all I got. We got 5 minutes for questions. What do you got?
Joel, thanks so much. That was a great talk. I think I like the high level concepts of what you kind of need to learn to create this culture. One thing I did want to see if you could kind of elaborate on a little bit is, what are some of the measures that you use to kind of gauge, is there a positive cultural shift in a group? Can you speak to those?
Measures are hard in a positive cultural shift. Those are one of those items where sometimes it's more observational than it is, quantitative, if that makes sense. Some things that I've observed with teams, and this might sound silly, but I'll observe the language in the teams shifting from I to we and shifting from them to us. And it might sound really silly, but if we're in an organization where whenever we're talking about a problem, the language defaults to they wouldn't let us do that then, that's very defeatist. But if the language starts shifting to here's what we can do right now about it, that's a team embracing and saying we have the ability to change the way we work. And I listen for language quite a bit with teams. There are some kind of like metric-y type things that we tend to look at. I like to look at how teams feel about the skills that they have on the team. Like, do we have the skills to be successful? And so we start with those kind of questions. And then we look over the course of time around the distribution of the skills. And so it's not meant to be, is everybody an expert? It's meant, and what we look at is the gap between the most skilled and the most unfamiliar, is that gap shrinking? And what we're finding is the correlation when that gap shrinks is we tend to get less burnout because nobody feels like I'm the only one that can do this, or we have to ask so-and-so for permission. And so we look to see if, are we able to shrink the gap in the skills across a team? And it's really interesting because, again, we're promoting the team as the learning unit. And so we're looking at team learning metrics, which I think then leads to like this, it's a leading indicator of a cultural change.
Thanks. So, yeah, I think people's attitudes change basically, right?
Yeah.
So, like you showed the slide, people are happy. It's hard to measure really, but it's a subtle indication. So we have a question coming in our live stream here. How do you suggest breaking down those institutional silos that impede communication and efficient flow of work?
That's a loaded question, huh? It depends. It kind of depends upon where it's coming from. Sometimes with some organizations, it's as easy as talking about some simple metrics around cycle time and lead time. And then we talk about, a lot of organizations don't know how much time is actually spent not doing things, not producing, because we're waiting and we're not allowed to get the information. So sometimes just collecting data around what's the biggest pain and capturing the data around it starts to create those shifts into wanting to provide more context. Other time it's just trying to work at a micro level and finding the questions we don't have the answers to. I used to do this, and I fully acknowledge I only got like 4 seconds here, so I'll go as fast as I can. I used to put up, when we were physically located with teams, almost like a bullseye, like 4 concentric circles. And when a question would arise, and so the inner circle was a team, the outer circle was the managers, the third circle was like the business sponsors, the fourth circle was the executives. But anyway, you get the idea. Is kind of like closest to the work is the center, and we go outwards for who has to make a decision. When a question would arise, we would talk about where does this question have to be answered in this circle, and we'd put it visually and see where it's at. And so that visualization wasn't so we would find out where to ask that question next time. That visualization was so we could go to that group and say, what context could you provide so the next time we don't have to ask this question? Because the tighter that loop is between we discover something and we have the information to make a decision, the faster everything moves for the organization. And so we were using that as a visualization to say, how do we push information down closer to the work? That worked really nicely as well. So a couple different ways of doing it.
Thanks. Well, that's about all the time we have. Joel, thanks so much. Great discussion. We are now going to take a 30-minute break. We have some great sessions planned for the afternoon. When we get back in 30 minutes, we're going to be joined by DJ Schleen for our next keynote. So again, see everybody in 30. Thank you.
Thank you.
be either morning coffee or lunch to move into this. You're going to get a lot of great speakers talking about supply chain specifically. And our first talk, our keynote talk for afternoon, will come from DJ Schleen. DJ, he's the distinguished security architect on paranoids at Yahoo, and he just got in that position. And I know DJ for a while, and DJ, he's always talking about some untalked topics, maybe under the hood, maybe some realistics and realities on DevSecOps. And today he's going to talk about the software bill of materials, but indeed, and software barrel of monkeys, which is SBOM. He's going to talk about that. I'm really, really eager to hear his talk, and he has been in that space and for a while. And he's one of the really key contributors in DevOps Kung Fu Mafia things in the GitHub space. And he's talking about kind of creating good tools and on the SBOM and also analyzing the file content on DevSecOps. I really encourage you guys to take a look at his GitHub space as well. With that said, DJ is a DevSecOps pioneer and advocate and security architects and provides and thought leadership in organization adopting DevSecOps practices. And I know him almost 6-7 years. And he is always the person to tell the truth about implementation. He is a real practitioner. Without further ado, I would like to hand over to DJ, and he's going to talk about the bill of materials, software barrel of monkeys. DJ, floor is yours.
Thank you, Hasan. Yeah, it's been great to be involved in the DevSecOps community for years. I started off talking at a DevOps conference about DevSecOps, and I think John Willis asked me if I was insane. Bringing that topic into a DevOps conference. But anyway, as Hasan said, I'm a distinguished security architect at Yahoo. I'm in the Paranoids organization. And I'm also founder of the DevOps Kung Fu Mafia, which is also known as DKFM. We basically make things that either don't exist or because something else doesn't really work the way we want it to. So this talk is about software bill of materials, and I call it software barrel of monkeys. We're going to talk a little bit today about what SBOMs are. We're going to talk a little bit about the Biden executive order. We're going to go into a bit of the standards and specifications that are used to describe these bill of materials. And then we're going to talk about some of the problems, and then, of course, what you can do, because there's certain things that you can do today to help manage these bill of materials. So I'm going to start off with a little conversation, little talk, a little story time about OpenSSL. And this was probably about the time I met Hasan, about 6 or 7 years ago, maybe sooner than that. But OpenSSL, there was a big vulnerability in that. So I think it was woken up around 3 o'clock in the morning. It was all hands on deck with the security organization. And we were trying to figure out, are we affected by this? Where is this issue or this component being used? And at the time, we had applications deployed worldwide. We were starting our journey into containerization. We had a lot of on-prem services and a lot of on-prem servers. And, trying to find out where this was at that time, pretty much impossible. So you probably can guess what we did. And if you send an Excel spreadsheet around to everybody to try to figure out what we had, that's absolutely right. So we sent out an Excel spreadsheet asking for what component, version it was, what application it was. And you can probably guess what the answer was to all the questions in the spreadsheet. We're not using them at all. So that was a little bit shocking. And at that time, it really hit me. It's this is a big problem that we're having right now. We don't understand what's in our software. We don't understand where it is, and we barely understand where it comes from. And, you could replace OpenSSL there with Log4j. Same thing. We went through it again. So, I don't think the industry's really learned from, they're not mistakes, but just a lack of knowing where the software components are. So, the questions I kept asking myself is what's inside the software we create? And, when we build software, we rely on open source community contributions usually. When I was at Sonatype, I had participated in a bunch of community surveys, and one of them that came out, we got some information back that said 97% of all software that we create is not developed by developers that actually work for us. It's the open source community, and 3% of it is us cobbling this together to make our applications. So when we look at those third-party components, this is what we start calling the supply chain. It's how things come into the software, the things that we create. And that's one element of the supply chain. Where did it come from? Where did these components come from? It could be GitHub, it could be Stack Exchange, it could be open source, it could be closed source, it could be somewhere internally to our organization. Maybe not. And then the biggest question is, are there any vulnerabilities in the components we have? And again, where are they? That's the big question. I compare it to a parking lot of cars, where you look at a big parking lot in a mall and it's full of cars, and there's 2 spark plugs out there that are going to cause some problems, going to blow up the engine. Where are they? Which cars are they? And we can very easily find this out to an extent when we start doing inventory on our applications. So SBOM to the rescue, right? Software bill of materials, been around for a long time. And really all it is an ingredient list. So it could be nutrition facts or Washington Nationals baseball cards that have statistics on the back of them. What you're trying to do again here is define what gets included in your software. And I'm going to take you back to 1978. And, we can talk about the automobile manufacturing revolution, Deming at Toyota and GMC. General Motors, and bill of materials it's not an unknown concept. So when you think about how you assemble a car on an assembly line, parts come in from external sources, right? The tires might come in from BF Goodrich, if BF Goodrich is still around. They might come in from Chinook. They might come in from Firestone or Bridgestone. Like, they could come from anywhere, right? And then the manufacturer is one thing, but the vendor of how it got in is another thing, right? The provenance, and then where this thing has gotten in from. Mufflers, any kind of parts, back to the spark plugs, like what is inside of the car. And the reason why they do this is not because it's cool and we have an idea of where our parts come from. It's what happens if there's a recall on your car, right? What cars are affected? How do I get in touch with these people? Where did they purchase the vehicle? And where did these parts come from, and what parts do we need to provision or acquire, procure to actually fix this issue? So, here's like a window sticker from a 1978 Jeep. And as we can see, there's a lot of information about what features you get, but behind those features is a whole bill of materials for that vehicle that gets housed inside of, the automotive manufacturer. And I think we can take a lot of lessons from the manufacturers on how they manage and maintain these bill of materials. Because I think that's one of the problems that we have today. And I'll get into that a little bit later. So let's talk about the order. In 2001, the Biden administration came out with an executive order that basically encapsulates, it's pretty long, and I'll let you guys read it yourselves, but it encapsulates a bunch of different concepts of how the government's going to deal with cybersecurity, perimeter, internally, and there's a whole section on the open source component of the supply chain. I'm going to dig into that a little bit, but what's the effect of this order? Anybody who sells services or products, software products to the federal government has to provide software bill of materials or attestations and documentations about other security practices that they do in their organization. So think about it this way. It's like a third-party risk governance scenario where you're providing that organization with information, or the government entity with information to actually make decisions if they're going to purchase the software and what they're getting. So it's a great start to defining a software bill of materials. And we'll go through a little bit of the executive order, especially when it comes to software bill of materials. Now, this is definitely stripped down, but this area here, I'm going to highlight a couple points. So, this bill of materials, or this data that the government's going to requires up-to-date provenance of origin of software code or components, right? So where did this thing come from? And not where it is, but where did you get this thing from? So that, again, could be GitHub, it could be an open source area, it could be closed source, proprietary. Where did this piece of software, this component of the application come from? You have to perform audit and enforcement of these controls on a recurring basis. Well, that's a great thing to say. It's a really hard thing to actually do, because one of these software bill of materials that you get is a snapshot in time. Every time you build software, change a line, change a character. Sometimes every time you do a compilation or a generation of a software bill of materials, you end up changing it. So the thing mutates, and then it's only as good again as your last vulnerability scan or the last time that software was deployed. And then providing the purchaser a software bill of materials for each product directly or by publishing on a public website. So there's some issues that happen with that. One is software bill of materials are the contents of your application, especially if you're using or if you're providing a proprietary product. That could be a privacy issue. Do you want to display this on your website? Right? There's some vendors that actually have it displayed prominently on their website. So one of them is Jupiter Networks. If you go to their site, they're one of the first companies that I've seen that actually put a software bill of materials in a standard format. I think they were using SPDX at the time to display what they actually contain or what they use. But other organizations might have a problem with that, where they don't want this to be public information. So there's some issues around that we're going to get into, but publishing on a public website, that's great. Contributing or providing it in a format to the vendor or to the organization itself, that's another that's probably what you're going to see coming in. Ensuring a testing to the extent practicable to the integrity and provenance of open source software. Okay, great. Again, where did it come from? Integrity. Has that bill of materials changed? And within any portion of the product. So all of this information and the executive order can specify timelines. So on the bottom here, we see that within 60 days of the order, there's an organization that has to come up with some minimum information about what a software bill of materials will contain. So let's take a look at that. So this comes from NTIA and Department of Commerce. They got this specification out. There's a link at the bottom if you want to check it out. It's the SBOM minimum components report. And we'll go through a little bit of what they have here in data fields. So supplier name. So entity that creates, defines, identifies. So this is the organization where it comes from. So this could be, in the case of what we do at DKFM, we're the supplier, right? It could be a open source group. It could be a component that's published by a company like Sneak or Sonatype or something like that we use and we ingest into our system. The component name, log4j. It could be, not jQuery. Well, it could be jQuery. I don't know if anyone uses that still, but it could be anything like to that effect. Go color or something like that, or these little pieces of functionality that you're bringing into your application to provide extra functionality that you don't have to write yourself. The version, this is very important. The version of the component and the component name, and then the package ecosystem that we use, those define something that we can actually scan for vulnerabilities. So the version is very important in that, because each version, it could have a vulnerability or could be remediated in a subsequent version, and then it could have another vulnerability later. So again, you're only as good as your last scan when it comes to vulnerabilities, but the version of the component is something that is integral to identifying problems and also identifying where it is, right? Component name and version, where is it in your enterprise? Other unique identifiers. I don't know what the heck this means. So, after spending a lot of time programming vulnerability scanners against SBOMs and SBOM creation tools, look at this and, there's a lot of identifiers inside of, a Cyclone DX or SPDX format or, within the standard formats. But a lot of that is just additional information that's at the, at the discretion of the manufacturer or the creator of the SBOM. And then dependency relationships. This is one that makes it look really easy to say that, the upstream component has, an X has a relationship or contains software Y. This gets a little messy, But this statement, having that dependency relationship is definitely important, because what we want to understand is what components are we using, what components, what indirect references or dependencies those components have, and then the transitive dependencies that those have. So that's the kind of relationship that we want to get to. And it's definitely not linear. And then the author of the SBOM data. So this is usually the tool that generates it. In the case of using any product or any CLI, whatever generates it, it's a little field that gets stuck in there saying, this is the tool, this is the version of the tool that created this SBOM. And then of course the timestamp, when was this SBOM generated? And like a vulnerability or like a build, it's a snapshot in time. So, in the minimum information, they talk about provenance and they talk about integrity. And one of the big ones is license information, but these aren't in that minimum specification. And I think that they should be, because I think it's important. And a lot of the industry is moving towards coming up with solutions to actually do this. So this is just going to be, you're going to get this when you start generating these bill of materials. So provenance. Who is it coming from, and do we understand and know that supplier of this component? We can achieve that by using certificates and signatures. The integrity, do we hash that whole software bill of materials and understand that there hasn't mutated on the way to us? And then license information is huge. So think about bringing in a very restrictive license. You could be instantly open sourcing the software that you create because of the license that actually is provided inside of that open source component. So we'll take a little bit of time and talk about the dependency relationship. So again, we talk about supply chain, and this is very common in DevOps and DevSecOps. When we start building our components, there's different ways that we can control the supply chain and components coming in. We can use a component firewall or proxy that ensures that anything that we bring into our organization gets scanned for vulnerabilities and can block based on policies. We can talk about, there's situations where developers just bring something in and there's no review of these open source components. And I think that's where one of the biggest problems with building software, I don't think we really solved it today. We can have these proxies, but you have to be on an internal network to do that. With a work from home environment and what we're doing now post-COVID and during COVID, we're working at home. We can pull in components that don't go through our standard security processes. And when you look at the supply chain, a lot of people think it's linear, but it's really not. And this is where the monkeys come into play, because you have Y includes X, right? So this is, or X includes Y. It really doesn't matter how you look at it. This is one of the things that the government stated in their minimum requirements for software bill of materials. But it's not that simple, because Z includes B and D, A includes C and D, B and D, and oh my gosh, it just gets too complicated, right? It's just a bunch of monkeys at that point. And some of these components are vulnerable. Now, again, this is like, think about, you have a piece of software that you're creating. And when you're creating the software, you pull in a couple components. Well, let's say you pull in two components and both use log4j, and they're two different versions. Maybe they're the same version. Well, now all of a sudden, both are dependent on one. So you start looking at a directed to cyclic graph of all these dependencies. Now, throw this in front of somebody who is, not necessarily technical, and how do you describe that to your third-party risk governance group, your GRC organization? Traditionally, maybe a little bit technical, but not fully technical security folks. And I'll give you an example. So this is a DKFM project. It's called Bomber. We'll talk about it again a little bit later in this presentation. It's one of the only applications that scans software bill of materials for vulnerabilities. And it's something I created because I was frustrated not knowing what I was consuming. Dan Walsh was a CISO that I worked with for many years at numerous companies. And, the security organization, Dan and I and Julio Jimenez, we talked a lot, and we're all members of DKFM. We talked a lot about how do we start ingesting software bill of materials from our vendors. And we would get them, and then we're like, what do we do with them, right? So, we start looking at Bomber here. So we have 12 direct references. So these are actual pieces of software that I'm pulling into Bomber to actually provide some functionality. So for example, Cyclone DX Go. This is all the schemas and all the objects and structs around Cyclone DX format. A spinner, so I can make things look, a little spinner that says, hey, wait type of thing. Color, so I can output color to the command line. It goes on and on. Testifies a test case harness. Now, the indirect references are the dependencies that these direct references rely on, right? So here we got 12 direct references. And even though I didn't import or use any of these in my code, these 16 indirect references come in. Now, where the problem really gets larger is the transitive dependencies of all of that we just brought in. So those 16 indirect references have 511 transitive references. Now, try to figure that one out, right? There's definitely a lot of data here. And when we look at this, we're like, okay, what do I do with this, right? We have versions in here. We have a package name. And so, for example, at the bottom, we have, cates.io utils and a version for it. Perfect. And then a hash. Well, that's awesome. This is not a SPDX or Cyclone DX or anything of the software bill of materials. This is just your dependencies. So this is Golang. We can look at NPM, package lock, pom.xml, like all these different languages pull in, Java, Python, there's PyPy dependencies. They all pull in different kinds of product and applications. And so, this is not just a language specific issue of trying to figure out your inventory. It's across all languages. So how do we describe these in a way that's portable and interchangeable and interoperable? Well, so we have some specifications here. NIST started this whole thing off in 2009. Again, this is not something new. Even though we still really don't know what to do with any of it, it's not something new. They revised it in 2015, and this is the SWID format. This is more used from what I've seen, and not software necessarily, but it's tagging, and it's not structured. It's hard to work with when you're developing software for it because it's not structured like JSON or XML. SPDX came out in 2010. They got a couple of different formats that they deal with. So they have a JSON format, an XML format, and then a key value format. And even though the key value format is extremely readable, it really doesn't lend itself to automation and actually dealing with the content of that file. And then we have Cyclone DX. That was OWASP, came out in 2017. I love this specification. It encapsulates a lot of the minimum requirements, and then a lot of the extended requirements like signing, attribution, all these kind of provenance issues, integrity, both handle licensing. And then we have SIFT from Anchor, and it's not, I wouldn't consider it necessarily a format. Like when you start asking vendors or you start generating software bill of materials, chances are you can use Cyclone DX or SPDX. You're not going to use SWID, and you're not going to use SIFT. SIFT is a great format though, because it pipes into some other tools that Anchor creates. And I use this in DKFM a lot so that when I generate code or I build code, I use SIFT to generate the Cyclone DX or SPDX software bill of materials. So SIFT is more of a tool, it's a format, and it also generates and converts between different SBOM formats. Now, this one surprised me. The SPDX specification, version 2.2.1, is an ISO standard, which is great, but version 2.2.1 is missing a ton of functionality. And again, this is the volatility of the specifications as they start being matured. I'm really surprised that Cyclone DX isn't an ISO certification or ISO specification. Version 2.2.1 is old. I think we're up to 2.3. And I think that there's a new major version coming out. And again, SPDX, I think, is trailing Cyclone DX, but it's almost like a browser wars where, you're looking at, I do one thing, you do one thing, now I'm going to do what you do. And it's a little bit of a mess. So I look at this and I think maybe we're too soon for all of this, right? And here's some issues, a list of issues, and I'll talk to some of them here. Again, the standards change very quickly. I remember writing an SBOM generation tool for DKFM about a year or two ago. And again, there was just nothing out there. Now it's almost like a commodity where you can generate these SBOMs. But I remember doing something for Cyclone DX 1.1, and then 1.2 came out as soon as I released it. And there was some things that broke. Now, it wasn't a bad thing. But again, it's the volatility that sometimes is concerning, because if you're exchanging SBOMs, like exchanging those baseball cards back and forth, if the specification changes and you can't read it, you've got a problem, right? And that interoperability, somebody might send you an SPDX format. You might have tooling that only processes Cyclone DX. So there's some conversion tools out there that convert one to another, but they're very lossy. They have a tendency to lose some data because there's, data in both formats that just isn't portable. It's getting better, but again, it's not standardized. And I think as an industry, we need to have a format to rule them all. I would love those organizations to merge together and say, hey, let's just figure something out for the industry that's standardized. So you generate them, right? A lot of folks generate software bill of materials. Great. Now what? Do you give them to somebody? I think it's great to create that artifact and include it with a release. But again, like once you get this baseball card, you just look at it and say, okay, great, I'm going to put it into a binder and forget about it. A vendor provides you one. What do you do with it? Let's say the vendor is the federal, selling to the federal government. The government takes a look at this and says, okay, thanks. What do you do now, right? Do you scan for vulnerabilities? Does that make it into your decision process on what you need to do? If you're going to purchase something from this vendor or not, that's really, there's not a lot of processes around that. When we were doing this at, when I was doing this with Dan Walsh, we would get these things in and we would like scan them for vulnerabilities, but we'd do it manually. And then we'd have it, and you know what? A version would come out of that software, like minor version or whatever, and that software bill of materials was invalid. We had to do it all over. So, there's some tactical issues of dealing with SBOMs. And then, of course, one of the original problems that I had when we were talking about OpenSSL earlier was where are these components? So a lot of folks merge their software bill of materials for multiple products together, and they have this one big thing. This is all the stuff that I have. Well, great. Where is it? You've lost it all by merging it into one. So again, we got some practices we got to figure out. Updating, delivery. How do we get these things? How do we update them? How do we secure them? And again, like the supply chain isn't linear. So those are some issues that we're definitely looking at when it comes to dealing with software bill of materials. Now, what can we do here? We're getting these things are out there, everybody's talking about them, they're the hottest topics since sliced bread came out. So what do? Well, first thing first, we use software composition analysis, which we're using, or we should be using right now, to scan our third-party components for vulnerabilities. But what we do is we actually use those in our DevOps pipelines after we build the application. Could be anywhere, right? To check the source out in the GitHub workflow. When we have that source, we can call SIFT. It's a GitHub action that can create a software bill of materials. We attach that to our release. So this is the generation process. When I first wrote Bomber, I had a lot of feedback saying, hey, well, can't I just do this with open source? Well, Bomber's for closed source, right? These are the SBOMs that you get, not that you give. So this is the generation side of the house. And so you can scan your source or open source, and you create a software bill of materials, and then build that functionality in your release process. So here's a release for Bomber. It's version 0.33. We can see that we have a spdx.json file at the top that gets packaged and built when that release gets built. So this is a snapshot in time. We can see that we have a identifier up here on it that says, okay, this is the version. And that's pretty much it. We've got some checksums in there for the actual files, but the software bill of materials, again, it goes with that release. So the nice thing about GitHub is you can pull the latest release numbers and you can pull the latest release binaries. There's like a raw content URL that you can use, but you can also have that URL to always hit the latest version of the SPDX SBOM inside your repository. So this handles the whole idea of the public distribution of an open source SBOM. You're probably not going to do this because you're not going to have your proprietary software publicly accessible. Now, what do we use for closed source? So this is when we consume a software bill of materials. And for this, again, this is, I think, a third-party risk governance task, or this is what group is really needs to understand what this is, because you have a third-party risk governance, or it may be just a normal security organization, GRC, whatever. But when they have a vendor that they want to procure software from, what they're going to do is a review. So they're going to send out a questionnaire. Do you do static analysis? Do you do open source software composition analysis? Do you perform DAS? Like all these different questions about how that manufacturer, that vendor creates software. Now, when you look at a software bill of materials, that should be an attribute to your decisions to procure that software, right? And it shouldn't be necessarily a, the de facto, hey, you got vulnerabilities or not. I think that's where a relationship with your vendors has to come into play, because a vendor is going to provide you these software bill of materials. Let's say it's part of a third-party assessment. You're going to get them. You're going to see vulnerabilities. You have your SLAs in your organization to remediate. Do theirs match? What happens when you tell them about this? Do you log a bug and wait for 5 years to get that critical vulnerability fixed? This is something that I've seen before. I remember getting a container from a vendor, and we were doing a third-party review on it, and I looked inside of it. So we had some scanning tools in container. We can look at the underlying file system, and there's 9 critical vulnerabilities in there. We didn't have a software bill of materials. We used some existing scanning tools because we had access to the inside of that. And when we talked to the vendor, they're like, okay, thanks. What are we going to do? You want to buy us or not? So, there's, again, some communication that has to happen with that. And then with those software bill of materials, you can use Anchor, and that's more of a container scanning tool. Like it'll take a SIFT format. This is by Anchor. It'll take a SIFT format, take any kind of format really, and it will process it and look at deb and RPM and give you some information about the security of the container. And then Bomber that, we wrote at DKFM, that scans everything. So it doesn't matter what ecosystem, because there's more inside a container than just the OS or the file system. The application that we write sits inside of there. Could be, NPM, could be Node, could be, a Go application, could be anything, right? So Bomber scans different ecosystems such as, Python, crates.io, scans for vulnerabilities in Rust, you name it. You provide an SBOM. Again, this is a closed source SBOM. You can do open source as well, and it'll tell you the vulnerabilities for it. And here's some output from it I just wanted to share with you, because these are some of the important things that you want to know when you're evaluating vulnerabilities inside of a software bill of materials. Ecosystem, are we dealing with Node? Are we dealing with Python? Maybe there's both, because some repositories or SBOMs might have multiple languages or ecosystems in there. SBOMs are huge. I'm not going to lie. You see a 750 meg SBOM, that's pretty normal. So, again, where are you going to store that thing, right? Now, processing these and finding vulnerabilities, like in this situation here, this SBOM that I'm scanning in the top left-hand corner, 840 packages. It's quite a bit. And again, you want to know the licenses in there. You want to know the vulnerabilities and the version and the component name. And then, of course, on the right-hand side, Bomber also puts a nice HTML report out that you can take and include that with your review of the vendor software and your risk assessments that you're doing. So some parting words before I wrap up here at DevSecOps Days DC 2022. What you should do right now, you can do this today, is generate and include SBOMs as an artifact with your releases. You may not need it, but if you're asked for it and you're working with the federal government, you can use it. If your repositories make up one product that you're providing to the government or providing to anybody, you can take those and merge them into one. And that software bill of materials you can provide out. So it's something you can do today. I definitely would start requesting SBOMs from your vendors when you're doing your security reviews. Have an idea of what you're bringing in. SolarWinds, I'm just going to say it. If you think about your DevOps pipeline, when you're running security controls in there, or let's say you're running Jenkins, what vulnerabilities does Jenkins have? Like, that's a closed source. Well, it's open source, but you can be using some closed source applications that actually interact with your code and could inject or be vulnerable to attack. And that's a pipeline, that's a production environment. Scan your closed source SBOMs for security vulnerabilities. Know what you're buying, right? Know what you're bringing into your environment. Are you bringing a Trojan horse in? Are you risking your customers' safety, PII, PHI, bringing a component in that has a vulnerability in it? Because all of a sudden, you're going to be holding the bag for that one. Storing the SBOMs in that shared artifact repository or appropriate access control and update it often. I hope that I can find, and if anybody knows it, DM me on Twitter, send me a message on LinkedIn. I'm looking for something that can catalog these massive files. Again, these aren't small, and let me search across it and say, I know that I'm using 15 versions of Log4j and 14 are vulnerable, and where are they, right? Because that'll help improve the quality of our applications when we hand that back to engineers. Work with the vendors, right? It's new for them, it's new for us. Our SLAs might not manage or map to their SLAs. We really got to take a look at this and say, this is a new world. And we have to work together to try to figure out how we're going to, deal with a lot of this executive order and these things that we need to provide in order to continue selling to the federal government of services and products. And how do we make things safer when we start dealing with our supply chain? So with that, thank you so much. Again, I'm DJ Schleen. Check out some of our code on DKFM and GitHub. And again, I appreciate your time. Hope you enjoy the rest of the conference and DevSecOps Days DC 2022.
Thank you so much, DJ. It was a great talk on talking about the bill of materials and the realities. I really like that you brought about interdependencies, because nobody's really talking about SBOM in that level. And I have been asked many times, actually, how can we handle the interdependencies? Like, I have one tools using the dependencies, I have another tools and other dependencies. Question was, how much go I dip as an organization? Do I have to create one layer dip on the SBOM? Do I have to go multiple layers? How can I do the interdependencies? I know you touched a little bit about that. What is your suggestion to the organization? They have to create an SBOM and every dependency components or higher level? What is your recommendation, DJ? Like, how much we can go deeper? Because we don't know how much we can go deeper, honestly. What do you think?
Well, yeah. Think about our SCA scanning tools, right?
Right.
We don't necessarily want to, we don't want to know one layer deep. We want to know everything, right? Because it's all contained in the application or the component. So, my recommendation is when you're doing an SBOM generation, it'll go through all your transitive dependencies. Mm-hmm. It'll just figure it all out for you, which is great because it gives that full picture. And the complexity of it comes when, if you're going to deduplicate things in there, right? So, for example, in Bomber, take all the pearls or all the identifiers for all the components, and I dedupe them so that, again, I'm just giving a picture of that SBOM. I'm not giving a picture of the interdependencies of it, because as I was saying, we could have two components using the same dependency, and that ends up turning into one. So now all of a sudden we have a triangle. Hopefully, it's things that we don't have to worry about unless we're actually coding for it. But the specifications have to deal with those relationships, because it's a mandate from the federal government in that minimum spec to be able to trace them. SPDX does it with external references, and then there's a reference node inside of Cyclone DX. So by default, you're going to get everything. And I think, that's going to cause big file issues, but it's going to give you the best picture of what you're actually bringing in and dealing with.
Okay, so we got that file we created as much as in detail. Do we done with the SBOM, or we're just going to create in a shelf and put in our repositories, then ignore it? Because I see people are really thinking, I'm going to create an SBOM file, that's it. No, right? That has to be beyond the creation of SBOM file. I think that what the DevSecOps comes in the picture. What is the relationship SBOM and DevSecOps? Since we don't have enough time to talk about, can you say a little bit, what is the relationship SBOM and DevSecOps, and how DevSecOps is helping to have the static SBOM creations, make it more dynamic as throughout the life cycle? Do you have a few words?
Yeah, think about this. We should all be doing software composition analysis by now. And if we're not, that's the first thing that we want to do when we're implementing security into our CI/CD process. So this is DevSecOps, right? Now, when we think about outputs of that, there's a couple of different things. We have outputs coming into a user interface that might go into our vulnerability management organization, right? So these are things that we have to remediate. We might have outputs from there coming into our pull requests showing that we have these vulnerabilities. We also might have automatic pull requests coming in that says, hey, here's a fix for this. You can hit merge and away you go. The other output of this, and this is an addition on the DevSecOps world, is creating that software bill of materials when we do a release. So that's extremely important. It's another output from DevSecOps, related security controls that we're putting into our CI/CD process. The problem, I think, is we can generate them. And as you said, it's like, what do we do with them, right? Well, we keep those with our artifacts and our versions so that it's like a snapshot in time, which is great. When we bring it in from an external closed source party, like a vendor, again, if they change their version, we need a new SBOM, right? So versioning of these things becomes a task that I haven't seen a tool out there that actually helps us with. So there's a lot of manual effort around just executing a lot of these processes, from a practical and tactical perspective.
That's interesting questions came up from the chat room. And before that, as you described, SBOM is generated, has to be part of our build and also the part of our deployment practices, as part of we deploy the runtime dependencies and build time dependencies. The question came from the chat, how can we generate SBOM from executables? Let's say we got executables, but we don't know any dependencies yet, but it is running in a production environment. Assume that we have some binaries that we acquire from third-party vendors.
Well, those third-party vendors, you're going to have to ask them for an SBOM.
Right.
So any of those, that's a closed source system. Now, if you generate an executable when you release, so when we release BOM or we create a Windows exe, right? We provide the SBOM with it. So, when we talk about ingesting these, we need to request that. And chances are, the vendor might not even understand what you're talking about, right? They're like, a software bill of monkeys? What? Software barrel of monkeys? Like, nobody really knows, right? But again, when we're building them and we're putting them in our release artifacts, and if we combine all of those artifacts that we're creating into one product that we're selling, we can merge all those SBOMs together and give a snapshot in time for that actual product compiled release.
Great. And I don't want to just giving an impression to the people, SBOM is just a file. There is a process associated. There's a governance associated. There is kind of the discipline and highlight that we have to get together, right? It's not just creating a file, if I hear you correctly, DJ.
Yeah, it's a file, and what do you do with it?
Right.
It's, do we put it in a binder like a baseball card?
Yes, that is true.
Who knows? I think that this is such a promising way of exchanging information about our software. I haven't even touched on Vex yet, which I think we're going to have a talk later on that's going to talk a little bit about that. But vulnerability exchange, how do we know that there's, there might be vulnerabilities in components. Maybe they're not callable, right? So there's a lot of noise here. Signal noise is a little bit hard, but again, we definitely got to start somewhere, and who knows where this journey is going to take us, because we're right on, the tip of the wave, right? We're on the tsunami, and we'll see how it ends up.
Great, DJ. I hear that there is another potential talk you and I will be engaging on that topic. With that said, I really would like to thank you for your time, your great insight of the software, Battle of Monkeys as an SBOM, and great vision. And thank you so much for your contribution into the community. I like the DKFM from GitHub space. I really, really like and enjoy so far. I'm a good part of the members as well. Thank you so much, DJ, for your participations. So as we are moving forward, and we have a next speakers in 5 minutes, and that speaker will be Alex Cross. He's going to talk about the escaping unicorn culture on DevSecOps pieces, and see you shortly.
Hello and welcome to DevSecOps Days in DC. I am Doug Reynolds. I'm a DevOps engineer from Carnegie Mellon University, the Software Engineering Institute. Kind of welcome to our afternoon segment of talks on DevOps. So I always appreciate DJ Schleen's presentations. They're always great and filled full of info. But we have our next guest speaker here. His name's Alex Cross. He is from Endava, and he's going to be talking about escaping unicorn culture. So I'm interested to hear his take on unicorn culture, because there's so many cultures now in software and development, and it's just going to be interesting. And right now he's a group head of DevOps in Endava, and he's been working, last 10 years doing all kinds of DevOps and managing that kind of capability delivery. So I'm going to let him take over and kind of let him give you his info and start explaining what the unicorn culture is.
Thanks very much, Doug. Hi, everyone. So as you said, my talk today is called Escaping Unicorn Culture, and I'll explain what that is in just a second. I had a quick intro already. This is on the conference site in case you want to hear more. But yes, I'm group head of DevOps at a company called Endava, and I'll say a bit more about that in just a minute. But let's dive right in. So here's what's coming up. As you can see, the first thing we're going to talk about is fantastic engineers and where to find them. Okay, so what's unicorn culture? Well, I have to say what a unicorn is first, and I don't mean the traditional kind of horse narwhal hybrid that we know from folklore. I also don't mean a sort of heroically successful tech company, although that is a related concept. What I mean by unicorn is some kind of rare breed of hyper talented engineer who can apparently handle a whole bunch of sometimes wildly interdisciplinary things comfortably. They always find a way through the challenges they're faced with. They're always super busy, and they don't often admit that there's a problem they can't handle. And I think most of us know someone like this, or who at least seems to fit the description. And maybe you'd even recognize this as a description of yourself, past or present. I've certainly been there. Not sure that's a good thing, though. At the very least, I'm sure you've seen those job adverts, the demand for an incredibly broad range of skills, responsibility, and of course, seniority, all in one head. Often correlating with membership of a rather small team. And I think unicorn is a good term for these kinds of people because they're sort of mythological. They're priceless if you can find them, and attempts to create more of them usually fail. They're certainly special and rare. But despite the challenges of finding somebody like this, it seems like most companies are advertising for IT roles that look very unicorn shaped. And actually, it seems like most DevOps roles, DevSecOps roles, and security engineering roles even are kind of unicorn shaped. So why is that? Well, we'll come to that in a moment. But I'll say in my role at Endava, we're a professional services firm. I see a lot of client requests for these unicorn skills profile. Most of our work is about designing, building, and running technology solutions to business problems, but these requests for unicorns, they're always purely requests for people. The customer doesn't have any particular objectives or strategic need. They just want one or two DevOps superheroes to add to their team, please. Now, we do have some incredibly talented people, so we do sometimes fulfill those customer requests, but recently I've been asking people to think again about that. Because if you're trying to make a strategic change, like adopting a DevOps or DevSecOps approach to engineering, relying on unicorns is not really the way to go about it. And I'm not saying that you shouldn't seek out exceptional people, but it turns out that, exceptional people are generally best reserved for exceptional circumstances. In other words, you don't need unicorns to be good at DevOps or DevSecOps. The idea that you do is driven by a kind of mythology and cultural habit rather than the facts. So today I'd like to look more closely at what where that unicorn culture comes from, the problems it creates, and a few ways that you might escape unicorn culture. But first I'm going to talk about blob-shaped people. And I tend to think of DevOps and DevSecOps as names for classes of operating model that organizations try to adopt, where the goal is to sort of maximize the flow of IT change without compromising on the stability, security, operability, quality of live systems. And an operating model, it's just a model of how various people, process, and technology concerns will be addressed in pursuit of a goal like that. Now, for those kind of DevOps models, the technology side, we focus on that very readily. The process side probably comes second, but the people side of this, the team shaping, the skills mix, helping people take ownership, handling out of hours cover, and instance, the shape of interactions between teams, it all tends to get left behind a bit, really. And this lack of focus on the people side is really the first mistake that leads us to unicorn culture. So let's talk about the people side of DevOps. And you've probably come across this concept of a T-shaped person, right? Which is the idea that you have, one deep area of specialism, but a broader, shallower competency in other areas. And in a DevOps model, T-shaped people are used to build cross-functional teams who build and run software or otherwise have some sort of common goal that's like that. And the people in the team need to be T-shaped so that they can take joint ownership and share the load. So finding T-shaped people is quite important to making DevOps work. But recently I've heard people talk about other shapes of individuals. So I heard about the pie-shaped person who's like a T-shaped person, but with two areas of deep specialism, and even the comb-shaped person who has a whole bunch of these areas of specialism. And the idea I heard is that organizations seeking to adopt DevOps should seek to build teams of comb-shaped people. But can you see where this is going? Because a comb-shaped person is really just a unicorn by another name. And actually, if we're honest, when we go hunting for people with a big long list of deep specializations, our requests are more often for what I'd call a blob-shaped person, who are just, specialists in whatever mix of stuff we decide we want today. And people obviously do specialize in multiple separable areas as their careers progress, and that's great, but I don't think it's core to making DevOps work at scale. You certainly need a big chunk of people to be T-shaped, and you need a good spread of specializations within a team if it's going to be cross-functional. But why do you need individual people to have multiple deep areas of specialization, past a certain limit? Why do all those specializations need to be in one head? Or to put it more broadly, why do organizations think that they need these kind of unicorn people rather than T-shaped people when they're trying to adopt DevOps? Well, I'm going to have a quick look at that. So I'm going to pick on three key factors that I think drive this. It's not the full list, but we'll focus on these three. So cost, industry groupthink, and organizational inertia. So, cost is the most intuitively obvious driver of this, of unicorn hunting. If you can find one unicorn that can do the work of 10 specialists, then it just seems to be a no-brainer that you should hire the unicorn, that you should prefer, a small team of unicorns to a larger team of T-shaped people. That is quite a shallow and problematic way of looking at things, but it seems to be sort of irresistible. And actually, I've noticed that cloud adoption makes people susceptible to this way of thinking as well. A selling point of public cloud is that you are outsourcing the bulk of, non-differentiating infrastructure heavy lifting to the cloud vendor. So you don't need so much in-house capability anymore. That's the idea. And that's certainly true on one level, but it also leads to the sort of seductive idea that you no longer need network specialists, data specialists, platform security specialists, and so on. All you need are, AWS specialists, Azure specialists, GCP specialists, cloud specialists, and there's your unicorn, right? Because cloud isn't really some homogeneous thing that you can master. It's a massive domain of often unrelated technologies. The cognitive load required to design, build, and operate a cloud solution can be immense. But, the bigger problem I have to say with viewing unicorns as an opportunity to save money is that DevOps isn't really about saving cost. That's probably most obvious when we contrast DevOps and ITIL, the operating models. They're both operating models for different purposes. ITIL is kind of cost optimized, and agility is deprioritized, whereas DevOps prioritizes agility, optimizes for agility, but it may be greater cost. And, don't get me wrong, you can end up saving money doing DevOps, but that's not really the point. So if you're coming at it from that direction, from that mindset, you're probably prioritizing the wrong thing. The point is to improve our agility. But beyond that sort of headcount reduction way of looking at things, I think groupthink in the tech industry perpetuates the myth of the DevOps unicorn. We've got used to this idea that these roles, DevOps unicorn people, are necessary because everyone's hiring for them and everyone's paying well for them. DevOps is more than some kind of technical automation activity. We all know that, but the most tangible sign of it that most of us see is the tools and the tech and the unicorn people that straddle all that. So if you ask most people in the IT world what DevOps is, they think of tech and unicorns rather than the old, you build it, you run it mantra where this all started. But unfortunately, what we really need to succeed at DevOps is a considered reworking of some major organizational concepts in IT, which brings me to the third cause of unicorn culture, which is organizational inertia. It's probably the biggest one. Organizations want to do DevOps. They want a simple canned answer for how to approach, people building and running stuff that doesn't create too much friction. Hire a bunch of unicorns and buy these tools doesn't sound like a complete strategy, but actually, facing the people and process stuff is scary and difficult. Now, a workable DevOps operating model involves traversing two common organizational silos, development and operations. A DevSecOps model treats security as a separate third silo in this picture, and many organizations are like that. So DevSecOps are trying to reconcile three different groups of people. But breaking down silos is really hard. So we go to unicorns for cold comfort. We seek out engineers who can hack their way through the organizational mire, automating as they go, sustainably or not. And this is what I'd call the go-between unicorn. But of course, using unicorns as a go-between doesn't really work in the end. So what we end up with is the substitute for dialogue unicorn. So rather than bringing DevSec and Ops together, let's just cut Ops out of the loop and let Dev hire some people that do all the Ops and security stuff. Meanwhile, some security unicorns will build some security tooling to inflict on Dev projects at arm's length, and Ops will hire some competing unicorns to build a bunch of pipeline tooling so they can DevOps you one ticket at a time. So, not a great picture, really. But okay, what's so bad about relying on unicorns, really? Well, I've said a few things so far, but let's pull those out and let's add to this a little bit. So, they're expensive. We said that. They're hard to retain. They're hard to find in the hiring market. They're hard to fit properly into an organization. They often feel uncomfortable being pigeonholed into what seems like a narrower job title or department. It's hard to train new unicorns. I haven't really said why. It's because the skill set is so amorphous, right? And usually it's a result of personal savvy and experience over time combined with being a fast learner rather than anything structured. So, being competent in that kind of blob-shaped role has a hugely steep learning curve. And junior would-be unicorns are not really useful. That's the problem. Being a unicorn means being senior, and it means being independent. Despite that, it's actually hard to offer the senior ones career growth as well, because they don't have a clear career track. They're too useful where they are, and they're hard to replace if they move around. If you've already kind of built your castle on the backs of unicorns from a DevOps perspective, you can't scale your operation because you can't find more of them. But I'm going to pick a couple more things that are a little bit more tricky. So the first one, this is a touchy subject, but they don't usually know as much as they seem to. If we're honest, if you claim to be a specialist in a huge long laundry list of things, the chances are that actually you aren't a specialist in all of them, but you're good at finding your way through and you're smart in some areas, right? And to be clear, muddling through is totally part of the engineering process. The challenge comes when you're doing it on your own and under pressure, because you're a unicorn. No one could possibly peer review your work because it's too complex. They don't do all the amazing things you do, and you don't have time for all that anyway. So the result of this is that you make mistakes that are totally invisible to everyone, or you miss things because you don't have the depth of domain experience that would prompt you to think about them. And the kinds of things that you miss if you're a DevOps or DevSecOps unicorn are not the kinds of things that will get caught easily in testing either. They're the kinds of things that will get caught super late in the cycle if you're lucky, and in newspaper headlines if you're not. And finally, I'll just say that, if you're doing DevOps right, you shouldn't see so many incidents, and the incidents you do see should be minor with a tiny blast radius, but unicorns perpetuate a culture of firefighting and heroics. Your team should be confident, in their joint ability to keep the lights on and to kind of roll forward and so on. But if you throw a couple of unicorns in the mix, it's almost like they create entropy. Unicorns are often great firefighters, and they're prone to acts of heroism, but it comes at the expense of maturing the wider team. And a lot of the time, this firefighting will come at the expense of fixing the actual root causes properly, either doing postmortems or doing the 100 other things the unicorn has on their plate. And this means that the overall likelihood of further incidents increases, and the ability of the wider team to handle them decreases. And worst of all, the availability of unicorns, their mere presence in the team encourages managers and product owners to skip investment in quality and toil reduction because they believe, wrongly, that they can rely on the unicorn instead. So look, from this list at least, I hope it's kind of apparent that the mere existence of unicorns in your teams actually works against you in successful DevOps adoption. And funnily enough, Gene, Kim, and co, they describe pretty much exactly this problem in the Phoenix project. Do you remember? There's a character in there, I think he's called Brent, who is the guy who knows and fixes everything. And besides being a major bottleneck, Brent is 100% a unicorn by my definition. I won't spoil the story for you, but I just wanted to say it's weird, isn't it, that one of the most famous books written about DevOps explicitly warns us not to depend on people like this. And yet, here we are, we all do it. So, okay, how do we stop? Well, as with many things, the first step is admitting that you have a problem. I'm only half joking. I mean, this is partly the reason I've been slicing and dicing the issue a bit so far, because it's such an ingrained thing. You have to be able to spot the signs and symptoms. You have to recognize the problem, or you won't be able to address it. But beyond that, the biggest single piece of advice I can probably offer is architect your teams as you would architect a system. Now, the habitual lack of focus on people and interactions in DevOps leads to dependency on unicorns. And the fact that we don't treat this stuff with the same care as designing the system itself is a cultural thing. No one is pushing for it, so it doesn't happen, because it's easier to kind of wave your hands and hope that things will sort themselves out, and that's somehow acceptable. So, you need to push for it. So be conscious and push. And I actually think a great way to tackle this is to explicitly address organizational interactions when you're architecting the system. So, we deliberately spend time thinking about how our system will be built by whom, the functions and breakdowns of teams that will build it, opportunities to split team remits and, try and make the system fit the people. And we think about things like the autonomy of teams versus the cognitive load that will be placed on them. Those are features of the overall socio-technological system that you're building. And we're trying to get to a picture then of what sort of this part of the company will do to achieve our goals, rather than just what the system that's being built will do. And to be more specific, I mean, I'd say you should at least, make sure your teams have a cohesive, preferably quite narrow functional purpose, and that most of their effort contributes directly to fulfilling that purpose. If you've got a team that owns a business service, but they're also building and running a complex infrastructure platform, then the team probably lacks cohesion. And lack of cohesive focus leads to dependency on unicorns, because the breadth of capability required in the team becomes very, very wide. But teams can't grow past a relatively small maximum size and retain agility, so more burden gets placed on fewer people. And within the team, obviously, you want to avoid single points of failure. I mean, that kind of goes without saying, even when you're not thinking about DevOps really, but it just so happens that people who are single points of failure tend to be unicorns or become unicorns. And that doesn't mean that you need two of every role in your team for redundancy. Don't take the architectural analogy so literally, but it does mean that you need T-shaped people to share the load. And we also want our teams to be loosely coupled to other teams to enable independent change cycles, but we don't want them to be totally isolated. And loose coupling is something that most organizations trying to adopt DevOps and DevSecOps models, they do pick it up on that, but it's easily misinterpreted to mean that the teams need to be able to work unaided by other teams, which leads to us depending on unicorns, because we want to bring everything in-house, and there's a critical mass where we can't get past that point. Again, what we want is loose coupling of dependencies, not elimination of dependencies. And for modern architectures, microservices and so on, that kind of decoupling is easier to do, and it's easier to do at the application layer, but it often gets quite difficult when we get down to infrastructure and data, especially with what we might call platform components that logically ought to be shared by multiple teams. And recently there's been a renewed focus on the idea of platform teams and the concept of platform engineering as a value generating activity. In this context, a platform is kind of an internally focused and importantly self-serve capability. Think about like a developer PaaS, or a cloud landing zone that vends accounts, or packaged with a bunch of tools that are ready to go and pre-set up. Right? The idea of these self-serve platforms is to better encapsulate a load of toil that it doesn't make sense for every single business-focused dev team to worry about. But importantly, they do this in a way that maximizes the autonomy of those dev teams rather than taking it away or becoming a bottleneck. And I'm a big fan of this movement. I think it's a critical, underrepresented part of successful DevOps. The benefits of, for change throughput are obvious if you're decoupled that way. But remember, designing and building these kinds of platforms, it's also an exercise in reducing cognitive load on other teams. So we're getting throughput gains, but we're also getting stability gains, which is the other half of the point of DevOps. And it's a similar proposition to kind of public cloud adoption. The difference is that because we are building the platform for our own organization, we can tailor it to the needs of our organization much more than a cloud vendor ever could. So we can think about things like developer experience, how skilled our dev teams are with the technology already, and even the specific business use cases that our spread of dev teams using the platform are going to be dealing with. And that's important, right? We don't have to build massive enterprise-wide platforms either. That's a mistake I see a lot. We can scope the purpose of a platform to a business domain if we need to, if that is the best way to deliver the goal, which is the agility that the organization is looking for in DevOps. Okay, so pulling our platform work into platform-focused teams is definitely part of the solution because it helps us to design teams that have a narrower, better defined focus. Now, beyond that, the roles that we need in our teams are going to be a function of the scope and purpose of each team and the skills needed to deliver it. One way you might analyze this is by breaking things down into sort of coherent, importantly, granular roles that someone might assume a few at a time, perhaps like in role-based access control. If you map those kind of many-to-one to actual people in your team, then you'll be able to spot pretty quickly whether you're depending on a unicorn and intervene. And in this example, which I kind of made up, you can see that one of the team members is responsible for 7 discrete specialist areas. So that's probably a cue to back them up and split the load. Similarly, if you maintain a decent granular view of things, you can use that to actually plan things properly, whether and when the team needs to grow, people's progression, training, onward career paths, rather than just hoping that they'll keep up or throwing more unicorns at them if they don't. Okay, well, what should we do with our existing unicorns? Because they seem to be everywhere, even though they're hard to find. Well, I do think you should hang on to them if you can. They're certainly useful, but you have to handle them with care. Of course, they perform extremely well in sort of short-lived crisis teams that need to be extra smart, but that's not really a strategic role, I suppose. So what else could we do with them safely? Well, I suppose the short answer is if you pay attention to team shaping alongside architecture, you can find roles for your unicorns that match their deepest skill sets without overburdening them. And that transition, okay, it might be tricky. It's easy to say the theory, but the transition might be hard because there's never a good time to take a unicorn away from something and they need to transition their stuff to somebody else. So you have to be very deliberate about it. And you also need to be very deliberate about sharing burdens within a team that contains a known or former unicorn, and watch out for firefighting and heroics. You could, instigate a mandatory process of post-mortem review, for example, which at least ensures there's some knowledge sharing going on, but there's plenty of other things you could do. Now, look, whatever you do, any of it might be disruptive, right? You might even cost you a unicorn, but to limit the chances of that, I suggest you involve them, explain your rationale to them. They're smart people, discuss the challenges you're trying to address. A better defined role with clearer onward options for advancement ought to be an improvement for them in the long run, after all. And I mean, I talked about security, in the context of everything else here, but are there any security specific things we should think of? I mean, well, the same concepts apply. The thing you really have to be careful with is defining security as like a separate role in a team. You want to be conscious that security expertise, it's a cross-cutting concern that will manifest within each of your defined roles differently. That means you need to define role-specific training for security if that's not already what you do. Because the kind of security knowledge that a QA person needs versus a Java developer or a Kafka platform engineer, it's obviously hugely different. Don't just think about AppSec versus Infra. This is far more fine-grained than that. So when you're designing the different granular roles that you'll need in your cross-functional team, that means that security is going to be an aspect of each of those roles. It's going to be a segment of each deep specialization, like in the diagram, rather than a separate specialization in itself. And beyond this, I mean, it is, I have to say, it's often appealing to try and augment your teams with some kind of assigned security expert, despite all that, who's available for, ad hoc queries and support during development. But you have to be really careful with that because it's easy to make them into a unicorn as well. And then you have all the big risks that come with that. And there are also some major pitfalls to having a nominated security guy in the team anyway, because it discourages, or it can discourage, other individuals from taking enough ownership of security within their own role. And that's true even if the security person isn't a deep specialist in everything. So you end up with gaps. I think that actually backs up the idea that rather than having some kind of smart security person who's kind of sitting on the side, a security champions program is probably a better shot and definitely worth doing, because we're sort of saying, with that, a champion is just a normal, T-shaped member of the team who does the security parts of their role more loudly and with more deliberate awareness of the security focus of other roles. I mean, there's more to it than that, but that's kind of the nexus here. And even then, it's still really easy to overburden security champions and have them turn into the security guy. All too often becoming a security champion is like catching the hot potato. I've definitely seen organizations rely far too heavily on champions, overstretching them or using them as an ineffective proxy for the security design review process. I think the best advice I can offer here is be conscious of what your security champions are doing and be aware that they're at risk of getting overstretched. So you need to spot that and find ways to support them. If you really get into trouble with this, I mean, you could try experimenting with different ways to share the burden within the teams they support. Maybe you make the champion title a role that rotates within each team, for example. And finally, I mean, the lesson about platforms, that applies to security concerns very well as well. If we get the shared responsibility model right, we can transfer a lot of security cognitive load to a platform team that is more specialized in handling platform security without hurting our ability to deliver. And that's especially nice when we think about implementing controls and demonstrating compliance, which can be really onerous if every team has to carry the full burden. Okay, so that brings us to the end of my talk today. I've explained, I hope, what I mean by unicorn and described why we so easily end up dependent on them. I've tried to lay out some practical advice about escaping that sticky cultural trap. I guess in a nutshell, be vigilant, think about where the unicorns are in your organization, and be deliberate about paying attention to the design of the teams that you build. So I guess we'll break for some Q&A, but in the meantime, thank you very much.
Hi, Alex. That was a pretty fantastic talk.
Thank you.
I guess a few years ago, the big concept instead of a unicorn was kind of like the 10x developer.
Sure.
Kind of before DevOps is becoming a thing, and I think you hit the nail on the head that you have these people you rely on too much to do everything. I've worked for places that have that DevOps engineer that basically does everything that's not app development and building cloud resources.
Yeah, DevOps is everything else besides a couple of well-known roles, right?
Exactly.
That's the issue we see, definitely.
Like I see this fellow backing up a SQL Server database, and then he's provisioning IAM accounts, and I'm like, I thought they had DBAs for that, but apparently not. So, and
I would say it's not necessarily that one person couldn't do both those things. It's when they do both those things and 10 other completely unrelated, deeply technical things as well. Like that's where it starts to get really egregious.
Yeah, at the same time, generally, and it makes it super difficult. And there's definitely, like you said, there's folks that can do that. I've been in that role where I'm doing 5-10 things at once, and it's not good. And and like, obviously this is kind of like a modern type of thing, but obviously this is something that has been going on for a long time, even before the cloud. What do you think in that aspect?
So I think I look at it from a DevOps lens, but I mean, there's some sort of relationship between DevOps and the cloud, isn't there? I mean, people do successfully adopt kind of DevOps practices and approaches outside of that context, but I think it seems to be particularly that we see a lot more organizations trying to push ahead with that and then falling into this trap as they move to kind of public cloud. There is an interesting other kind of set of scenarios though, which is I've seen organizations that are perhaps a bit more old-fashioned in their infrastructure. They use a lot more on-premise stuff for good reasons that are specific to their business, but they have maybe some more kind of pushy, innovative kind of business units that want to do their own thing. So they end up using cloud stuff one way or another, on somebody's credit card, and they got approvals because they're the flashy, innovative part of the business. And then the result is that you end up with this kind of unicorn setup because they kind of cut the rest of the organization out of the loop as far as possible. They really just don't want anything to do with them. They want to be their own masters, and it's great for innovation because they can move really quickly. But it's so that throughput side of DevOps, that really works for them. But then when it comes to sustainability and being able to keep this stuff up and keep the pace going, it falls down pretty quickly.
Yeah, that's kind of I think they call that the gray IT infrastructure, where
yeah, that's right. Yeah, well, shadow IT, right?
And like we know it's there, but it's not there. Well, this is good. this is great talk. We're going to be taking a break here, and we appreciate your presentation on unicorns, and super informative, and definitely I hope some people follow through with trying to kind of move on from that cultural aspect of, it seems like it's just another step of the progression in this IT. So thank you.
Great. Thanks very much.
Hello and welcome back to DevSecOps Days in Washington, D.C. We're continuing on with our afternoon sessions here. We had a good session from Alex Cross about escaping unicorn culture. So now we're going to talk to Mr. Vishy Mahadevan, and he's going to be talking about the art of enabling engineering excellence in DevOps. He's the CTO of Optimics, and he has a lot of different experience and roles over tech and business in the past 25 years. And I will let him kind of give you his intro and talk through enabling DevOps and excellence in engineering, which we all want. Go ahead, Vishy, take it away.
All right, thank you, Doug. Good afternoon. My name is Vishy Mahadevan. I'm the Chief Technology Officer of Optimax, a boutique management consulting focused on helping clients for digital transformation, DevSecOps, and modernizing enterprise data management, and also applying emerging technologies for improving operation excellence. Let's dive into the challenges and the needs that we are trying to solve today by enabling engineering excellence and DevSecOps. During our presentation today, we will see some of the challenges faced by the engineering leaders and the security leaders, and how the best practices and continuous improvements can help them to overcome those challenges. I'm happy to show you a few real world use case on how to measure and improve end-to-end software product delivery by function area and persona in your organization. In the last decade, software engineering has evolved from custom development to deployment of SaaS products, use of low-code, no-code, and cloud-native solutions, with increased need for automation, integration, and security controls. Agile and DevSecOps are no longer a nice-to-have capability, but have already entered the mainstream for application lifecycle and product management. This growing trend also added complexity by adding more tools or silos. On an average, the Agile team uses about 15 to 20 tools, anywhere from Jira, Rally, GitHub, SonarQube, Jenkins, Veracode, Ansible, ServiceNow, you name it. Today, it is hard to get a unified view of these tools, as it added more complexity with the tools landscape. Most organizations have invested in multiple tools to improve their application lifecycle management, but achieving a mature, scalable, and standardized DevSecOps is always a challenge because one, it is time consuming, and two, it is expensive. What if we remove this complexity, automate the data collection across multiple enterprise tools, and provide insights into your functional area, as well as provide recommendations and resolve any current challenges based on industry best practices and near real time? Today, I will show you how organizations can get unified view of improved engineering excellence and also DevSecOps tools to deliver business value like the industry champions. So you see the tool complexity. Many organizations use multiple tools, but getting a unified view is the critical element for improving engineering excellence and also maturing your DevSecOps. Looking at some of the challenges faced by engineering leaders today, for example, if you are an application development manager, it is critical to know some of the bottlenecks hampering your developer productivity in your organization. If you are a product owner, you want to know how to increase your future velocity effectively and also reduce the time to market. If you are a testing manager, you want to know the areas for improving product and code quality. and you are more interested to secure the software without choking the developer's bandwidth. The common challenge of these leaders, or what are some of the industry best practices we can adopt to generate insights in a near real time, in addition to investing in the tools. Eventually, organizations must devote more time and energy to develop engineering excellence to overcome these challenges. So, what is engineering excellence? It is a rigor that you want to adapt at an atomic level to deliver your software code that provides business value iteratively. Leaders across application lifecycle are prepared to review and make necessary adjustments on an ongoing basis without compromising on quality and security. By applying industry best practices and near real-time data collection for continuous improvements, organizations can achieve engineering excellence. Several stages and components that you see here work together as a best practice to build engineering excellence, provide functional insights, and drive innovation. By focusing on each stage of this application lifecycle management, you bring the leaders and stakeholders across the organization to come forward to identify answers to the key challenges and also develop meaningful metrics to measure and collaborate for improvements. The text below each stage is an example of the key metrics you want to consider to improve your engineering excellence. For example, if you are a project sponsor, you want to know the projects that are not delivering commitments and the predictability of key initiatives without having to reach out to so many people looking at different reports. If you are a product owner, what are some of the long-running stories and the stories that are not tied to epics and initiatives, etc.? If you are a DevSecOps manager, you are most interested in knowing this if the CI/CD pipeline has mandatory security testing steps executed. If you are an operation manager, of course, you are most concerned about the cycle times on tickets and how many tickets are pending for more than 5 days, etc. Now that we have seen the key stages and metrics to measure, let's see who are the beneficiaries, key beneficiaries of this engineering excellence. On the left, you see the personas across application lifecycle management, including the leadership team, that is mapped to the key performance indicators to the right, and the information is provided more functionally rather than the tools. For example, if you are a security officer, you are more interested in knowing the organization risk score, compliance score. If you are an ITSM manager, you are more concerned or interested to know about the mean time to resolve. Likewise, if you are a CI/CD DevOps manager, you want to know the maturity and mean time to change. Similar to the challenges faced by engineering leaders, DevSecOps or release managers and organization leaders like CISO is also up against key challenges in DevSecOps implementation. To begin with, if you are a DevSecOps manager or a release train engineer, you want to know and measure the current levels of DevSecOps implementation, and most importantly, how to minimize developer efforts on DevSecOps implementation and vulnerability remediation. Ideally, you want to develop developers to shift security to the left, reduce the time for troubleshooting security issues. If you have multiple agile teams in your organization, you want to standardize DevSecOps implementation across various product teams and get a unified view of the outcomes. If you are a CISO, you are most interested in knowing the current vulnerabilities, risks, and compliance levels. Finally, as the security leader, you are expected to solve these challenges with multiple constraints. Like a CMMI implementation, the art of enabling DevSecOps starts with an assessment and a robust implementation plan. Irrespective of organization's size, the number of agile teams, perform a maturity assessment to understand where you are today in your DevSecOps journey and set smart goals for where you want to be over the period of time. This exercise is essential and also helps you to understand the type of tools you need and type of tools that you want to automate and the time required to achieve the desired results. Once you define the implementation plan, conduct a periodical review to ensure your DevSecOps maturity level improves and stays at the intended level. Most of the digital and product initiatives fail today because of reactive troubleshooting and a lack of predictable outcomes with the delivery process. As you set to mature your DevSecOps, you want to measure, benchmark, secure, and improve your end-to-end product delivery. Organizations must focus on these 6 domains to maximize business value through DevSecOps for traceability, increased efficiency, improved predictability, and continuous governance. Data collected from these dimensions should be used for trend analysis, predictive and prescriptive analytics to prevent issues proactively. Each dimension listed here is connected to the best practices and answers to the key challenges and helps you to gather insights and apply preventive measures on velocity, productivity, quality, security, and compliance. Now that we have seen the challenges, the needs for engineering excellence and maturing DevSecOps, let's see how we can bring the information across the enterprise together in a single pane of glass with a real-world use case. As I mentioned earlier, most organizations have already invested in a handful of tools to manage software delivery. Kyber is not a replacement tool for your current DevSecOps implementation. Rather, it is a low-code, no-code, all-ops simplification platform that interact with almost all the existing enterprise tools used for software engineering, DevSecOps, compliance, and governance. We want to ensure the enterprise tools yield maximum ROI and automate data collection to reduce the time for troubleshooting and provide insights and recommendation to organization leaders proactively. Kyber customers today use this platform to eliminate the tool complexity and simplify communication across the users in the enterprise. Because Kyber converts the data from each tool into a canonical model, so users don't have to log multiple tools. Instead, they can view data generated from those tools translated into their functional language. This is a huge step forward in improving your engineering excellence and DevSecOps maturity. As the platform does most of the heavy lifting for collecting, understanding, analyzing, and providing insights to the user. On an average, enterprise today requires 15 to 18 months to produce equivalent visibility on limited tooling. You also see the key benefits on the right-hand side of this slide, such as visibility, validations, visibility for the benchmark for leaders, a single pane for developers and teams, and atomic level validation and control based on industry best practices. With Kyber, enterprise customers can achieve the key benefits 1 to 3 in days rather than months, using the low-code, no-code, drag and drop features. Most importantly, Kyber offers an abstraction of tool data into functional language with improved user experience, reduced time for troubleshooting, with ready-to-consume data to resolve any challenges. Now, you may wonder how this is possible with so many people, processes, and policies involved across the enterprise. The simplified communication and the abstraction layer in Kyber is possible due to deeply engineered framework with near real-time data collection and the creation of canonical models using ML-driven aggregation data tagging, and an enrichment engine. As I mentioned earlier, it is a low-code, no-code platform that helps you to configure the existing enterprise tool through API. And this platform is available as a SaaS offering with SOC 2 and NIST compliance, and also deployable in your own data center or any cloud environment of your choice using Kubernetes. The platform includes state-of-the-art rule engine that was fine-tuned over the last 5 years and is ready to produce results for you from day one. This platform is supported by horizontally scalable microservices architecture with a configurable, customizable drill down visualization framework that helps you to drill down the data layers. And finally, the platform supports anomaly detection, prediction, root cause analysis that contributes to proactive problem resolution. There are several use cases Kyber supports today for improving engineering excellence and maturing DevSecOps. And it benefits several personas across the enterprise from the insights generated from the platform. Most of the Kyber customers today, as much as 80% of the customers that were onboarded most recently, use this platform for a near real-time visibility and stage gate governance. The reason is it reduced tremendous amount of time to troubleshoot, resolve anomalies quickly and effectively. For today's use case, I will be using three personas: a developer, an application leader or a product owner, and an org level leader like a CISO or a CDO. The core problem we are trying to solve is how we can help the developers act on their priorities without having to log into 10 to 15 different tools. If I am an application leader, how do I know close to a real time the current level of maturity and health of my end-to-end software delivery process without having to ask multiple people for a status or a report? How do we know we are doing enough test coverage and test automation, and if the developers are shifting left regarding security? How do we ensure nothing falls through the cracks of any given release? If I am a security leader, how do I know the current risk score, compliance levels, and the effectiveness of shifting security to the left is working? Moreover, as the organization leader, I want to understand the tool effectiveness. The output produced by the Kyber platform is what you see on the screen now. This use case focus on providing near real-time visibility on the end-to-end software delivery process across all the tools used by any given time by applying atomic level standards and best practices that were jointly created in collaboration with the customer. As a customer, you define the configurable stage gates from requirements tool to source code management, your testing activities like unit test, functional, static, performance testing, your security compliance and artifacts management. By connecting end-to-end tools, you will know up to minute health and the gaps that you need to worry about. With this view, you can see what you want to focus more. For example, from this example, you already see there is 100% coverage of functional test, performance, auto build, deployment, and performance testing. Perhaps you are making a good progress in code quality, code review, artifacts management, and requirement management. Whereas your source code management and unit testing, we have a long way to go. Now that we have seen the overall usage of stage gate governance, you may ask, as a developer, how does the stage gate helps me to increase my productivity? All these stage gates have a clickable and a drill down capabilities with a spoon-fed information on what to worry about, which helps almost each persona to focus on where it is needed for troubleshooting instead of looking into multiple tools and correlating the information. This dashboard is entirely configurable, meaning this is configurable at the org level, portfolio, program, project level with thresholds that you want to monitor. As you resolve a particular issue, you can come back to this dashboard view and see the percentage of coverage go up in a real time. This view helps you to benchmark velocity, productivity, predictability, quality, reliability, and security compared to an industry standards, and determine which project or agile teams may need help to improve their KPIs. It also offers the ability to apply deeper level improvements to your agile processes, requirement managements, and delivery processes. In summary, the abstract layer enables a unified view of enterprise tools to measure, benchmark, secure, and improve your end-to-end software product delivery. Kyber is a pre-integrated with many tools, as much as 60 plus industry standard DevSecOps tools and 200 plus cloud service implementation. Today, this use case is built upon industry standards and a robust process for continuous measurement, transformation, and improvement. Kyber guarantees engineering excellence by validating 100 plus best practices and produces 350 plus KPIs at every step in your software product delivery lifecycle. This concludes my presentation for today. I'm happy to answer any questions from the audience.
So Vishy, that's quite an interesting kind of product that you've put together here. I think the biggest thing that I've had a lot of people doing DevOps is like, hey, I need metrics. Like, you know, to people who are developers, you know, or engineers, metrics are important, but they're kind of looking at infrastructure metrics, like how much is my system staying awake. But when you have your project management folks or your project owners, you know, you're kind of like, hey, how do I see all this stuff at once? Where's my, you know, software testing at? Where's my, you know, if I need manual testing, you know, I think this kind of gives that overhead view of pretty much everything, which is kind of impressive. Like, how long did it take you folks to get this kind of to this level of integration with every application? That doesn't seem like a simple task.
Absolutely, that's a great question, Doug. It took us nearly 5 years. The product owners took nearly 5 years to mature this product. The good thing about that now is the customers, the clients can reap the benefit from day one, right? So it took almost 5 years for us to mature the product. And we all know the DevSecOps tool landscape. You get new products every single day now, right? It also, you know, we are staying very active in this space. We are ready to integrate any new tools that comes out in the market. Our cycle is about 2 to 4 weeks to integrate any new tools into this platform today.
Wow, that's pretty impressive. So what sort of like kind of limitations are there with this tool? Because obviously you're doing like almost everything here.
Yes.
When it's, you know, you're talking integrations, there has to be some sort of catch. Where you have to kind of there's some kind of lines drawn where you can do some things but you can't do them, or that type of thing.
Awesome. So very common question that we get asked by almost every client. The limitation we have, this platform is API enabled, right? In the last 5 to 10 years, most of the DevSecOps tools exposes API connectivity. That means 70-80% of the latest tools we should be able to integrate out of the box. We take a different approach. If a customer comes back and say, I have a legacy system, monitoring system that I want to integrate that cannot be connected via API, we don't want to spend so much of time to integrate that tool if that does not add business value to the customer. So we will look at each case by case and really see if that really adds value. If we want to do a temporary stopgap to integrate that product, or otherwise, most likely we would advise them to, use the latest tools. Or if the other use case, I can also think about if a customer comes back and say, I got this fancy tool, DevSecOps tool that I want to integrate with your platform. Yes, we can do that. As I said earlier, we can integrate that between a 2 to 4 weeks cycle. The limitation right now I see is the tools that are not API enabled. And the tool that is probably 10 year or greater, or 10 year or old, those are the tools that is not ready for integrating with this tool at this point.
Yeah, it seems like API-driven tooling and products is kind of the best practice and future goals of pretty much everything. Now, this is kind of like the generic answer. Does it take like CSV input for some things, or is that just kind of your tools it's just kind of out of scope with doing that kind of mapping if needed?
Yes. So the answer is yes and no, right? Yes, we can do CSV in a batch mode. Now, this platform is really built for giving you a near real-time insights to what is happening, what are the gaps, right? So you don't want to bring in a CSV file and make your data stale. We cannot guarantee that it is the latest and greatest information. So that's why we always want to pull the latest information from the tools directly, rather than allowing CSV as a mechanism to ingest data into this platform. So to answer your question, yes, we can do it, but we don't recommend doing it.
Yeah, I guess that's a good plan. You want the best data available. So the CSV is that generally a batch-driven process, although I've seen some odd usage of CSV and kind of streaming and those type of interesting activities where people don't want to make it APIs. So this is pretty neat. Now, does this integrate into, say, the AWS Azure tools where it can pull the data out of like an Azure log workspace or something like that to kind of look at those metrics as well?
Yes. So this product is currently, most of the organization, they don't have their infrastructure in a single environment anymore, right? So they have SaaS products, they have their own on-prem data center, they have multiple cloud native solutions or cloud service providers that supporting their infrastructure. Definitely this platform is able to connect almost every cloud service providers, as well as it is API integrated, API exposed. We should be able to connect across all the cloud service providers, SaaS platforms, and on-prem applications.
Wow, that's pretty impressive. But I guess honestly, if you want to work within the environment today, you have to kind of support cloud vendors and any type of pretty much anything's available now as a software as a service, and that's definitely needed. So yeah, this is I think this is kind of like a good way of the future. This is a kind of a future looking thing, because especially if you're trying to make decisions over large programs, like if you're a decision maker and you need to generate that risk profile and kind of evaluate what you're getting yourself into, and what's been completed and what's good and what's bad, kind of having this dashboard aggregation with all the needed data on it, that's definitely a big deal to me. At least I know with a lot of folks that I've worked with, they would, I never even knew such a thing was available other than just using like Power BI or some sort of reporting tool. But yeah, this is really neat. and I appreciate your presentation. Do you have anything else you want to add here before we head over to our break?
No, I'm good for now. No, thanks for the opportunity to present this use case. I'm sure people don't want to reinvent the wheel, so we already have a solution. If anyone need any help, just reach out to me. I will be happy to provide a full walkthrough demo with the real use case real data.
Yeah, awesome. That's definitely sounds like a plan. It's good to know that stuff like this is out there exists. So this was Vishy Mahadevan, and we are going to take a short break right now for about 10 minutes, and then we'll get on to our next presentation. And that's going to be from Chris Hughes on software transparency, which it's a big topic in the year 2022. So definitely something we need to hear more about and how to fix that. We'll see you after the break. Welcome back to All Day DevOps. I'm sorry, DevSecOps Days in Washington, D.C. I'm Doug Reynolds from the Software Engineering Institute, and we have our next speaker on. His name is Chris Hughes. He's from Acquia Inc., and we're looking at software transparency, securing the digital supply chain. Chris, he's the CISO and co-founder, and he's dealing with a lot of federal and DoD agencies and trying to bring this all together. And let's hear it for the digital supply chain, which is being a big issue nowadays with all the hacks and the typo squattings and everything people try to do to get into the supply chain. I'll let you talk to it, Chris. You can give us a little bit more detail.
Yeah, definitely. So as he mentioned, Chris Hughes here, CISO and co-founder at an organization named Acquia. By way of background, I've been in the cyber space for a little over 15 years. Started off active duty Air Force, was a federal employee with the Navy, as well as GSA on the FedRAMP team, doing cloud security and DevSecOps activities for Navy and GSA as well. Spent about some time in industry working with programs like Platform One, also the Space Force Software Factory, and supporting some federal civilian software factory and software supply chain efforts currently, actually. So my talk is titled Securing the Software Supply Chain, Transparency in the Age of Software-Driven Society. So that said, let's dive into it. So let's start off here discussing open source software. As we all know, there's tremendous benefits of open source software, expedites innovation. There's a robust community and ecosystem around open source software. And just some metrics, almost 100% of organizations are using open source software based on some latest surveys from groups like Sonatype and others. Almost 80% of those organizations are starting to increase their use of open source software. Even in the federal community, even in the Department of Defense, we're seeing a more of a propensity, more of an openness to using open source software. And as I said, 80% of the organizations are also starting to sponsor open source software projects and associations. So you think of things like OpenSSF, Linux Foundation, and others of that nature. Organizations are starting to sponsor those organizations and put money into the ecosystem as well, which is a great thing, because traditionally it's typically, largely a volunteer-based ecosystem. And we've seen the highest increase of open source software adoption and tooling when you look at the DevOps, CI/CD pipeline and automation space. Things such as Jenkins, for example, Kubernetes, Istio, all the little latest buzzwords around DevSecOps and containers and cloud native architectures, for example. But that said, there's a much broader ecosystem around cloud, containers, languages and runtimes, DevOps tooling, and so on. The list goes on. But that said, that open source software is not a panacea. There's also risk and considerations to be considered when it comes to using open source software. For example, just looking here at the last couple of years, you can see some notable open source software incidents. Of course, we all know Log4j. We've all seen the fallout from that, and I'll discuss that more in a bit. But there's been other incidents too, like Colors JS, for example, CodeCov. There's been a lot of dependency confusion, typo squatting incidents, as Doug talked about in the introduction there. So that said, open source software actually comprises about 60 to 80% of modern applications or software code, for example. So modern software is overwhelmingly comprised of open source software components to some extent. And the software supply chain attacks are on the rise too. So as organizations are using more open source software, malicious actors have realized how valuable of an attack vector, this is. They can compromise a single open source project or open source software component like Log4j, for example, and have a cascading impact across the entire ecosystem, impacting tens of thousands of organizations. They may be targeting a certain organization that's using a project or a certain component, or they may just be looking to hit anyone that's actually using it with no kind of no discrepancy or no discrimination against those targets, and just kind of hitting anyone they can. So we see everything in between there. If you take a look at this diagram here, you can see just in the last, say from 2016 to now, we've seen a tremendous uptick of software supply chain incidents. And this trend is likely to only continue as malicious actors realize, how lucrative an attack vector it is and keep compromising the software supply chain and targeting it. And so there's some tremendous problems associated with that adoption. Many of the projects that we're all using, as I mentioned, are traditionally supported by by unpaid volunteers. So not necessarily financially motivated or incentivized to fix vulnerabilities in a timely fashion or produce secure code necessarily. They may be doing this as a hobby or just a passion project. So the financial compensation typically is not there that may incentivize people to respond more quickly. And then incidents like Log4j kind of sent the whole entire industry scrambling as people realized that they lacked visibility at the component level. People simply don't understand, what software components am I using? Where does it exist in my enterprise environment, my ecosystem? What systems or projects or business units are impacted? How do we go about responding to this? So that lack of visibility is a major problem for the industry and organizations across the industry. So what do we do about this? We all saw some things like the Cybersecurity Executive Order, guidance from NIST, and many others that I'll be talking about coming up here. And, so what do we do about this? A couple of the things that are coming out of here is guidance from NIST, as I mentioned. They recommend, using, if you look at their NIST 800-161, they produce their cyber supply chain risk management practices and for systems and organizations. That's a critical piece of guidance to look at if you're standing up a CSPRIM or a cybersecurity supply chain risk management program. You definitely want to have one of these in place. And then there's also guidance and recommendations coming out from not just government organizations, things such as NIST, but industry organizations like OpenSSF and Linux Foundation and others are starting to put information out that I'll be talking about here in a moment. And then also we're seeing crowdsourcing catching on. Large organizations, such as Amazon, the Microsofts, the Googles, and obviously a lot of small innovators and even business organizations that are using open source software and projects, they're starting to crowdsource and crowdfund these projects as we realize how critical some of these projects and software is to the ecosystem, putting some financial incentive around that. So that maintainers are compensated, they're more incentivized to fix bugs and issues quicker, produce secure code, things of that nature. But we're far from perfect in that context, and we're moving in that direction. But we have a lot of work to be done still. So in the NIST 800-161 guidance, which I'll be talking about more coming up, they kind of laid out different capabilities, which they laid across a maturity model of foundational, sustaining, and enhancing, which I'll be diving into. And then they also recommend things like a software composition analysis, software bill of materials, which I know has been discussed quite a bit today. I'll be talking about that as well. There's other emerging efforts like VEX, the Vulnerability Exploitability Exchange. And then they recommend establishing a centralized hardened internal repository of known open source software components, for example, that your organization is using. So on the SBOM front, to try to talk about this a bit, it really started to get traction with NTIA and under Dr. Alan Friedman. They had the multi-stakeholder transparency working groups that participated in this and produced a lot of guidance around SBOMs, what an SBOM is, an SBOM FAQ, SBOM myths and misperceptions, for example. And then they also did a survey. What are the leading formats of SBOM? That came out of that survey. So Dr. Alan Friedman has now moved over to CISA, the Cybersecurity Infrastructure Security Agency, where he's now leading their SBOM efforts. And they have various work streams. They held an SBOM Orama in 2021, which is a big, 2-day event. They brought the people from academia, federal government, state governments, industry, commercial industry as well together and discussed SBOM, where we are, where we're headed. And then they spun off of that 4 different work streams. I participate actually in the cloud work stream, but they have a cloud and online applications work stream, on-ramps and adoption, sharing and exchanging, tooling and implementation. And the reason for this is, creating an SBOM is somewhat trivial at this point. There's a lot of tools out there you can use to produce an SBOM, but there's things like what is an SBOM in the context of SaaS, for example, or the term SaaSBOM has now started to take trend. What does an SBOM in the cloud native environment look like? And then also, how do we help organizations like, OnRamp or adopt SBOMs at scale? How do we go about sharing and exchanging SBOMs in different formats? How do we automate this? How do we automate the process of creation, ingestion, distribution, and so on in a secure fashion? And then how do we produce tools to facilitate all these activities? So those different work streams that are actually meeting right now and discussing those topics. And if you're interested in any of those topics, I highly encourage you to participate. So on the SBOM format front, NTIA essentially came out. So there was 4 leading SBOM formats that industry is starting to look at and kind of rallying around, which is SWID, Cyclone DX, and SPDX. But that said, the 2 formats that really have taken off and gained traction in the industry are Cyclone DX, which is led by the OWASP Foundation. You can go to their website and check out the Cyclone DX documentation, or the Software Package Data Exchange, SPDX format for SBOMs. That's being led by the Linux Foundation and actually is an ISO standard now at this point as well. So from a security perspective, those 2 formats have kind of taken the lead. But SBOM is, a lot of information, and a lot of people consider it a lot of noise. So another effort that's starting to gain traction now is what's called the Vulnerability Exploitability Exchange, or VEX. So that's telling you, not only, what's in the software that you have, from a supplier, component name, unique identifier, version string, things like that, but also start to show you not only what are the vulnerabilities in this software associated with these components, but are they actually exploitable? So VEX is trying to solve that challenge and bring some signal to all that noise. If I'm a software consumer, I want to be able to consume a VEX and understand, are these vulnerabilities associated with the software actually impacting me? Do they present risk to my associate or my organization? Is it within my risk tolerance, for example? And if I'm a software producer, I want to start producing VEX documents so that people can ingest these and make risk-informed decisions from a business or mission perspective. Now, so that's another SBOM component that's definitely starting to gain a lot of traction as well. So another aspect I want to touch on is, everyone knows here the title is DevSecOps Days, right? So a fundamental aspect of DevSecOps has quickly become the CI/CD pipeline, continuous integration, continuous deployment pipeline, and for great reason. There's tremendous benefits when it comes to CI/CD adoption. It's changed the way we deliver software. It's facilitated us, quote unquote, pushing security left, shifting security left, as we say in the industry. That's moving things like SAST and DAST and secrets scanning and, malware scanning, vulnerability scanning, producing SBOMs, et cetera, all to the left. In the software development lifecycle, we're able to facilitate these automatically through the CI/CD pipeline, things like GitLab or GitHub, along with third-party tooling and integration and such. And it's, allowed us to produce these robust tool chains and achieve these, robust capabilities from a CI/CD perspective, integrating all of our security tooling, catching vulnerabilities or bugs earlier in the life cycle, bringing that information to the development teams and letting them drive down things sooner before they get to production environments, before they present risk to the organization, and while they're easier to fix in many cases, before they get to a runtime environment as well. But that said, CI/CD pipelines, much like other things that we'll be touching on, are not a panacea or not a silver bullet. Many organizations, they haven't adopted what's called a unified CI platform, for example. They may be using a CI platform, but then using a lot of third-party tools and integrations that they need to integrate with. And it brings a lot of complexity. That's a lot of moving parts and moving pieces. And as we all know, complex systems fail in complex ways. So when we look at CI/CD pipelines, while they are able to, facilitate secure delivery, they're also part of your attack surface as well. So organizations need to treat these CI/CD systems as part of your production system. The same way you treat your production environment. If you're distributing code through a CI/CD pipeline, you need to treat this like as part of your attack surface. And as we saw in the case of SolarWinds, a compromise of the pipeline can lead to a massive, software supply chain cascading impact downstream to thousands or tens of thousands of consumers. Many of which, in the case of SolarWinds, for example, were federal agencies, state and local governments, and so on, everyone using this software vendor in this case. Not to poke holes at them, but it's just a notable example, and it can happen to any organization that are using CI/CD tooling, distributing software at scale, and not using, proper best practices and security hygiene from a CI/CD perspective. And malicious actors are even starting to go a step further, and not only produce a malicious payload by compromising the tool chain or pipeline, but actually compromising signing systems. So you may get a piece of software, from your software vendor and say, oh, well, it's from them. It's even signed, right? It must be legitimate. It must be secure. But if the signing system has been compromised, now all you have is a piece of malicious software that's actually signed, and it can, it looks trusted, it looks verifiable, and it can be a poisonous, piece of software you're ingesting into your organization or your enterprise architecture, for example. So what do we do about this? How do we start to address some of the CI/CD challenges of, ensuring that we're using CI/CD for all the benefits, but also implementing security best practices? And there's a lot of sources of, guidance and information out there that you can go and use. A lot of sources I like to recommend, one of which is Cider Security. They produce their CI/CD security top 10 list. And if you take a look there, it's a lot of things that we'd actually see in other situations too, like insecure, system configurations, poor credential hygiene. So a lot of the issues that impact us in other ways in other systems and other environments actually impact the CI/CD pipeline and toolchain as well. So definitely check out Cider Security. They have some great documentation and guides out there with, securing your CI/CD environment, for example. They actually have a tool called CI/CD GOAT. It's a kind of an intentionally vulnerable CI/CD pipeline that you can go in there and work with, test, train with, etc. There's other notable efforts like SALSA, which is the supply chain levels for software artifacts. This is an effort that's spun out of Google. If you go to salsa.dev, slsa.dev, You can check out information on SALSA framework. And this is another notable software supply chain set of guidance and best practices that are starting to get adoption. And it ranges from 4 different levels in maturity, from level 1 through level 4, depending on your organization, your security requirements, your compliance requirements. Obviously, the further you go up that chain, maybe you're working Department of Defense or national security systems, you may have higher, more rigorous requirements. But at a high level, it's all oriented around preventing tampering, improving integrity, and ultimately producing secure packages and artifacts for downstream consumption for software consumers. So definitely check out salsa.dev. And then, as I mentioned, not only do you want to secure your environment, your CI/CD pipeline environment like a production environment, but you want to do things like threat modeling or adversary emulation. Start to threat model your pipeline, understand what the risks are, what the threats are, what mitigations can I put in place to drive down risk? Have we thought about these scenarios? Because often organizations simply haven't thought about that. They're simply producing software through the pipeline and worrying about their production environment. But if the pipeline itself is vulnerable, as I showed in the previous slide, it can impact not only yourself, but if you're distributing software to downstream consumers, it can impact tens of thousands of organizations. Another, favorite of the DevSecOps community, of course, is Kubernetes and containers. You can't have a conversation about DevSecOps or DevOps, or cloud-native architectures without discussing Kubernetes and containers, and for great reasons. It's often linked to cloud-native architecture, and DevSecOps adoption. Almost 80% of organizations are starting to adopt containers from a compute abstraction and compute workload perspective. And Kubernetes quickly, of course, has become the largest open source software project around container orchestration, and it's become the container orchestration tool of choice. For great reason. It reduces development timelines. It has benefits around cost optimization for things like multi-tenancy, for example, and improves scalability and resiliency of your application. It can scale up and down, based on demand or traffic to your website or your app, your workload, for example. There's a lot of great reasons to adopt, Kubernetes and containers. But that said, much like all the other things that we've touched on, there's also fundamental security concerns that you need to keep in mind. A couple of statistics I want to throw out here is like Palo Alto's Unit 42 Threat Research Group. They took a look at, publicly available Kubernetes Helm charts, for example, on Artifact Hub, and found that almost 100% of them had insecure configurations. Likewise, they went and looked at public container registries, things like Docker Hub, Gwei, Google Container Registry. They found that those containers, had critical findings in almost 91% of the images that were out there, not to mention highs and, moderates and lows that could be, vulnerability chained or for, other methods essentially to exploit your workload, your environment, your architecture, your organization. So what do we do about this? Much like anything else, you want to look to industry guidance. What's out there? What are some of the best practices that are emerging? And there's some great resources of information out there. If you look at things like Center for Internet Security, Cloud Native Computing Foundation, they have some guidance around software supply chain security, for example, that touches on this. And then, things like DoD's Container Hardening Guide or the Kubernetes DIG, for example, Security Technical Implementation Guide from Department of Defense. NSA even produced a Kubernetes Hardening Guide. So start to look at these sources of guidance and understand, like, yes, we want to use containers. Yes, we want to use Kubernetes to orchestrate these container workloads. But how do we go about doing it in a secure fashion? So some of the best practices you'll see there is using things like container or manifest scanning, scanning images, for example, looking for CVEs or vulnerabilities or misconfigurations that may be in my Kubernetes manifest or my container image manifest, for example. And then starting to use things like pre-hardened images rather than going out and just pulling container image from a public container registry, which I hope not many folks in this audience are doing unless it's for testing or training purposes. But looking at things, Department of Defense has a great example. For example, underneath Platform One, they have something known as Iron Bank, which is a hardened container image repository. And they've, run container hardening tools, container scanning tools, and they've produced, hardened containers that have been stripped, from an attack surface reduction perspective, stripping out unnecessary components, stripping out bloat, things like that, and in producing a hardened image container that can be ingested and used by organizations. And you can go and see, if I use this container, what are the residual risks? What are the residual vulnerabilities that I'm consuming as a consumer, and get that information before you just simply start using things. And of course, using image signing and hashing so that you understand, you can check the hash, for example, or the signature and understand, where am I getting this from? Who created it? Who's kind of attesting to the security of this container rather than just going and getting something off the public internet, for example. And then ultimately, you want to make sure you scan container images throughout their life cycle. As we all know, this is a software engineering institute. Software ages like milk, as they say. Maybe there wasn't a vulnerability or wasn't some vulnerabilities associated with the container during your pipeline or build activities, for example. Maybe new CVEs have emerged. Maybe new vulnerabilities have emerged, for example. So you want to scan containers at runtime, scan them in your registry, for example, to look for new vulnerabilities, and then ultimately rip and replace those vulnerable container images from your production or runtime environment, which is something that can be facilitated through Kubernetes. You can do that without minimal business interruption, for example, to your users, your consumers of your application or your system, for example. And then ultimately, you need to, not just from a technical perspective, but you need to update things like your incident response plan or your playbooks. A lot of organizations are adopting these cloud native architectures, these cloud native technologies, but they're not really updating their organizational processes and policies to align with that. So we need to update those incident response plans, business continuity plans, and so on to reflect the technologies that we're using, the operating environments that we may be operating in. Because failing to do so is going to have a situation where an incident happens and you're simply not prepared. You haven't exercised this from a tabletop perspective, for example. You don't really know how to respond. And then not only that, but looking at things like not only the Kubernetes container or Kubernetes manifest or container images, but also looking at your infrastructure as code. When we're talking about DevSecOps, there's some great research out there from Palo Alto and others showing that things such as CloudFormation from AWS, or maybe you're using a vendor agnostic solution such as Terraform, those infrastructure as code files, configuration manifest files, and so on, have a lot of vulnerable configurations in there too. Maybe you're not using encryption. Maybe you have, too many permissive ports and access control policies in place, for example. And this is where, people start to talk about configuration as code, compliance as code. So starting to scan your infrastructure as code and ensuring that it aligns with your organizational security requirements, maybe your industry compliance requirements, things of that nature. And this is one I actually like to talk about quite a bit because I feel like it's often neglected in the conversation around software supply chain. As we know, a major part of the software ecosystem is delivered as a service these days, SaaS. There's over 20,000 SaaS applications out there available for consumption. Organizations are often making, financial decisions to build versus buy. In many cases, maybe buying SaaS services that provide some kind of service that they want to use, and for great reason. Like they offload a lot of responsibility onto the SaaS provider. And maybe they don't have to worry about quite as much from a capabilities or administrative overhead perspective, for example. But that said, we're starting to see a little bit of SaaS sprawl, and a little bit is putting it lightly. Large enterprises, for example, are having upwards of 200 different SaaS applications across their ecosystem, and they're adding as many as 10 new SaaS apps a month. And of those, SaaS apps of upwards of 200 in large enterprise environments, only about 20% of that's actually controlled by the IT or security team. So think about things like shadow IT back in the day. You had servers or workstations or endpoints that you may not know about. The major difference from back in the day is, maybe you had to physically touch or see those things. SaaS, you simply you don't know it exists. And anyone with an organizational credit card or financial, capability can go out and start to procure these things and use them and start to put sensitive data in there, give people access, not really have proper access control in place, things of that nature. So getting a handle on your SaaS consumption is definitely something that needs to be addressed as well. So from a SaaS consumption perspective, you want to start to implement things like SaaS governance and security programs, and even start to request SBOMs. You're consuming software through these SaaS providers, for example. So you should be asking them for SBOMs, understanding within their SaaS application, what software components exist. Are there vulnerable components? Are there vulnerabilities and risk associated with the components that they use in their SaaS application? And understanding, what is the risk and the hygiene of the software you're consuming from them via as a service. For example, just to put it in perspective, the recent Twilio incident, for example, involved over 130 other SaaS providers. So think about that spider webbing, kind of scenario where you impact one, SaaS provider, for example, and it kind of spider webs across the industry, impacting hundreds of organizations. And then who knows how many thousands of organizations are actually using those SaaS providers as well. So you can see how it can have a cascading impact across the entire ecosystem. So obviously, as DevSecOps DC, I definitely, my focus is often in the public sector with, federal civilian agencies or Department of Defense, for example. So I want to take some time to focus on, where the federal ecosystem is at and some of the activities that have occurred in this space. As we all know, the cybersecurity executive order served as a primary driver to, get the federal government focusing on software supply chain. And leading up to this, we had incidents such as SolarWinds, for example, and then, right on the heels of that, obviously came Log4j. not long after that, I'm sorry. So in May of 2021, we had the Cybersecurity Executive Order come out. Section 4 in particular focuses heavily on the software supply chain, and it tasks many organizations, in particular NIST, with doing certain things when it comes to software supply chain security. So NIST held various, cybersecurity supply chain risk management workshops. They published things like their new secure software development framework guidance. They also published, their new CSCRM 800-161 guidance that came out almost a year to the day from the Cybersecurity Executive Order. So we have a lot of industry guidance, or I should say government, guidance coming out around this, and government focus, which I'll be talking about more in a moment. So looking at NIST, as I mentioned, they kind of laid out different levels of maturity when it comes to software supply chain security. So if you look at this, they laid it out across 3 different levels of maturity, which are foundational, sustaining, and enhancing. And I kind of want to dive into these each a little bit. From a foundational perspective, they recommend using things like the secure software development framework to protect and respond to incidents around software supply chain. They recommend using, open source components or open source operating system components, for example, that are acquired via secure channels, trustworthy repositories. And then if you go on that, build on that a little bit to sustaining, they recommend doing things such as software composition analysis for in-house code bases, understanding, what components are we using, and are there vulnerabilities and risk associated with those? And then, ultimately creating and maintaining internal repositories of libraries of known good, open source software components that your development team may use. So rather than having a situation where anyone can go out and grab anything they want and simply use it, is starting to create that internal repository of known, open source software components and libraries that have been vetted from a security perspective. You feel comfortable allowing your organization to use those when it comes to risks that they may introduce. And then ultimately at the enhancing level, they recommend even shifting to more secure programming languages, maybe memory safe languages, for example. This is emphasized in NIST guidance, but you'll also see this kind of recommendation pop up in things like OpenSSF guidance, which I'll be touching on in a moment as well. And then automating that pipeline of collecting, storing, and scanning those open source software components and moving them into those internal repositories prior to introducing them into your development environments, and starting to get some security hygiene and rigor around how you use these open source software components. Then recently, I think it was about a month ago, roughly, maybe even less, a few weeks ago at this point, OMB, the Office of Management and Budget, released 2218, or more appropriately, was titled Enhancing the Security of the Software Supply Chain Through Secure Software Development Practices. And this is a very big one to pay attention to. What it is, it essentially requires all federal agencies within a year, roughly, to start to obtain self-attestation in terms of conformity with secure software development practices for any third-party software. They may be procuring from a vendor, for example, or a third-party software producer, start to require these attestations, showing that vendor or that third-party software producer is using things such as a secure software development framework. They're using things such as NIST Cybersecurity Executive Order Software Supply Chain Guidance, which NIST has published on its own dedicated website. You can go check that out. It even says that some agencies, maybe based on a risk assessment, for example, based on the intended use of the software, may require things like a third-party assessment or 3PAO to occur. If you think of things like CMMC, which has a third-party assessment organization kind of included in that activity, or things like FedRAMP, where you have a 3PAO, some agencies may make a determination on a certain piece of software or a certain vendor that they want a 3PAO. They want to accept a self-assessment. So this is a major change when it comes to the federal ecosystem of software consumption that's going to have a cascading impact across many vendors working with the federal government. It even goes further, saying that federal agencies may start to request SBOMs, software bill of materials, as we've discussed, in their solicitation requirements. So they may have RFIs, RFPs, and so on that start to require SBOMs, from these software producers, these third-party software vendors, and in formats defined as NTIA. So going back to obviously SWID, Cyclone DX, SPDX, for example, is going to be required in those formats the industry is kind of rallying around. Some other notable activities I want to touch on here is not just NIST, but other organizations like OpenSSF, the Linux Foundation, for example, have made some tremendous strides around securing open source software. In 2022 and earlier this year, the White House held what was called the Software Security Summit. They had groups, of course, like nonprofit groups like Linux Foundation, OpenSSF, and others, but they had major technology giants like Google, Microsoft, Amazon, many smaller innovative firms that attended this as well. And coming out of that, OpenSSF ultimately published what's known as the Open Source Software Security Mobilization Plan. And it kind of rallied around 3 high-level goals, which is securing open source software production, improving vulnerability discovery and remediation, and shortening the ecosystem response time when it comes to patching vulnerabilities in these critical open source software projects that thousands of organizations and millions of people are either using or depend on. And some of the key focus areas include things like secure software development education for developers and certification pathways. This is something that doesn't really exist, at scale across the industry quite yet. Other activities such as digital signatures, promoting things like SigStore. If you dig into the OpenSSF document, it emphasizes things like SigStore and trying to drive adoption of that across the ecosystem. It also talks about an OpenSSF incident response team. Many of these open source projects, as I mentioned, are based on volunteers or maybe limited funding and financial support. So having that OpenSSF incident response team of kind of software SMEs, software security SMEs that can go out there and respond to these incidents that may be impacting thousands of organizations. And of course, it also touches on SBOM. SBOM is turning up in every sort of guidance from NSA to NIST to OpenSSF and others. It talks about SBOM everywhere, producing SBOMs, and not only that, but producing things like attestations, showing maybe what build systems occurred on, the security hygiene of the system that the build occurred on, things like that. And it also talks about a risk assessment dashboard for the most popular 10,000 open source software projects. So understanding like how quickly does this open source software project respond to vulnerabilities. What level of support does the project have? How responsive are they? That kind of thing. So you get an understanding of the health, resiliency of an open source software project that you may be consuming. So we have guidance galore. We have no shortage of guidance. Just a quick list here. We have NIST Secure Software Development Framework. We have the supply chain levels for software artifacts, salsa.dev. NSA and CISA have produced their securing software for securing the software supply chain for developers guide. There's going to be 2 more guides that come out of that. Following out of that guidance from NSA. OWASP, of course, has produced the software component verification standard. CNCF has their software supply chain best practices guide. So look at this: NSA, CISA, NIST, CNCF, OWASP. We have no shortage of guidance when it comes to starting to secure the software supply chain, but we need to bridge that divide from theory to practice. And the reality is, this is going to be very challenging for many organizations. Maybe for larger enterprise giants, Google, Microsoft, Amazon, and so on. Maybe it's more palatable. But when you start to look at things like SMBs, for example, meeting some of this guidance without the internal in-house, expertise, resources, and staffing is going to be very challenging. So if you look at the, that LMB guidance, for example, we may see a situation where you have some consolidation or even lack of access to innovative SMB, software producers for the federal government. If we have to attest to these SSDF practices, these NIST recommendations that small organizations don't have the expertise, time, or resources to meet, that could be a challenge. Essentially, is going to lead to a situation that kind of challenges how much access to the software ecosystem and innovative solutions the federal government may have due to their security requirements. We saw this with FedRAMP and cloud, for example. To put it in perspective, there's about 20,000 SaaS offerings in the marketplace. But when you look at FedRAMP and the FedRAMP marketplace in terms of what's approved, there's a little bit less than 300 cloud service providers, many of which, of course, are IaaS and PaaS and so on, but of course SaaS as well. But so you have a 20,000 SaaS ecosystem, 20,000 providers out there of SaaS, but the federal government, from an authorization perspective, only has access to a very small footprint of that. So if cloud is, critical to innovating and national security and things like that, keeping access to that software ecosystem is critical. And some of these emerging security requirements are going to make that really challenging for many organizations and agencies to do. So that said, where do we get started? I want to talk a little bit about my organization and, some of the guidance out there that kind of recap all this as well. So as I mentioned from NIST and others, some of the key fundamental activities are including things like establishing a known trusted repository of software components for your developers to use, now allowing, just open poor hygiene where anyone can go grab and use any software component they want, any dependency they want, for example, starting to get some rigor and hygiene around that, creating capabilities around ingesting, generating, enriching, and utilizing SBOMs from an industry standardized perspective. Think of things like I talked about from SWID, Cyclone DX, SPDX. So industry rallying around those industry formats and starting to adopt those at scale. And then not only that,
Chris, we're starting to run into time here, so
no worries. I'll wrap it up. Any questions or whatnot, feel free to reach me at chris@acquia.us. I appreciate it.
All right. Hey, thank you, Chris. This was filled full of a ton of good information, and definitely recommend folks go through the slide deck because this is definitely a veritable cornucopia of information about supply chain and software, which is super important, as Chris kind of mentioned here. Well, right now we're going to be taking a short break, and we'll be back in a few, and we'll wrap it up with some of the final speakers, and we'll be right back. Take care.
Hello, everyone. Welcome back to the last session of the day, DevSecOps Days DC 2022 event. I know it was a lengthy day so far. I know we covered up a lot of topics. We learned a lot of good stuff from our practitioners as well as our participants. And now when we are going to the last day of our talk, which is minimum viable security, how to get started, it's kind of wrapping up a day, seems to me. We learned a lot of great topics so far, and Jason will be explaining his journey at the Highmark Health about the minimum viable security. Before handing over to Jason, I would like to talk about his background. And Jason, and he's the ITIS manager at the Highmark Health organization. And Jason, and he's responsible for governing and prioritizing secure software development and has been a key contributor in shaping the Highmark DevSecOps program. Jason's a manager within the Information Security and Risk Management Department at the Highmark Health, and one of the largest integrated financing and healthcare delivery system in the United States. So his problem is much bigger than what you guys are thinking about it, because he is dealing with many brownfield application as well as the greenfield application and applying the security into the DevOps process and practices. It's very challenging. I'm going to hand over to Jason for his great talk about where to start, what to do, what the minimal viable security means. Jason, floor is yours.
All right. Thank you, Hasan. Yes, I have quite some experiences with brownfield applications. So hello, everyone. My name is Jason Martin. I have nearly 10 years of experience in the field of information security, policy, and management, having initially focused my career on overall cyber risk and compliance for several years. I've now since transitioned to managing a team that's responsible for monitoring remediation for application secure code development. In addition, I oversee IT infrastructure vulnerability governance, as well as security hardening for IoT, such as medical devices. I am also a representative of Highmark Health. As Hasan had mentioned, it is the second largest integrated delivery and financing system in the United States. As an independent licensee of the Blue Cross Blue Shield Association, Highmark has a number of businesses growing in regional hospital and physician network among one of them. It's also comprised of leading companies that offer dental solutions, reinsurance, population health management, and health and wellness technology solutions. And yes, I've had to commit that to memory. It's not the first time I've had to rattle that off. And as mentioned earlier, I'm here today to discuss how to get started with incorporating a security framework into your CI/CD pipeline from a minimum viable perspective. I'll begin with a high-level overview of sorts of the journey that Highmark and our teams are on. At the time we began our DevSecOps transformation nearly 2 years ago, the organization was using a very traditional means of development. And not many at the time, from a leadership perspective, were using data efficiently that would allow them to be making better informed decisions for application security tools and training. Like most everyone else, when faced with that dilemma, we did an assessment. We had a third party come in, and the results of which they found that our development and our security programs were very much comprised of knowledgeable resources that were working very hard to satisfy the applications and infrastructure vulnerability metrics that had been set before them. But as you might assume, it was acknowledged it's not really enough for having your employees to try to do their best. They need to know what is expected of them and have the proper tools available, which at the onset of our journey was clearly incomplete at least from a security perspective. The assessment had also found that the architect and developers were given access to relevant documentation. However, that documentation was not always up to date. And additionally, the assessors had found that there were common issues such as there being times when a vulnerability could sit idle waiting to be claimed, which would increase the possibility of a service level objective being breached. It was concluded that leadership must encourage the creation of a culture that places a high value in building security in every stage of the software development lifecycle. And that would require acknowledging that this would incur additional costs up front, but that those investments would significantly reduce the amount of rework and exposure necessary downstream. I'm assuming that some of this sounds a bit familiar to those of you who have been doing this for a little while now, or maybe those who are just now getting into it. Well, anyway, that said, we luckily have had support from our leadership at various tiers of the executive structure. And now from that assessment, we had our case for change. Coincidentally, as that assessment had concluded, we found that numerous development teams across our diverse environment within our enterprise were already beginning the process of transitioning to DevOps as an operating model. So we had an opportunity to get security baked into the process a little early on during that transformation. However, our security team dedicated to the topic of AppSec is a relatively small one when compared to others in the organization and the development teams. So it was decided that the role of the application security program would be to govern the processes rather than conduct them. We would support universal adoption and realization of security testing and analysis of all digital products and services. In doing so, we formally transferred accountability from the security team to the development teams. And I'll go into more of that momentarily. To do that, we went about establishing new goals for the program. Chief among them was that we outline a framework for security to be included in the DevOps implementation at Highmark, which we did, and it was based on a number of respected sources like BSIM, NIST, HITRUST, to name a few. So having a framework for security to be included, that was established. The second was to insert ourselves into the various work streams in the software development programs to ensure up-to-date security documentation was communicated and reinforced, where it previously may have not been. And then lastly, we set a goal for standardizing the reporting, for measuring the secure coding activities so that we could properly monitor performance and whether we were achieving the improvements we were looking to achieve. Now, that's not to say that there wasn't reporting already in place, but it was disparate and in some instances nascent. And we have made incremental progress. That's really the theme of a lot of the work that we do, is incremental progress for each one of these goals to date. However, there are some elements that are incomplete, and for a variety of reasons, many of them operational. And this is to be expected for an organization that has been around for as long as Highmark has been, nearly 30 years, and has large of a footprint that it has. Now, where we are in our transformational journey. I've just explained, where we are up to this point. And I'm guessing you now want to know, how do you get started for your implementation? Learning from our experience, what is minimum viable security? How is it to be implemented, and how are you finding success in the program based on these goals? Good questions. But before I dive into the concept of what minimum viable security means, I want to go back to defining what we are trying to solve. In other words, what is the real challenge that we're faced with? So I'm going to ask some rhetorical questions here relating to the maturity of ours and and most other organizations who are either early on or in the throes of their DevOps transformation. The first is every piece of software and some component known? No. Do we understand what vulnerabilities are present in all of our applications? No. And are our app teams staying on top of resolving problematic software? The answer is no. We have a large footprint of legacy applications, all built at various different times, different forms of the organization existed that don't exist today. People that have historical knowledge are no longer here. There's a reason why these things have played out the way that they have, and it's common among other organizations as well. We're obstructed by a limited ability to identify and remediate our security risks in a timely manner because the application teams have an incomplete inventory, mapping to code bases, and therefore they do not know what all the software components are for the entire populations of applications. And the root cause is that, and at least as we got closer to the root cause, we found a lot of the security frameworks that have been applied in the past were bloated and difficult to apply quickly at scale. So why am I bringing this up? Why does this matter, right? Well, on average, nearly all companies are known to have a open source dependency in their code base. And when surveyed from an operational risk maintenance perspective, most of those open source dependencies are outdated, with many being several years out of date. To make matters worse, we're seeing an exponential increase in cyber attacks as well as software component vulnerabilities. Over half of the cyber incidents in recent years originated from breached software components. This threat is such a concern, it was explicitly referenced in the 2021 Executive Order on Cybersecurity. Now, these numbers that I'm showing are from an industry perspective, but I can confidently say that these percentages I'm showing should be considered likely reflective of yours and our code bases. Now, taking a step back from that doom and gloom, it's important to acknowledge that there are justifiable reasons for not keeping software up to date. But it's likely that a large percentage is due to the app teams not being aware that a newer version of a software component is available and not having necessarily the resources to prioritize which gets updated first. When we completed our first goal to establish a security framework for DevSecOps, we were all pretty satisfied with ourselves that we had been able to agree on collectively what the framework would shape up to be as it applies to our organization and its current state of being. But when it was presented, right, we included NIST, we included BSIM, et cetera, ultimately, the architects and developers came back and said, what do I do with this? Where do we start? How do I prioritize this? I've got all this stuff on my plate. You give me 100 plus controls. Where do we start? If self-developed applications continue to be governed by an overabundance of security controls, these trends will continue to impose a high risk to the business operations and app performance because they do not guide the business on how to prioritize. So what's the solution? I don't know the answers to everything, but what we've started to do seems to be working and make a lot of sense for our organization, and part of the reason why I'm here to talk about it. We asked ourselves, how can we simplify? Right? And so we distilled our objectives down to 3 questions that we tried to answer. Can it be secured? When we leverage new or existing technology, are the right controls available? How can we make it secure? Second being, is it secure? Right? Given the impact, are the right controls implemented for that technology today? And is it staying secure? Right? With the changes in the cyber landscape, technology and business needs changing, do controls need to be updated? In the process of developing tasks and deliverables to address these questions, we realized what we needed right out of the gate was an anchoring point. In other words, a frame of reference for where security fits into each stage of an application team's maturity during their DevOps transformation. We reviewed the framework we had developed and started to condense it down to an inventory of best practice baseline controls for security hygiene and avoiding software supply chain risks. In other words, we outlined a set of minimum viable security controls that defines the bare minimum amount of work that can be done by developers to make an application secure. That's it. That's the MVS, as we call it for short, the minimum viable security. The concept of MVS, or minimum viable security, for applications requires taking a look at security requirements the same way we would look at and develop applications. For the various business domains involved with application development to own responsibility of security, the process needs to work just like any other aspect that the dev team work on. It needs to start small, lean, improve in a continuous, agile manner, right? Incrementally, automating where we can as much as possible, and developing as code. What I'm presenting here is a dashboard that serves as an illustration of what the MVS can look like at a granular level per application. This is a condensed executive view, if you will, with certain controls removed for the sake of simplicity. However, it's meant to give the business and the development teams a sense of their security performance that is tangible. And what I mean by that is that it takes little effort to determine the actions required to drive improvements quickly. Because each dev team supporting the relevant areas of the business have their own distinct operating models and tools, they wanted to know, how does the framework align to that? We borrowed from the factor analysis of information risk, known as FAIR, the FAIR methodology, which promotes the notion of using a shared ontology in order to speak the same language across the different areas of the business. And that assisted us towards simplifying the expectations and making the controls more accessible. Ultimately, establishing a path for security to be addressed without the concern of breaking the rapid delivery continuous feedback model. Now you've seen what it can start to look like. We have requirements outlined. You can see some ratings associated to it as well. The goal is you want to improve your rating. That's will allow you to get to the next level of maturity in your transformation for DevOps. So what do we do? What does the business do? What do the developers do with this information? We got to talk about next steps. And it needs to be clear to everyone that just because you have it documented doesn't mean that you're over the hurdle yet. There'll, of course, need to be discussion about the acceptance of risk, documenting remediation plans, but that's not the main focus for today, and there's not enough time to get into the complexities of that. But it's important to acknowledge that there are many stakeholders involved in the DevOps transformation. Therefore, it's important to avoid operating in a silo, consequently ending up inhibiting collaboration between these groups. And in concert with the development teams, meeting with them on a reoccurring basis, we at Highmark produced a maturity curve for DevSecOps to pivot towards understanding and measuring and strengthening our AppSec processes to govern the requirements for developers and those who own the scan tools. We took it upon ourselves to assign responsibilities across these stakeholders so that the MVS data, the minimum viable security data collection, would be sustained and allow our security team to reinforce the program that we had set out to push forward now that we had redefined the governance model, reinforcing accountability through governance. This endeavor has helped the architects and developers establish business cases for tools and other resources they may need to effectively perform security activities where they may not have already. In doing so, on this slide, you can see our DevSecOps maturity curve that we had initially tailored for the organization. It's based on using industry resources to illustrate how to prioritize and drive security outcomes, and then inform application security metrics. The intent was to maximize the value realization from the implementation of application security controls in support of DevOps. We start easy on the curve. At the initial maturity stage, which we consider to be minimum viable, then moving along the continuum, hitting specific milestones. And we found that in some cases, as we communicated this model, this maturity curve, development teams were operating at different stages of the maturity curve than others. And that is perfectly acceptable. But overall, this is the set of expectations that we have mapped out for effectively determining the level of maturity a team is operating in. Since we're still in the proof of concept phase, we are only expanding the metrics for a subgroup of application owners in order to best determine the effectiveness of our plans to improve all the developers' understanding of what to achieve as they advance along the DevSecOps maturity curve. And like any good program, success is contingent on proper change management, and we're actively working to adhere to our developers' quality and delivery playbook as we expand communication regarding the cultural changes that will arise from these enhanced security expectations that would have to play out during the transformational journey that they're on. So let's recap on minimum viable. We're able to deliver on our 3 key program goals, which is provide a framework, communicate expectations, and measure performance. Our team has established the requirements and the associated measures in a format that is more accessible. But it's important to note that the better data we have, the more accurate the MVS model will end up being for our decision makers, our leaders, and those on the front lines tactically making improvements. And we're consulting with the development teams to validate that they're performing the baseline actions shown in the checklist for MVS. setting a checklist like that for yourself during the process of a framework adoption will certainly help clarify the path for prioritization for your teams and reduce the amount of frustration that often occurs when introducing new controls to your application development space. That said, we know that vulnerabilities cannot be effectively prioritized without understanding the amount of financial risk that they bring to our applications. And so to solve that dilemma, we are working on how to prioritize the work using the FAIR methodology, which I alluded to earlier, having used as our means to guide us on simplifying the controls to minimum viable. It's also a model that's used to quantify and provide qualitative risk perspective to the environment. So where it's no longer a grade versus a D grade, we'd like to eventually transition it to a common language of financial risk to again better improve the decision-making process. And there's lots of ways you can slice and dice your health status through the minimum viable security scorecard. You saw a version that I presented earlier that includes a view of a more granular by application. Here's another view aggregated up at the various business domains that these applications roll up to. The health status enables platforms to monitor their performance. It makes them better informed so they can alleviate vulnerabilities faster and reduce the instances of vulnerabilities in the first place. Measuring defined security posture requirements and best practices against the various platforms on a recurring basis. There are still some challenges we are aware of. Components of the DevOps model, automation is still being fleshed out on a subset of the development teams. And so without that, we cannot achieve certain levels of maturity on the curve beyond what would be considered fundamental for application security. But due to our using the MVS and applying it, we've identified these issues, communicated them up, and the app teams and leadership now have initiatives underway to address those gaps. That is my conclusion of the review of minimum viable security and how you can get started to implement it for your organization. I've provided some resources at the end of the deck here, and I'm sure you will find it useful when it's hosted after the conference. So thank you, everyone.
Thank you so much, Jason, for your journey on DevSecOps implementations. I know it's a lot to talk about for your lesson learned and some sharing practices as well. A couple of things like really struck me in your journey. And first was getting a C-level support. I guess C-level support really helped you a lot, right, to get DevSecOps journey started. Can you open up how much you're able to get support? That's really one of the blocker I had been seeing in our organization. I guess that's one of the things that you got in your organizations.
Support's an interesting word.
That's true.
You know, it really helps when you have your senior, leadership understand what's at stake. And I think that we're fortunate to have a CISO in our ranks that does a very good job in helping communicate those risks and showing, based on the data that we already have, what could happen if we don't take action. And being in a healthcare organization, having a constantly looking for what's new, what's fresh, I think that helped as well. And saying, hey, things need to change. We can't keep using the same scalpel from 30 years ago. we have to, move on to something better so that we can better serve our members and our patients. So I think the combination of having good communicators who are in tune with the industry and being in an environment where change is welcome certainly helped.
One more questions on the C-level support. Actually, you gave a good analogy on race metrics as well, which goes back to it is not the one person's job to get the DevSecOps. It is a combination of the people. Do you see any struggling or some pushback on your race or recommendation? Like you put some responsibilities on developers as an example, but keeping information security folks as an inform. I know we're expecting everybody's contribution. Sometimes still we may get a pushback from team members. That's not my job or I'm busy. I'm assuming other team members will help to the developers to plan accordingly, right? Do you see support from each other? It's not race is not giving a siloed recommendation for the people. Race is more about distributing the MVS to the many team members, right? Can you open up a team distribution or support distribution amongst other stakeholders instead of just focusing developers?
Yes, and part of it is about the concept of security champions, right? To support that, but I do want to add, I can't tell you how many times I've drafted up racy matrices, and I had to stop myself from making a more in-depth one for this presentation. Is that a lot of the R and the A is shared, and a lot of the C and the I is shared, and sometimes you're informed and accountable to an extent. So my experience has been the pushback is more just a lack of confidence from what they've experienced historically. And so a lot of it is trying to demonstrate to them that what maybe didn't work 5 years ago or 10 years ago when they were in that space doesn't mean that won't work now, right? And in addition to that, really, a lot of the way it was operating was, hey, here, take this on and I'll see you later, right? Do this control, we're gone. It's now a matter of we're in this together. Let's figure it out together. Let's brainstorm on it. Let's work on the business cases for these tools together, as opposed to working in a silo where they have to then present to finance, as an example, to get a new enterprise license or expansion of enterprise licenses for a security testing tool. Without security at the table, they can't really have a good conversation with the finance team to convince them. So we're working on, how do we be involved increasingly in the everyday activities of these teams. I did reference earlier, we're meeting with these teams on a near weekly basis, where a couple of years ago that wasn't the case.
I guess this is going to get more about the team and developer support for your journey, and you will get more implementations. I have one more question while we wrap up the sessions. Then I have one more topic to really cover up. In your DevSecOps journey, again, Jason, there is some brownfield application that you have been dealing a lot. And I'm assuming those applications has a different pipelines, right? They have different type of CI/CD practices. So how you can merge those different pipelines? Every pocketed developer, they have their own pipelines and versus a generalized pipelines. And as a security expert, do you see a problem having a multiple pipelines to look at some of the dependencies and examples, some of the implementations? What is your take on multiple pipelines, Jason? What is your recommendations? I know it's a very hard problem to solve, honestly. I'm just looking for as an expert in your security, what is the right ways to get multiple pipelines or a single pipeline, or what's the right thinking?
I think everyone's ideal state would be a single pipeline. I think with the size of our organization, and the different operating maturity levels of the different business domains, that's not a reality that can be sustained. I think it's more important to focus on, you can have multiple pipelines, but ensuring that the policy structure impacting each pipeline is the same from a security policy perspective. And ensuring that where as much as possible, such as simplifying the how many libraries are in use from a dependencies perspective, will help alleviate some of the concern of having multiple pipelines. But I don't see a way of operating, at least for an organization at our age, with just one.
Thank you so much, Jason. It was a very enlightening talk, and I'm glad to hear that your MVS journey with the DevSecOps. I really thank you for your participations. I'm looking forward to maybe more sessions for really get to learn your metrics pieces, because that's another things we didn't open up yet today. Maybe another session we can discuss on the scorecard, because scorecard is another way to motivate, incentivize the people to the better security. Maybe we can open up the more topics later on, but thank you so much for your participation today, Jason. Was very well and shared very well, discussing the DevSecOps topic, so we can wrap up to today's sessions. That said, so let's go at today's session, what we really learned so far, and in terms of the DevSecOps journey and what we cover up in terms of the overall sessions today. So with that, I'm going to share our lesson learned, and I'm hoping that will be useful for everyone and for the DevSecOps implementations, and as well as the many talks. So as we kind of so far as the day goes, and we did a visual recording, so I'm going to share my visual recordings, and we can go from there. Let me share my screen as well. All right, so really what we did so far, we really discovered a lot of topic as today. So we started about the welcoming as DevSecOps Days was a 2022 events. And by the way, today is October 12th, and this month is the Cybersecurity Awareness Month. So, and now it is not a developer-centric work we are talking about. It is basically responsibilities, everybody's role in getting secured into the software engineering practices. As Jason said recently, and everybody's responsible somehow. Everybody's accountable, and some people has to be informed, but overall, we all responsible. That's what we clearly discussed and throughout the sessions today. So we started with a keynote and from Kyle Fox, and Kyle was talking about the software-defined weapons, and he really get into the, how are we getting this software, get into the weapons, and what techniques we use, what the demands are, how can we really address the threat analysis, and some a new threat is coming up, new software is coming up, and now we are going to the more speed-oriented delivery and deployment in the weapon system. And he really shared a lot of good insights how DevSecOps is helping such a high-regulated organizations get into the life cycle using the DevSecOps principles, be ready for any deployments, or be test early in the life cycle, or get a lot of artifacts from the life cycle perspective. We can be ready for resiliency perspective, for audit perspective, for other work perspective. It was a perfect example that he shared his journey and how DevSecOps is playing a key role for resiliency, for system safeties by using the platform, by using the concept of the mindset of the cultural elements and other capabilities. And he really created that DevSecOps as the one for the IT and getting better job as software-defined weapon system as we are moving forward. Then the next topic was from Jeroen Williams, and actually he opened up a very interesting topic. There was the one topic, and I presented similar things in the couple of years ago, and most of the vulnerabilities we kind of ignored. It is part of the deployment scripts. It is part of the secrets, how we manage those secrets. How are we getting those secrets into our deployment practices? And Jeroen was really highlighted the great concept, and even though he shared the OWASP projects and of the things about how can we really use the kind of a framework and manage our secrets in our deployment practices. I knew we do a lot of the code bases, look at the static analysis, dynamic analysis we do, but we often ignore the deployment aspect of it. And Jeroen reminded us to use the framework, it's available, or the vault mechanisms, and some other capabilities, and to keep the code securely using our secrets and secure environments, so we can really secure deployments, or we can protect our assets in infrastructure layers. Like we can do great secure coding practices. If we don't do a job on a well in our infrastructure pieces, we will fail miserably. So he opened up that discussion. He gave a lot of tips and ideas on how we can manage the secure keys, on how we can manage our deployment scripts, how we can really address the secrets in a proper way in our pipeline perspective. Then we start to move into the product features about how we can be getting the products and security as part of our life cycle. Now, and Mark gave a good insight in creating a value concept, because typically the security world, if there is no value that we heard about many, many times throughout the day, how can you justify your value with respect to security? And Mark gave a good tips about the common frameworks and ideas describing as security as a value, as a product that can be part of our life cycle. But to define the value, really we have to start from iterative approach, so looking for the threat analysis, looking for the reasoning, then we can add the value into security as throughout the life cycle. Start from the why, start from the risk management perspective, define what that means to the organizations. He gave the tips about the many frameworks, even though he shared about the capability metrics on the effectiveness of DevOps and how can we share the measurements and metrics pieces that can kind of value of the secret that can be part of our product. Then another thing, actually, he said a very key point, I completely agree, and I'm sure all of us agree as well. Basic empowering the team, they can do their own job as well as primary approach. We don't want to be enforcing the team to do this, or make it a part of the team, empowering team by giving enough resources, enough structures, they will be ready to achieve their security practices as part of the DevOps pipeline. And next talk was really talking about the cultural shifting, and from Joel. And Joel was great example he gave us about how can we change the cultures, how can we change effective culture as a learning culture. One of the benefits of DevSecOps, honestly, is creating a learning culture. And he said a key point, and actually I'm a faculty member at the CMU, that kind of resonates me. The most of the classroom learning, it is not staying forever. It's just the 90 days, maybe a 6 month, because we're not practicing what we are learning at the classroom. The key point is here, we have to build up some sort of a culture organizationally. We can learn while we are building. We can learn in an environment, we can practice. And I saw a great example, if organization does a great DevSecOps or DevOps implementation, they're able to learn much effectively, and they can gain some skills as an organization so we can grow our knowledge pieces. Really, continuous learning is one of the fundamental outcome of a DevSecOps implementation. And we're going to learn from our failures, which is impacting our pieces, or we're going to learn from our mistakes or writing a secure coding. It's just a learning. Learning has to be on demand, on time, that it really create a lot of cultural sense with respect to learning and how it's really helping for organizations. Then when we move to the afternoon sessions, and DJ started a provocative title about the software bill of materials as the Battle of Monkeys. He opened up an unknown secret about SBOM. I know everybody's talking about SBOM. Everybody's really talking about creating an SBOM or generating a SBOM file. But there are a lot of problems we may not aware of it, or we never think about it, or we never seen yet. Like basically dependencies. He talked about a lot of dependencies in our SBOM component we don't know. Like we have some the dependencies, interrelation dependencies, kind of connecting each other. That he gave an analogy of the monkeys, right? We know it's kind of connected, but there are a lot of dependencies are connected to each other. How can we solve those dependencies? How can we look at the vulnerabilities? And how can we make them more effective in our lifecycle perspective and creating the SBOM, maintaining SBOM, integrating SBOM into the pipeline? He said the key word about the maintaining is really not the creating an SBOM. We can do that, but after that, we have to maintain those SBOM files as integrated into our pipeline, which is CI/CD pipeline. We have to integrate those. We have to look at the runtime dependencies. We have to also look at the build dependencies in a software perspective. We should be ready about unknown things. We should be ready for the vulnerability perspective for each of those dependencies of the SBOM files perspective. Then we move into another interesting talk, which is more about the workforce on unicorn cultures, right? And I heard so many organizations are hiring a specific personalities that knows everything. it's a failure. And Alex told us it is a bad strategy. Hiring a person knows everything. That's not practical. But versus we have to build up a team, that teams are interacting each other, teams are talking each other's, and instead of building a unicorn individuals, let's build up a unicorn culture. Unicorn culture really helped the organization to grow, to learn, to share the information each other, instead of hiring a very individual persons that knows everything. It's not practical. I'm sure you heard many novels and maybe other things, article we have read so far. Like, we don't want to be a person that knows a lot, then our organization will depend on that entity, but make it a team effort, build up a team structure, build up a great terminology so everybody can contribute into a team. That team can be a unicorn. That was a great talk from Alex, and talk about what the security means, what the security unicorn means, and sharing the team as a security unicorns, not an individual. That's another statistic I would like to share here. As based on the survey, there's one security expert, there are 100 developers. It's not really practical to get a unicorn security element as well. We have to use as a team structure, build up our unicorn strategy as a culturally, so we can build up a great DevSecOps unicorn culture. Then we move into another interesting talk about engineering excellence in DevSecOps, and we should talk about how the productivity means, how can we do some assessments, how the infrastructure will help us on the pipeline perspective. There are some challenges on DevSecOps environment, like maturity, or using the developer effectively, or using some sort of a comparison, some smoothing architecture, some value at risk. He really gave a good insight wise in thinking about software development evolution, how we start from the customer development, how we get into the infrastructure pieces, then we can build up some maturity with respect to the lifecycle perspective. Then he shared a good insight, good challenges, and good recommendation. And from product to the project to product, or product or developer, and velocity, code quality, and security was a keyword that he shared on his talk. Then we move into the interesting talk from Chris Hughes and talk about the software transparency. That's another related topic on the SBOM, but we have to look at the software supply chain perspective. What that really means, organization. Are we ready as an organization to know all our dependencies? How are we acquiring? How are we putting in our life cycle? What does the strategy looks like? What type of tools and techniques we can use? How can we really shift left our vulnerabilities and bug tracking into the environment? So these are the great topics that he has shared with us with respect to this, specifically on implementation, software bill of materials, and secure and digital supply chain as throughout the life cycle. He gave a good tips on using the many other framework, but the main framework has to be aligned with our organizational structure, building of a secure infrastructure and building of a secure software on top of it. Then we can build up a good software supply chain practices from inception to the deployment with the great ideas that he shared. When we wrap up the day, and I have the visual recording, but I get the one screenshot from Jason's talk about the minimum viable security scorecard. Now we learn a lot of topic, but how can we start? What the problem that we are solving? And Jason shared this story from Highmark Health perspective on how can we define the minimum means. We cannot ask every developer to do the secure code development right away. Maybe much easier for a greenfield application, but such a big enterprise, there are many brownfield applications. It's very, very difficult to add security implementation into their life cycle, into their case or the daily duties on writing the code. Now he built up the MVS concept, studying what the minimum viable security means in an enterprise. Let's try to implement those. When we implement MVS into the organizations, let's define who's going to be responsible, accountable, or inform, or owner. So he created a basic concept, and along with the MVS, and put the organizational construct, who can do for what, and everybody has to do some sort of a minimum viable security into their life cycle. Like I'm a developer, I'm going to look at the secure coding, but the project manager has to define and allocate the time so developer can do coding as an example. We give a good example about the relationship, the team construct, and also what the minimum viable security means. That was a good talk, and wrapping up the day, where to start, how to implement. That said, as we are moving forward to the cybersecurity month in October, I would like to announce there is another DevOps event is coming up, which is All Day DevOps. Will be November 10th in 2022, which is almost a month and a half almost a month from today. So we're going to have almost 180 speakers, 24 hours. I really encourage all participants, please part of the All Day DevOps event. It's free, and you will get a lot of exposing into the practitioner perspective. Remember, it's a continuous learning. This is another opportunity for you to learn from the practitioner, improve your security practices, improve how an organization does. You will see some connection what you are doing. Again, we're not copying and pasting how our organization does, but we are learning how to approach the culturally, how to train the team members, how to solve some technical problems, how to configure the tools, how to share the information with SBOM or the vulnerabilities. Many other topics will be discussed on All Day DevOps, and looking for many participants as well. That said, and I would like to share a couple of URL as well. As I said, this is a continuous learning. Today is not the end of the DevSecOps, it is growing. I really encourage all of you look at those resources from SEI website. They're all free. It's available based on what we learn, what we gather from information, from our experience, either the blog posts or podcasts and webinar. Please look at those examples and be part of the communities by learning or by sharing your stories. If you have some stories you would like to share with us, I'm happy to listen and talk about your stories, and happy to really have you explain the stories or get a lesson learned and discuss or share with the community as well. That said, I would like to thank all our sponsors, and from Highmark Health as a communities and Security Compass and Aqua and other team members, and offering a really work for the overall support as an organization. Thank you so much for a great support today, and thanks for participating in the event. And that said, thank you for all your participants. And I would like to thank you, SEI team as well, a media broadcasting team. A lot of people have put their effort and time and energy to make that happen as smooth as possible. I would like to thank you, all of you, be part of this event. Please reach out to us for any question that you may have, either directed to me or info@sei.cm.edu. Looking forward to have another session with all of you. Thank you so much for attending DevSecOps Days today. Thank you.